Okay, I think we're live. Okay. Sorry, I know no one's watching this right now, but I'm just trying to figure out. I can't get chat open right up here. Yes, Rojan. Sorry, just figuring all this stuff out right now. Um, hello. Okay, all right. To the two people watching, and I think one of them's me. Wait, this is how this is mute. I need to mute this thing. Okay, so hello everyone. I know no one's here, but today, I'm going to be doing math until I mentally break down. I have a lot of punishment set up if I get any question wrong. Let me pull up what the punishment wheel would look like. So, I have the punishment wheel right here. I have different things such as doing the next problem blindfolded, having to drink salt water, eat hot peppers, do a problem on a pogo stick, wear oven mitts, eat a whole lemon. I tried my best to think of a lot of things, and if anyone else thinks of some things, I'd be happy to do them in case I get them wrong. So, yeah, that's what I have in store. Please feel free to suggest any problems or any topic. Uh, I plan to just do as many problems as possible. Maybe like I want to study some other topics myself. And yeah, I have a lot of Red Bulls. Please sponsor me, but that's not gonna happen anytime soon. All right, so let's start off. I think it's best to start off with what this channel name actually is, and that's Calculus with Caleb. So why don't we actually start off with doing some calculus. All right, hold on, let's go take a sip of the Red Bull. Yes, we have some more people watching. I'm so excited. On my iPad here, I just have a lot of questions that I spent time curating. I haven't done any of them. I just have them pulled up. Okay, so I think I'm gonna do this in Black. Where should I set this up? Actually, hold on. Yes, this is better. Okay, so if we have y is equal to x sine x, then what is the derivative? I actually need to figure out, like open up like the answer key too to some of these in case I get them wrong. Well, I don't know. I need someone to fact check me. So yeah. So to take the derivative, we would just multiply both sides by d over dx. Then we would have dy. Make sure you can see this. Dy over dx is equal to, and then that's this part, and then this is x times sine x. So x is its own variable and sine x is another thing. So we have to do something called the product rule. We can't just take the derivative of this. We have to do this special rule where it's you take the derivative of the first multiplied by the second times the derivative of the first. So the first would be x. The derivative of sine x, I believe, is, yes, it's cosine x. And then plus the second, sine x, times the derivative of the first, and the derivative of x with respects to x is just 1. So then our final answer should be sine x plus x cosine x, which I think in this case would be b. So this be our answer. All right. That's one problem down. Wait, I already have question one set up over here. I don't know OBS. I need Miranda to help me. Um, can you guys hear me okay? I think Roshan would be the only person to actually respond, but Roshan, can you hear me all good? Okay. Sounds crisp. Okay, thank you. Thank you, Arya. Thank you. Okay, great. Great. I figured out how to actually open it up so I could see you guys. All right, that's one problem down. Let's go on to the next one. Oh, also another challenge I have set up is I will do the ice bucket challenge right over here. Let me show you guys. I have a bucket filled with water, and then when I actually have to do the challenge, I'll fill it up with ice so that you guys actually believe me that it's cold water because I don't know how long it's gonna be till I get that, so I didn't want the ice to melt. So we have that. I have blindfolds, and then I have my pogo stick. I don't even know how I'd actually do problems on the pogo stick. Oh yeah, that's not happening. Okay, we'll save that for later. Save that for later. Okay, next question. Okay, so this question is, let me just write down the function first. These are again all calculus topics. If you guys want me to switch anything, just let me know. 300 minus x cubed. So this question asks when the let f be the function given by this function, on which of the following intervals is the function f increasing? So when you want to figure out if a function is increasing with calculus, what we have to do is we take the derivative, we set the derivative equal to zero, and then we figure out if like in between those points if it's positive or negative. And I'll show you how to do that. So to take the derivative of this, in case you don't know the notation, we would just write f prime of x is equal to the derivative of 300. That's just a regular old number. There's no variables in there, so that would just go away. And then the derivative of negative x cubed, if you remember the power rule, you'd bring n down and then do n minus 1. So this would be negative 3x squared. Okay, awesome. I believe that's. Oh shoot, sorry, my bad, guys. There was a there was an x right here in the 300. Rewrite this x minus cubed. So then this would actually just turn into 300 minus 3x squared. Okay, so now we could set this over to 0. So we say 0 is equal to, actually, I'm just gonna, just to save some space, I'm just gonna turn this into 0. And then after this, let's move, we want to try to isolate x. So let's move this over to the other side to get it all positive. So we have 3x squared is equal to 300. Divide both sides by 3. X squared is equal to 100. And then we take the square root of this, and then the square root of x is x, and the square root of 100 is plus or minus, oh shoot, x is equal to plus or minus 10. Okay, awesome. These would be uh, these would be critical points for the, hold on one second. I prepared for this. All right, sorry guys. There's an Amazon package. So anyway, like I was saying, Now, the next step in these types of problems, when you're trying to find whether or not a function is increasing or decreasing, is we use a number line. So I don't know if I can move this. I don't know how that would look actually. I'm gonna keep it like this. So then we would have a number line right here, and I would put -10, because remember it's plus or minus 10, and then I would have +10 right over here. Let me like, hold on, I'm still trying to figure this out. Okay, and then what I'd do is I'd look for points in between this, in between these two numbers, and some easy points here. We have -10, 10. In between those would be 0. -10, I have like -11. And then I have, what I could just do like 11 here. So then all I have to do is actually there's another, I could just factor this out right here actually. 3, and then I put 100 minus squared. But then I could just plug it. This is just a factor version of this, and I just see whether or not this is positive or negative. So if I plug in -11, I'm gonna have negative squared, and then that number is going to be bigger than 100. So this is going to be negative. And then when this is 0, this is going to be positive. And when this is 11, it's going to be the same thing. It's also going to be negative because of that minus. So that means it's only increasing from -10 to 10. Yes. All right. Cool beans. Cool beans. Um, why is this stuff so hard? Okay, there we go. All right, that was problem number 2. Me. Ooh. Ooh, okay, this one's a good one. I might need to review my integrals and derivative rules because it's been a while since I've done any sort of calculus work. So this next one, I'll do this in part two, I guess. Next one is saying the integral of secant x and x dx. Okay, so let me see. I know we're gonna have to. Oh wait. Isn't wouldn't that just be like, yeah, wouldn't that just be secant? I believe that would just be secant, right? Secant x. Actually, since someone's asking any questions, I'll just use this time, I guess, a little bit to review some of my derivative and integral rules. Just write them down. So, like, I know there's dy over dx minus u is equal to cosine u is u prime, derivative is equal to negative sine u times u prime. The derivative of tangent u should be, I believe it's secant squared u. Do this. Hmm. Okay, cool. That's right. And then have the derivative of cotangent u should be equal to negative cosecant squared u as u prime. And then some next ones. So then, oh, this is not dy. This is d over dx. Secant u should be equal to secant u tangent u. All right, and then I think for cosecant should be the same. Cosecant u negative cosecant. And then I think the last ones that I know I need to write down are going to be derivative of arcsine that should be equal to and oh sine square root 1 over square root of 1 plus x, right? No, no, it's 1 minus, it's 1 minus. It's 1. Yes. Okay, hold on. I need to just do one little thing, guys. Excuse me. Shion, if you're still watching, I'm sorry. YouTube won't let me enable donations. Very sorry. What? You posted my stream link? Oh my gosh, 10 upvotes? Okay. People join. Yes, guys, spread the word. Spread the word. Um, okay, so I'm just trying to like review some of my like trig rules. So then if this for sine for cosine it should be the same except cosine should just have a negative in front of there. Yep. And then tangent is just there's no square root and it's a plus there. So we're all we're all good. Right. Okay, cool. I think that was a nice little refresher. It's gonna take me a while to do erase this stuff every time. Do, 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 do. Okay. Okay. Um, let's go back to the calculus problems. Okay, this is a nice, easy, fun one. I think we're just kind of working our way. We'll get hard as we go. Also, I wanna review some of my BC topics because I kind of forgot how to do series and all that stuff because I rushed that stuff at the end, and I'm like annoyed at myself. So in this question, we have f of x is equal to 7x minus 3 plus ln x. Ooh, plus ln. And the question is asking, what is f prime of 1? is equal to what? We got three question marks there because we don't know what it is. All right, so with these types of problems, um, basically this prime just means that's the first derivative. If there were, for example, two dashes right here, that would mean the second derivative, three, and then I think after three they usually just put a number like four or five or six because that's way too many dashes. And then once we have the derivative, then we plug in one because a lot of people make the mistake where they plug in one first and then they take the derivative, and that would just give you a very wrong answer. So this looks like a pretty simple derivative. So we have f prime of x is equal to the derivative of 7x is x to the power of 1, so that'd just be 7. And then this 3, making sure there's not that 3 would just go away because it's a constant. And then the derivative of ln x is u prime over u, or like the derivative of ln u would be u prime over u. So x prime, this is the u right here. And the derivative of x with respect to x is just 1 over x. And yep, that's the derivative. And then they want us to plug in 1. So move over here. F, oh my, what was sticking full? F prime of 1 would be equal to 7 plus, and then we plug in a 1 for this x, plus 1 over 1, which is just 1. Why was that so? 1, which is equal to 8. And again, I believe that's right. It should be right. Okay. Let me we're on question 4 now. No, 3, I think. Okay. Hey, this one I would love to show you guys, but I don't know if it's like a graph question, so I don't know if I can do this. Oh, total distance equals. Oh, okay. I believe I remember how to do these questions. These are all directly related to AP calculus, both AB and BC, but this is more leaning towards AB right now. I'll try to do some BC questions later if the two people watching want to ask. The people I respect you, okay? Um, okay, cool. Okay, so this is saying the question says that a particle moves along the x-axis and that the velocity of the particle at time t is 6t minus t squared. Okay, and it's saying what is the total distance traveled by the particle from time t equals 0 to t equals 3? Okay, so we're looking for total distance from t equals 0 to t equals 3. Actually, just put like a. Okay, so, excuse me. So with these questions for calculus AB, the way that they work for these like velocity particle questions, you can, if you don't know, the way that things work is you go from distance, you take the derivative of distance, and you go to velocity. You take the derivative of velocity, and you get the acceleration. And same thing if you go backwards. If you take the integral of acceleration, then you get velocity. You take the integral of velocity and you get acceleration. I mean, sorry, you take the integral of velocity and you get distance. So with these questions, this time it's asking us to move backwards. So we have velocity and they're asking for total distance, so that means we need to take the integral. So I think the only way to set this up is that you would just take, because this would be equal to v of t. That's the best way to think of this. This would be equal to v of t. And then we just integrate, if we integrate v of t with respects to t, we should get we should get d of t, right? But if we put in these bounds, because we're looking for the total distance, not like everywhere, we're looking for the total distance from t equals 0 to t equals 3. So like think about it as a number line. And we're just asking for how far the particle traveled in this little section of the number line. So what we do is I take the integral of 6t minus t squared, and then we put in these bounds. So this from t equals 0 to t equals 3. Don't forget the dt because this is with respects to t. All right. And now we do that. Okay. So if you don't remember the power rule for integrating, you add 1 and then you divide by it. So like for example, if I have the integral of x squared dx, the integral of that would be equal to x cubed over 3 plus c. So you add 1 and then you divide by it. So this is just like, it's really bad. Okay, so for this situation, 6t, the integral of 6t. You can also, by the way, you could split this up into two separate integrals. You could put an integral right here because this is a minus. You could do the same thing with an addition sign. You just can't do it with other things. But we're just gonna do this in one shot because I don't want to do that. So 6t, so t is our variable because it's with respects to t. So we'd add 1, so that'd be t squared, and we divide by that. So then that would be 6t squared over 2, okay, minus t cubed over 3, because this is the same thing over here. It's just with t's instead of x's. And then I'm just going to simplify this to 3t squared, just to make my life a little bit easier. We have 3t squared. And then what we have here, actually, that's not the notation. You just put a line over here, and then we have some 0 to 3. It's gonna, oh, we got 3. Okay. So from t equals 0 to 3, so we go, it's f of b minus f of a. That's one of the fundamental theorems of calculus. I'm gonna get down on my knees. Okay, so we plug in 3 everywhere we see a t. So we'd have 3, why, oh my gosh. We would have 3 times 3 squared minus 3 cubed over 3. And that'd be one section. And then we'd have that minus, and then we have 0, 0. But when we plug in 0 for these, it just everything goes away. So this will be our final answer. So 3 squared is 9. 9 times 3 is 27. Minus 3 cubed. 3 squared is 9. 9 times 3 is 27. 27 over 3 is 9. And then what is that, like 18? Okay, that's an option on the thing. So no one's fact checking me yet. So I'm gonna say the answer there is 18. Until like there's more people and I can actually get fact checked, because I'm not gonna be doing these punishments if no one's seeing them, because then there's like no point. Okay, cool. Ooh, okay. So this is saying that if y equals parentheses x cubed minus cosine x root of 5, then what is y prime? Okay. So for this is just the power rule. I think I'm just gonna explain these because it makes it go by a little bit quicker. So if I'll do it over here in the corner. So if I have, for example, if I have y is equal to, I'll put it in parentheses, like if I have x squared. Okay, the derivative of x squared, the rule is that you bring 2 down and then do 2 minus 1. So y prime would be equal, I bring the 2 down, I'd have 2, and then I leave the x alone, and then 2 minus 1 is just 1, or you could just leave it like that, and that would be the derivative. So in this case, this whole thing is our x, and that's what we leave alone. But the problem with this is that this actually leaves out something. That's why I'm actually gonna do this again in terms of u, because that's actually a better example. Because if I have y is equal to u squared, and then I take du over d, or no, dy over du. Wait, no, no, wait, no, sorry. Yeah, dy over du would be equal to 2u times u prime, because there's always you always have to add that prime at the end. That's what a lot of people forget, because when you do things in terms of x and you're deriving in terms of x, then the derivative of x is just 1. So a lot of people forget that when you have other things in there, you actually have to work it out. I'll show you what I mean. So in this case, y prime would be equal to, I bring the 5 down, 5, and then I leave the inside alone, multiply this by to the power 4, and then I have to multiply this. You have you have the answers. I do have the answers. They're just scrolled down all the way. So I would just like, honestly, let me scroll down and just take a screenshot so I can refer to that quickly. Yeah, that's a good idea. Here. Okay, I just took a screenshot of the answer key. I'll have that next to me. Thank you for asking that. I was waiting for someone to fact check me on some things. Do, do, do. Okay, great. So for this is question 7. So let me make sure I have. Okay, cool. So, all right, great. Okay, so then we have to multiply by the derivative of the inside parentheses here. So I'm just gonna add a little dot here, and then I love that you're doing this. Thank you so much. Thank you so much, Cat Math Tutoring. Yeah, I just want to do this for fun because I really do love math, and I always said that I think I could just do math forever because it's not for me, it's not a punishment, it's a pleasure. So I just want to try to do this just to kind of bring like just to have some fun. That's why I have these punishments set up, just to keep it interesting for me and just for the audience. But the main thing about this is just doing math, doing questions, practicing. I have next year I'm going to take linear algebra, so I have a linear algebra book down here that I might start to study a little bit when things get a little bit slow. But I hope to do a lot more. I hope to do many more videos in the future. So thank you. I appreciate that. So, multiplying by the derivative of this. The derivative of x cubed is going to be 3x squared. Remember the power rule that we have over here. And then again, with the u prime, what's the u prime here? But remember, if we're deriving this in terms of x, so for here, the derivative of x is just 1. So there'd be technically an invisible times 1 here, but no one just no one writes that. But it's important to understand that so that in future problems you don't get caught up with those things. And then we have a minus here, and then the derivative of cosine x is going to be negative sine x. One tip is that when you take the derivative or integral of anything cosine or cosecant, the answer will always have a negative sign. So this is going to be minus, and then parentheses, a negative sine x. Now, in this case, I'm just going to simplify this a little bit. 5x cubed minus cosine x to the fourth. And then this is going to be times 3x squared plus sine x. And I believe, let me look at our answer choices, seeing if they want us to simplify anything. 5x. Okay, cool. Let me just check with my answer key. 70. Okay, got that one right. Nope, no punishments this time around. That's good for me. Let's see. Ooh, ooh. What I want to do, might do that later. I don't know. I kind of want to do a Riemann sum question, but I haven't done them in a while. but this one's a right hand, so maybe I'll do that one a little bit later. Do that one a little bit later. What is the area? Oh, cool. Okay. This will be question, I believe. Okay. So this question is asking using the substitution. So in case you for this is a U sub question. It's that's just slang for that's short for U substitution. Saying U is equal to the square root of x. Then, comma here, the integral 1 to 4 of e root of x over bx is equal to which of the following? Okay, f f of x is equal to 6. What is the derivative? Okay, well, Dr. Howard Kasnov, in that case, when you have a constant, so I could have I could have f of x is equal to like I could have it equal to 1 million, right? If I take the derivative of that, the derivative of any constant is equal to 0. In this case, f prime of x would be equal to 0 because the derivative of a constant would just be it just wouldn't be there. You could think about this in terms of a graph. So for example, if I have f of x is equal to x squared, right? The graph of that kind of looks like this. It's a smiley face, you know? And then, sorry, let me just erase this. But then if I take the derivative of this, if I say f prime of x, that would be equal to just x. And x is, as you should know from algebra, is just a positive straight line like that. So when you take the derivative of that, we have f double prime of x, because in this case, after that, that would just be 1. Then I just get a straight line like this. Okay? So when I take the derivative for the third time, it's just going to be 0 because you can't go anywhere else from that straight line. So you can think about that just in terms of though the derivative of a constant is always 0, or you could think about it in terms of a graph. As you take the derivative, the slope changes, and if you think about how the slope changes, then you understand that once you take the derivative of a constant, you can't go any further than that. So I hope that answered your question, unless you missed a little thing in that. But from what I could see, it just says f of x is equal to 6. So the derivative of that should be 0. All right, that was a little bit of a long, convoluted explanation, but I just wanted to explain it that way because I think it's cool for math when you can think of things in different ways and get the exact same answer. It helps you just have fun with it. It makes it interesting. So back to this original question. We have u is equal to the square root of x, and the question here is asking what the integral will look like if I do u sub and correct. Okay, awesome. Thank you. If I do u sub for u is equal to the square root of x. So if you don't know what u sub is a method of integrating where, excuse me, where when you can't integrate it fully, you can do u substitution and kind of manipulate the integral in order to get into a form that you can integrate. Okay? So in this case scenario, it's asking us to replace every square root of x with a u. And then, because usually when you do u sub, this is how I would do it. We have u is equal to square root of x. Then I would take the derivative of u, and this would be 1 over 2 root x. If anyone wants an explanation of that, I will give that. And then this would be dx. And then we move this to the other side because we want to replace the dx with this du, because when you do u sub, when you're integrating, at least when you go on in calculus, I haven't gone that far yet, you want to have everything within the same variable. So in this case, we want everything to be in terms of u because we're doing u substitution. So this dx over here, and then if I multiply by um, 2 over root x, 2 root x, oh, sorry, 2 root x du is equal to dx. Now this dx is by itself, and I could substitute it into this part here. Sorry, it's a little cramped, so I will rewrite that. Okay, so now trying to figure out where I should do this. I'm gonna do this over here. I'm gonna draw a little arrow. So now I would have the integral from 1 to 4 of e to the square root x over square root x times 2 root x du. Now, usually I would actually like skip some of these steps, but I want to try to explain everything, and this is where you can kind of do it in whatever order. So I'm supposed to replace this with a u, this e with a u, but some people might could be confused here because when you see u is equal to square root x, you might think, oh, there's a square root x here, I make that u, there's a square root x here, I make that u, and that is correct. But the one issue is that if you already replace this with u from the beginning, you might be confused because you might not realize that we can cancel out the square root x here because we have a square root x in the numerator and a square root x in the denominator. So if you do that step too quickly, you might not realize and then you might get stuck. So I see right here that I can cross these out. And then one other thing is that now I'm going to replace this square root x here with u. So then we have 1 4 of e to the u. Wait, shoot. Sorry. 2 e to the u du. Okay, great. We're almost done. There's just one important step that that we have to do because on the exam, so this would be you could pull the two out because when you're doing an integral and if you're multiplying by a constant, like if this was 3, 4, 6, 1/2, whatever, I could just pull it right out. So I could just go like this. Not going to change our answer like that. Now, this is technically correct, but on the AP Calculus exam specific, which is only for America, if anyone here from America is not watching, it's just it's the AP exam. For other things it might be different. Um, for the question types, they might have a question and answer that looks like this, but one important step is that we want to change our bounds, this 1 and the 4, to be in terms of u. So to do that, all we do is we plug in 4 for x, and we plug in 1 for x over here. So if I have u is equal to the square root of 4, that's going to be equal to 2. Doesn't matter if it's plus or minus right here. And then if I have u is equal to the square root of 1, that's going to be equal to 1. I could change my bounds over here to be 2 and 1. And this would be our final answer. So let's double check that. I think it's looking like that matches up with answer choice C. Let's double check. 12. Yep, it is C. We got that one right. Let me add one to the counter. Question 6. All right. Great. Okay. I do not know how long I'm going to be doing this for. I have a lot of plans to try to keep myself going, but we will see how the day goes. Ooh, okay, this is a really fun problem. Okay, I'm glad I just saw this. Okay, perfect. So these types of problems are what's known as composite functions. So a composite function, let me just give you like a little bit of a background beforehand, just in case. Um, also, I mean this stream's name is just doing thank you. This stream it's it's doing math, but also I mean I just kind of like explaining and teaching it. When I was studying for my calculus exams, I would literally be explaining it to an imaginary person, and now I get to explain it to like 3 people. So um, and also when you explain things for math, it forces you to really know it. So I'm open to trying to explain it and realizing the gaps in my knowledge because that will help me further. I'd rather, make the mistake now, try to explain things, maybe get it wrong, than never do it because it forces you. It's very powerful. So let me give a little lesson on composite functions here. Usually when you get composite function questions, it will be with f of x and g of x because it's like the variables, common variables are x, y, z. With functions in these types of exams, it will usually be like f of x, g of x, h of x. That's what you usually see. So in this case, if I have f of x is equal to, let's just make this easy. Let's say that this is equal to x squared, right? And I say, and then I have g of x is equal to, hmm, uh, oh, I'll just make this is equal to 1 plus x. Okay. So in this case, if I wanted to do, there's different notations for composite functions. This is the one I like. I think when you're in pre-calculus, they use like this. It's like the little o there is supposed to mean, I don't like that. I like doing it like this. So I like doing like f of g of x. And you might be looking at that and you're wondering like, how do I read that? How do I read that? I don't know. So what this is saying is that for x, the x is here, for every x that we see, we plug in g of x because we plugged it in for every x that we have. So this is what it would look like. I think let me do this with with another color actually because I think it'd help it visualize a lot better. Do it with red. So this would be equal to, I'll put this in parentheses to signify that this is the f of x on the outside. And then we plug in 1 plus x, which would be our g of x. And then out here we have our square. So if you imagine that g of x is the red marker, I know I wrote it in purple, but over here it's the red, then we plug it in for all the x's that we see. And for example, we can add on to this. If I said that f of x is equal to x squared plus x, then that would mean that I add this. And then since there's another x here, I would plug in a g of x, 1 plus x. That is how it would. I could also just put some parentheses around here. So if fx was x squared plus x, then you plug in a g of x, and vice versa. If it was the other way around, I would plug in an x squared plus x for every x I see right there. All right, that was a little fun explanation, I think. Now let's do the calculus problem. So this problem states that f of x is equal to the square root of x squared minus 4, and this is how I do my ands, and g of x is equal to 3x minus 2. And now this is saying then the derivative of f of g of x at 3 is equal to what? Now this is a wordy, I'm just gonna say is what? Oh shoot, asking for the derivative actually, so I'll put it like this. Okay, this question has a few more layers than I thought originally. So let me just reiterate this question. We have these two functions, f of x and g of x. And then we have this composite function, f of g of x, very similar to what I just showed you in the example. And the question is saying that what is the derivative of this composite function at x equals 3? So when you have questions like these, it's very important that you do them in the correct order. Because if we plugged in 3 first and then we took the derivative, then that wouldn't be a good idea. It's easier just to take the derivative first, plug in 3, and also I think you get the wrong answer. So to do the derivative of a composite function, the way that it would work is it would be f prime times g of x times g prime of x. So if you guys don't understand that it's literally just the power rule, because in this case it's not the product rule. So I don't want to try to confuse you guys, but I just want to explain this. The product rule would be if I had f of x times g of x like this, and I want to take the derivative of this. That would be a different rule entirely, and we'd have a very different derivative setup. In this case, it's a composite function. So we do f prime, we leave the inside alone, and then we multiply it by the derivative of the inside. And then this is what we get. So let's let's continue on this question. This actually might be the first one I get wrong. So let's stay tuned. So this question requires us to actually take the derivatives of these things and then plug them in. So now this is saying 3. So it's saying the derivative of this whole thing at 3. So now we would want g of 3 and then g prime of 3, and then that would help us solve the rest of the problem. So first off, let me figure out what g at 3 is. I'll do it over here. So g at 3 equal to, so 3, there's an x here, so we plug in the 3 for the x. 3 times 3 is 9, minus 2, which is equal to 7. So now what we can do is I can rewrite this as f prime of 7 times, and let's find g prime of x. So g prime of x, the derivative of 3x is just going to be 3. The derivative of -2, remember, the derivative of any constant is 0, so that'll just go away. So the derivative of g prime of x is equal to 3. And the derivative at 3 is going to be 3. Because if you think about it like a straight line, if the graph of this is just a straight line, right, at this is the line. This is x equals 3. Wait, actually, that's y equals 3. Sorry. X equals 3 is going to look like this. Oh, wait, no, that is the... Wait, should I think it would actually... Yeah, it would be like this. Because no matter what... Yeah, sorry. It is like this. And no matter what x value put in, if I was at x equals 3, it would still be... the output would still be 3. If I was at x equals negative a billion, the y output would still be 3. So, therefore, g prime at 3 is equal to 3. I know I explained that a little bit quickly. I'll be back in a bit. Good luck. All right, thank you, Arya. I explained that a little bit quickly, so if anyone wants me to explain it a little slower, let me know. I get a little bit excited and I talk quickly. So yeah, please let me know about that. And then, so we would basically multiply this by 3 in the end. And now you can see that it's getting a little bit simpler. But I want to do. Let me just explain that one more time. So for this problem, it's asking for at x equals 3. So that means that for every x, we're going to plug in 3. We already found the derivative, so now it's okay for us to plug in 3. If I plugged in 3 beforehand, before I got my derivative, I might mix some things up. So we took the derivative, and now I know that I need to find at x equals 3 for g of x and g prime of x. For g of x, we found it right here. G of x at 3 is equal to 7. So I plugged in a 7 here. And then g prime of x at 3 we found is equal to 3. So I have a multiplied by 3 right here. Now the next step, or I guess the final step, would be to find the derivative of f of x and plug in 7 wherever we see an x. So I'm going to do that. I'm going to do that right down here. Okay, so f prime of x over here, f prime of x is going to be equal to, so one shortcut for doing derivatives with square roots is the derivative um, of the square root of u, I'm just going to do u, is going to be equal to u prime over 2 root u. That's only for square roots. If you have cubed roots, whatever other roots, this won't work, but it's u prime over 2 root u. So the u prime is going to be this right here. So the derivative of x squared minus 4, the derivative of x squared was going to be 2x because of the power rule. -4 is going to be 0. I made it. Yes. Yes, the more the merrier. So the derivative of any constant we know is 0. So the the numerator is just going to be 2x. And then we divide that by 2 times the square root of u, which is just this. So x squared minus 4. And then I could see that we have a 2 here. Hey, Caleb, it's Huxley. Oh, hey Huxley. How you doing? Thank you for joining. Thank you. I saw your story the other day, like you actually went to that event of the guy that we met, so that was really cool. I saw him, so good on you, man. Okay. So we can cancel out a 2 on both these sides. So then f prime of x, you guys can see this, f prime of x be equal to x over square root of x squared minus 4. Good. Sorry, I was at work. Thank you. Oh, I'm jobless right now. This is my job. So now we have the derivative of x. I'm calculating right now. Yeah, I'm calculating. Okay. So um now we just plug in a 7 for this, and then we'd have the rest of our answers. So let me just like box this right now because it's getting a little bit messy. So f prime at 7 is going to be equal to, we plug in a 7 everywhere we see an x. So we have 7 over the square root of 7 squared, which is 49, minus 4. Okay, I'm not gonna lie, it's looking a little bit it's looking a little bit ugly. I don't hmm, look at my answer choices. Okay, so this would then be f prime. So now what I'm gonna do is I'm just gonna combine what we have here. So f prime, I know that it's 7 over the square root of 49 minus 4 is gonna be 45, and then times 3. So then this is then equal, to simplify it a little bit further, 21 over the square root of 45. Okay, so I'm looking at my answer choices right here, and I don't have anything that looks like that. So I'm gonna need to simplify this square root a little bit. Let me also just double check that my battery's all good. Cool. We need to simplify a little bit of that. By the way, I hate simplifying uh square roots. Um, yeah, Huxley, I just want to let you know this is a PG, like a PG audience. This is for everyone of all ages, so please be careful in the chat a little bit. Um, I hate simplifying square roots. A lot of people, I think it's really funny between people that do math, whereas for some people, they love doing certain things that other people would hate, and it's some things they need so much help on. Like for example, for me, when I was taking pre-calculus over the summer, I couldn't do fractions. I remember taking the class, and literally I had a fancy TI-84 color calculator, and my teacher would not let me use it on every test. Um, this is not, I know it's not irrational, but you can simplify it. We could maybe simplify it. You want to know how? Here, look, okay, just to show Huxley for 1 second. When I see this, I see the square root of dislike, not hate. Someone dislike the stream? Confused. Oh, dislike, not hate. Oh, okay. So my apologies. I strongly dislike doing fractions. But Huxley, let me show you actually right here. So the square root of 45. Do you know how to simplify square roots? Um, so the square root of 45, when you're trying to simplify a square root, we just try to separate it into things that we can take the square root of. So when I see 45, I'm immediately thinking, this is just because of practice. I'm uh thinking of 9 times 5, because 9 times 5, I'm pretty sure is tree method. What is it? Oh, I think I that's another way of doing it, I guess. I've never heard of the tree method, but I think I can imagine what that would look like. So when I say the square root of 45, I guess I'll do it over here. Can you guys see over here? Yes, okay. So the square root of 45 is the same thing as the square root of 9 times 5. And then when you're multiplying them, you can actually do this as the square root of 9 times the square root of 5. That's one of the things you're allowed to do. You can't do that if it's adding or subtracting, it's different. And then the square root of 9, we know what that is. That's 3. And the square root of 5, we can't break that down any further. We can't do anything else. So we just leave it like that. So now we simplify this fraction to equal, just like arrow, 21 divided by 3 root 5. And 21 is divisible by, is it? Wait. Yes, because 21. Oh yeah, 14. Yeah, so that's equal to 7. So this will be equal to 7 over the square root of 5. That would be our final answer, which in this case is A. Let me check. 14. Okay, yes, we got it right. Okay, awesome. So Huxley, I hope that showed you that even though it was not rational, we are still able to continue on. So like I was saying beforehand, when I was in pre-calculus, a lot of people know me that I like to go far in math and just do it for fun. So a lot of people assume I'm really good at it, but that's not the case. So I like to tell them the story where when I was in pre-calculus, I did not know how to do fractions at all. And I remember before our tests, I would literally have like those like middle school or like pre I don't know when you learn fractions, but there's like really those videos for babies where you just like watch like how to add like 1/2 plus 1/2, and I'd watch them religiously and try to study down because I could not understand it. And when I tell people that story, they never believe me because it seems ridiculous, but it's true. And that's why I never want people to feel discouraged, because sometimes you could be doing like really difficult problems, but there's just if some of your basics are just not down, then it could you could struggle. But a lot of people are embarrassed to say, oh, I don't know how to do fractions, I don't know how to do percentages or ratios or anything. But I don't think you should be embarrassed about not being able to do any math thing, because you could just practice, and no math is like above another. They're all just math. They all should be respected equally. As a little yap sash. Um, and again, if you guys have any problems or you maybe want something explained or anything, please let me know. And if I do know the topic, I will try to explain it. If I don't, obviously, I don't want to try to give you guys too much false information. So I will. Did you get it right? Yes, I did. I checked. I have the answer key right next to me, and I'm checking it after every problem. And I'm just kind of scrolling through and seeing problems that I think look right. Oh no, not look right, but I think it'd be fun to do. I don't really have a set plan. But right now we're just doing some calculus things because I enjoy calculus a lot. Okay. Ooh. Okay. This one is really good. I really like this problem, but I'm gonna have to draw it out for us. This is gonna take me a second because I don't know how I don't want to show the graph. 1, 2, 3, 4, 5, 6, 8, 9. This is not even, but it's you guys will be okay. Okay, it looks something like that. I know it's a little bit ugly, but I think in terms of the problem, it'll be fine. So this is the graph of h of x, which is equal to the integral from 0 to x of f of t dt. And what the question is asking is, you can't see all the answer choices, but it's like saying, you know, um, it's asking you to compare the base function, the first derivative, and the second derivative in terms of which one's greater or less than the other. So we have to set up all three. Like for example, I don't know if this is the answer or not, but it'd be like, oh, like h double prime is less than h of x, which is less than h prime of x. Something like that. That's kind of what the question's asking us here. Now, this looks intimidating, doesn't it? You see squiggly lines, we see a graph that's very poorly drawn, and we see like integrals, we see h of x, but then we see f of t, and you're like, what do I do here? Um, but I'm going to show you that it's very possible. And the answer's in here. Okay, so first off, let's just understand what each thing means. So understanding what h of x is. So h of x is the integral of f of t, and I believe this is the graph of f. This is the graph of f. Oh shoot. I'm just gonna put f down here. I'm gonna say f of t. This is the graph of f of t. And even if you haven't um, taken calculus, when you take the integral of something, that's basically just saying what's the area under the curve. So this is the curve here, and we're asking, what the area is. And this is saying it's from 0 to x. So this means we're starting at 0, and we're just going on um, for a while, whatever x value we want. So like, for example, if I said that x is equal to 6, it'd be the area from 0 to 6, which is this negative thing. And in case you don't know, when your area is below the x-axis, it's considered negative, and when it's above the x-axis, it's considered positive. So our area from 0 to 6 would be like considered negative, like a negative area, but that's where whatever. So h of x is basically going to be equal to, like, if we put in h of 1, that's going to be equal to the integral from 0 to 1 of this graph. So that's just kind of understanding what that is. So now let's take the derivative of h of x. So h prime of x, if you don't know how to take the derivatives of these types of questions, basically all you do is you take the derivative, or no, you just plug this in over here, and then you multiply it by u prime. So for this case, in this case, it'd be equal to f of x times u prime, but the derivative of x with respect to x is 1, so h prime of x is just equal to f of x. My gosh. Excuse me, guys. Okay, so h prime of x is just equal to f of x. Now, how do we interpret that? We know that h of x is just going to basically be equal to the area under the curve of wherever we want of f of t. But this is saying that, oh no, sorry, not f of t, because you just plug in t for there, but this is saying um, h prime of x is just equal to f of x. Now, what that means, Caleb, trivia question, what is a swirl in the golden ratio called? A swirl in the golden ratio called? Like a shell, or what? What is a swirl in the golden? The Fibonacci sequence? Is that what you? Oh no, that's not. I don't think that's it. Shoot. Oh, okay, okay, it was okay. I did say it. Okay, cool. So, all right, I do want to say that the stream is on like a slight delay. So, but I promise you, I did say it before that popped up. But fun little trivia question. I do like that. Okay, so f prime of h is equal to f of x. Now, if we plug in, let's say 1 for x, then h prime of 1 would be equal to f of 1. So that would mean what the function is at 1. Let's get this integral. That's right, let's get this integral. Um, so let's give an example. So if I say, let's say when x is equal to 6, yeah, when x is equal to 6, h of x is going to be equal to the area under the curve from 0 to 6. And we can see that the area from 0 to 6 is going to be negative. It's not gonna be a positive number. Now, h prime of x is equal to f of x. What that means is that if we plug in x equals 6, then h prime of x is equal to f at 6. And we can see that f at 6, it crosses the x-axis, which means it's 0. Because if it's not above it, it's crossing it right there. So in this case, at, at x is equal to 6, this would be negative and this would equal 0. Does that make sense? I hope it does. But sorry, I'm speaking a little fast. I have to slow down. I'm starting to like run out of breath and everything. So I hope you guys can understand what those are saying. But let's go one step further and take the second derivative, and then I'll give the exact same example. So if we take the derivative of this, so that's h double prime of x, that will be equal to f prime of x, because then we take the derivative of that side. Now, what the heck does that mean? So that's asking for the slope. If you don't know what the derivative is, the derivative is basically saying the slope um, of that point. That's why when we have, like, for example, if I have if I have x squared over here, which is this graph here, uh, this graph right down here, if I take the derivative of that, that's going to be the slope at the point. So the derivative of this is just going to be x, which looks like this. But if I'm looking for the derivative at a certain point, it's going to get the slope at that point. And it's basically seeing like the rate of it increasing at that point, if that hopefully made sense. So this is asking the most important thing to understand from this is we want to see if the slope is going to be positive, negative, or just constant. Is it going to be zero? So let's use the exact same example. If I at x is equal to 6, okay? Let me just do this in red so it stands out a little bit more. At x is equal to 6, for h of x, we know that it's going to be this area over here, which is a negative area. So this is going to be equal to a negative number. We don't really care what it is. For h prime of x, for h prime at 6, that's going to be f of 6. And f at 6, we could see this point right here, that's going to be 0. So this is equal to 0. Now, the third part, h double prime at 6 is equal to f prime at 6. And that's saying, what's the slope at 6? And the slope at 6, if you cannot, this is hard without practice, the slope here is going to be positive. It's going to be positive and increasing. So this is going to be equal to a positive number. Okay? Now, if we picked a point like here, it would still be positive, but if we picked it here, it would be negative because because it's actually because um the derivative you can't see because my graph is poorly drawn, but the derivative touches the graph at a single point. So right here you can see it's kind of going through here, but it's only supposed to be this one point. So for example, if I was asking for it at 2, the f prime at 2 is going to be this line here because it's only going to touch the graph at that point, and um that's going to be 0 because it's just going to be constant. It's not increasing or decreasing. It's just going to be whatever. So in this case scenario, the way that you'd answer the question, if you want to order them from least to greatest, the least is going to be this negative one, which is going to be h of x, which is going to be less than h prime of x, which is going to be less than h double prime of x. And that's because h of x is negative, so a negative number is going to be less than 0, and 0 is going to be less than a positive number. And let's see which answer choice does that line up with. Oh, this is saying at 6. Sorry. I would just pick 6 because I thought it was a good example, but I didn't even know that it was asking for it at 6. So would you look at that? And this would, of course, change depending on what point you're asking. And I believe that I picked answer choice A, which is correct again. Okay, so there is yet another one. Let me just change this. Let's check up on how the stream is doing here. I don't know how many people are watching it right now. We got two people watching. I think one of those one of those people is me. So, um, oh wait, at one point we had 4 people watching. That's kind of crazy. If you get to 4 hours, I'll send you $15. Well, I don't have donation set up, so there is one little issue with that. I don't yeah, I'm sorry. No, but please do not send me money. I do not want money to be sent. If I do want that later, maybe when I get popular enough, YouTube will let me uh use donations. So I will Venmo you. Oh my gosh. All right, guys, actually, excuse me one moment. I'm just gonna run to the restroom, be back real quickly. Need to I have this all set up. Look at this. Wait, wait, wrong, shoot, wrong thing. Yes, we'll be right back. Okay, see, I told you to be quick. Let me get this going. Production quality, yes. Yes, I spent all of last night watching OBS tutorials and I wasted a lot of time, but I also did a lot of fun stuff. Here, Huxley, since you're here, let me show you the punishments that I have lined up. I have this great punishment wheel that I've always wanted to show, uh, but I can't. Well, no, it's not that I can't. I just like let me pull it up here because I don't think you were joined originally. The punishment wheel here, I can spin it when I get a question wrong. Um, so far I haven't gotten one wrong, and I also haven't been doing super hard questions. So there is that. But the punishments include doing a question blindfolded, which means like I can't really see the screen. I have a cup here that I filled with that's all salt, and I will fill it up with water, and I'll try to drink a little bit of it or like all of it. I don't know, it depends on stuff, but that's all salt. Let me see the punishments. So we have, yeah, salt water. I also have eating a whole lemon with the rind and everything, or maybe half. I don't know. It's gonna see how it goes. I don't know why it's in the bag. This is what my friend Miranda gave me. There are two apparently very spicy peppers in here. If they're not spicy, I mean, I'm pretty sure they are, or else she wouldn't have given them to me. But uh, there's also that. But there's only two of these, and again, there's only one lemon. I have doing problems with oven mitts on. I think that'd be fun. Some of these are harmless. Some of these are pretty harmful. I also have a pogo stick. So trying to do a problem on a pogo stick, I think would be fun. I just hope I don't break something around here. Uh, then what else do I have? I have doing a problem where I have to balance something on my head. So I have this like puzzle thing, but I can grab more things if you guys want. And then I also have down here, this would be the big one we go outside, but I have a bucket filled with water, and when I get the punishment on the punishment wheel, I'll fill this up with ice, and I'll do the ice bucket challenge. I have towels all over my floor, and I take you guys outside, and we do that real quickly. And that's it. Those are the punishments I could think of, but I'm also open to suggestions in case you guys think of anything creative that's what that's within reason, you know. So, but let's get back to mathing. Get back to mathing. I also have a few Red Bulls to keep me going, but I don't want to drink too many, so I have them down here for aesthetic. Impromptu ice bucket challenge. But listen, Huxley, we have to if we get it on the wheel. So I don't know. I don't know what we're going to be doing today. Hopefully we get to go through some of them. I'm kind of excited and I think it's going to keep me alive a little bit doing a few of these. So yeah. Anyway, let's get back to so ba. Ooh, ooh. Hmm. This is an interesting thing. That's improv. Listen, listen. We'll maybe like at the end or at a certain milestone. I don't want to do it too early, also because first off, I don't have that much ice. Second off, we've only been doing this for an hour and 20 minutes. That's actually it's gone by pretty quickly. Okay. Okay. How many viewers do we have right now? Drinking a glass of salt water can be dangerous. You can vomit and harm your kidneys. Then I will drink just a little bit, because or maybe I'll try to gargle it because a lot of people gargle it uh when they have sore throats, and gargling it can also be kind of gross and a nice fun challenge. So don't worry. I won't try to harm myself. So I'll be careful, but I appreciate it. Maybe I'll take that one off. Okay. So this next question we have here is a limit question. We have the limit as h approaches zero of ln of 4 plus h minus ln of 4 divided by h. Now, when people get these questions on their exam, they kind of get overwhelmed and doing, they start evaluating the limit, which is the wrong way to do this question because with experience, you'll realize that this is just the formal definition of a derivative. This is just basically a fancy way of saying take the derivative. My, my dog's barking at something. So this is again something that just comes with practice because what a lot of people don't realize with math is that a lot of it is just patterns. So when you do a lot of things, you can kind of see questions and map out how to solve them because you like, no, oh, I've done a problem that kind of looks like this. Let me try out that way, and then most of the time they'll end up being it because of the pattern recognition. So right here, this is the formal definition of a derivative, and I don't know if I know it off the top of my head what the actual thing is, but I know it's the limit as I think it's still like as h approaches 0 of f of x plus h minus f of x over h. Yes. So if you can automatically do right here, we could see that right here, this is just our f of x. And it's asking us to find the derivative for. So thing is, so we could draw right here, this is our f at 4. So then our f of x is equal to ln of x right there. So basically, if we take the derivative of this, plug in 4, then we have our answer. We don't need to worry about all this other stuff. It's just there to, well, it's not there to confuse us. It's the way of doing it. But really, you just need to be looking at this because the plus h will throw you off. But if you know what the actual formal definition is, then you know that on this side, this is just the function and the value that we're evaluating the derivative of the function at. So if we know that f of x is equal to ln x, f prime of x would be equal to 1 over x, and then f prime at 4 is equal to, I wrote equal twice, is equal to 1 over 4, and that would be our answer. Let me, I'm hoping that was right. In this case, that would be B. Yes, okay, that was right. Does anyone have any questions on that? I'd be happy to explain that. I went through it a little bit quickly. So, um, mm, just checking in on the stream. All right, cool. Anyone have any questions on that one? I think these are fun questions. Okay, let's look for another question. Also, if you guys want me to do any other math types, I would be happy to do it. Ooh, mm. Okay, this is an interesting question, so I want to make sure that I try to do it correctly. It's a little bit of a long one, but I'll talk it out. Let me just write down the necessary information first. It's a very weird way to write that. How about a related rates problem? Those are tricky. Oh, okay, related rates. Yes. Okay. I'm gonna do that actually right after this question here, just because I was writing it down. But after that, I'll definitely do a related rates question. I have a fun story about related rates question. So equals. So what this question is asking is it's saying in a fancy way. It says function f is defined by this. At what points x and y on the graph of f have the property that the line tangent to f at x, y has a slope of 1/2? That is just complete math talk for saying when is the derivative equal to 1/2? Because the derivative of a function is going to be the slope. And it's saying at what properties or at what points is the graph going to be equal to 1/2? So all we have to do here is just take the derivative of f of x, which would be f prime of x. Okay, so this, we have to do the quotient rule. So we have a variable on the top, we have an x on the top, x on the bottom. We can't cancel them out. So we have to do the quotient rule. And if you guys have taken calculus, your teacher may have said, there's a little nice little saying like low d high minus high d low over low squared. And all that's saying is if you have, for example, if I have, f of x on the top and I have g of x on the bottom, then the quotient rule will be the low, which is g of x, d high is the derivative of the top, low d high, minus high f of x, d low, g prime of x, over low squared. So g of x squared. So that's just a little acronym that, or not an acronym, it's a little saying that help you do that. So I'm going to say it out as I do this. So I have low, which is x plus 2. D high, the derivative of x is just 1, but in this case, I'll just write down an imaginary 1 just to help you guys. So low d high minus high x d low. So the derivative of this is actually just going to be 1 because the derivative of a constant is 0. The derivative of x with respects to x is going to be 1. So again, we have low d high minus high d low all over low squared, x plus 2 squared. Okay, cool. Now let's just clean this up a little bit. F prime of x is equal to x plus 2 minus x over x plus 2 squared. Now these x's cancel, so then we just have 2 over x plus 2 squared. And we want this to be equal to 1/2, right? And so now if I want this to be equal to 1/2, now we just have to move some stuff around and isolate the x. So if I multiply both sides by if I multiply this over here and I multiply this over here, then I could do x plus 2 squared is equal to 4. That's just the butterfly method. So I multiply both sides here. I multiply this by 2 over 2, multiply this by 2 over, oh no, 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 no. I both sides by multiply this by 2, multiply this by 2 to cancel out this, and I multiply this by x plus 2 squared, and I multiply this by x plus 2 squared. So therefore, everything cancels out because you can do anything you want to the equation as long as you do it to both sides. But now, take the square root of this, square root of 4, x plus 2 is equal to plus or minus 2. In this case, the plus or minus is very important. Now, all we have to do is x is equal to -2 plus or minus 2. So therefore, x would be equal to -2 plus 2, and x is equal to -2 minus 2, which is then equal to 0 and -4. I know I went a little bit quickly there, so if anyone needs any explanation, let me know. And now the last part of the question. So these would be the the x coordinates where the function has a slope. Oh, the derivative has a slope at 1/2. But no, sorry, the derivative is equal to 1/2. But the question is asking for the actual coordinates. So to find the coordinates, all we have to do is plug these points back into our original function. So if I plugged in 0 into this, I would just get 0 because it's 0 plus, I mean 0 over 0 plus 2, which is just, oh no, no, sorry, it'd be 0 over 2, which is just 0. If I plugged in -4, I would have -4 over -4 plus 2, which is equal to uh, -2, which is equal to +2. So then our final answer would be at 0 comma 0 and -4 comma 2. So in any sort of math problem, when they're asking you for coordinates, usually in calculus, they ask you for the derivative, and then you have to plug that derivative back into the original function to get the other coordinate point, because that's the x value, now you need the y value. Okay, so I'll let you guys marinate that while I find a related rates problem. That would be fun to do. Let's see. Mm, Do, do, do. I just search up related rates calculus problems actually. Mm, hey, I think I'm just gonna look up related rates problem on my iPad. Mm. Also haven't done related rate problems in a while. I'm scared to mess it up, but it should be fun either way. I remember when my calculus teacher first introduced related rates problems, and I just could not understand them. Oh, here we go. Okay, perfect. I found one. All right. Oh, oh shoot. Did not realize that. Oh, oh. Snitsky fell. Yeah, so related rates problems I think are very, very fun. Originally, I found them to be very intimidating, but then as long as the problem gives you the equation, then it usually seems pretty fine. So for those who don't know, related rates problems, the trick to doing them is you first off, you just have to take your time. You have to understand what the question gives you and what you have to find. And usually when you write it out in this way, I'm going to show you it's not too bad. So this question says the velocity v in meters per second of a certain type of wave is given by v of h is equal to 3 square root h. Okay? Where h is the depth in meters of the water through which the wave moves. What is the rate of change? That's also another thing. To know whenever you're doing a related rates problem, it will always say rate somewhere, so don't worry about that. Saying what is the rate of change in meters per second per meter of the velocity of the wave with respect to the depth of the water when the depth is 2 meters? The way that I always approach related rates problems is first off, whatever equation they give me, I just take the derivative of it. So you take the derivative with respects to r because it's the rate. So you multiply both sides by d over dr. So we have, it's going to put this like, yeah, so I'm going to put this as dv over dr be equal to 3 times the, oh yeah, so this is u prime, which is um, dh dr divided by 2 square root of h, yeah, wait, yeah, dr. I believe I believe that is right because what you're saying here is that the derivative of h with respects to r, which is the rate, will be the rate at which the height is increasing. So it's looking, so now I believe that I've derived this correctly. I'll do a few related rates problems actually, just to kind of get my bearings back. I forgot to increase the counter. Uh, and I know this looks a little bit ugly because it's a complex. Are they called complex fractions? I don't remember, but so you have to understand what it's saying. This is saying this is the rate at which the velocity is changing. This is the rate at which the height is changing, and this is just the height. So you have to understand like what your d whatever over dr means, because if you know what they mean, then you can refer to the problem and figure out either A, if they give it to you, because usually what sometimes problems will do is they'll say like, oh, the rate at which the height is increasing is equal to this. But in this case, it says, what is the rate of change in meters per second per meter of the velocity of the wave with respect to the depth of the water when the depth is 2 meters? Okay, so hmm. Okay, so this is saying when the depth is 2 meters. So that's saying that you plug in a we plug in a two there, but I'm a little bit this might be the one that stumps me. Meters per second per meter of the velocity of the wave with respect to the depth of the water. And the depth is 2. It's the rate of change in meters per second per meter of the velocity. Hmm. Yeah, this is like, because it's saying when the depth is 2, because there's something I'm missing here. It's saying when the depth is 2, because this is u prime, is the square root of h, because, if I have the would equal be equal to h prime over 2 root h. So that'd be drd, dhdr, drdh. Hmm. That math team, you want to try to help me out a little bit? Or let me see. I just like this is where I get a little confused because it's should be because this is the velocity. Or what rate the velocity is changing. dr be equal to 3 times I need to figure out what dr is in order to solve the rest of this problem. This would be multiply that by. Can you write the problem on the board? I couldn't catch the whole thing. You want me to like rewrite the whole? You want me to rewrite the entire problem, or is h equals to the depth? Yes, it's saying the depth when h is equal to 2. When the depth is 2 meters. That is correct. Sorry, I know I didn't write it too neatly here. God, I don't know. There's something I'm missing here. Mm, Depth is 2 meters. Not like I'm so. Here, let me pull up the problem like this. Maybe you could see it. Yeah, like let me. Uh, is it focused? Got it? Okay, wait. You, let let you be the teacher. Yeah, explain it to me. I'll count this as my first one wrong. And you oh, and you I don't know if you meant like you got the question or you got something else. Mm, Just looking at it. Oh, okay, 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 okay. I got you. I got you. Um, yeah, I don't know why this is like helping me so much. I just don't. Maybe try another one. You want to try another one? Okay. Let me when a few more people come in, like because I think one of my friends who's taking a pre-calculus power rule. Oh, okay, wait, hold on. Yeah, let's see if we could try yeah, power rule. Well, because that would have been the power rule because if I have three and this is like h to the 1/2, I bring h down, which would be 3 over 2 h, and then minus 1 minus this would be minus 2 over 2, which would be equal to negative 1/2, which would be h to the negative 1/2, which would be 3 over 2 root h times h prime, which would be what we had before. Answer should be C, then 3 over 2. Yeah, no, but the thing is that you're forgetting to aren't you forgetting to multiply by the h prime? That's the thing I'd be confused about because I feel like you need unless I'm missing something here. Because there has to be an h prime because when if you were to do the power rule, then there's always um an x prime, but it's usually um x with respects to x, which is just one. But in this case, it's h with respects to r, so it shouldn't be that. Answer should be C. Let me see. You said it's okay. I don't know. The answer key is saying something different. It's saying should be C. How do you know? Wait. Should be C. What does that even mean? Wait, you don't know what C is. That's funny. Unless you know something I don't. A velocity V. Why is this one stumping me so much? Oh, oh my gosh. You should. Oh, you should screen. Okay, you're right. I took a screenshot and solved. Okay, so I. Okay, I think I read the problem incorrectly, and you have to do it. That was the issue, guys. Okay, I am so sorry. What happened was is you have to differentiate this. This is the derivative with respects to h. So it was not. It's the derivative with respects to h. So then, therefore, when you did this part, it should be 3 over 2 square root h, and the h prime should go away because it's the derivative of h over the derivative of the derivative with respects to h, which would equal to 1. So then, yeah, you're right. It would be it would be that. It should be C. Okay, so if it's 2, then yeah, no, I think you may have got me on that one. Okay. So that means it's punishment time. I will give you guys an option actually. Do you want me to do the punishment right now, or do you want me to wait until maybe there's a few more people? Because I know there's gonna be a couple people that join in a bit because my friend's taking a summer class and I asked them to put the stream on. So I'm gonna leave that up to you guys. But thank you, Cheyenne. You get some brownie points for that. That was my bad. I'm confused with the units in meters per second per meter. Okay, so and chooses reasonable. Okay, we're not doing that. I'm confused with the units in meters per second per meter. So it's the in meters per second per meter. That part is just because you're doing like the rate of uh the rate. So like when you're doing related rates question, usually it's like per second or like per second squared. That's just the nature of what happens when you line up the units on your related rates problems. Here, let me try to find usually Kat, you don't have to worry about that because most of the time the problems they won't be in units. You only have to worry about that during FRQs. So, but that is a good question. It just has to do with the um, the nature of the problem when you're taking the derivatives like that. Okay, that makes sense. Thanks. Of course, of course. I'm gonna try to find another problem because ooh, hmm, okay, that makes sense. Let me see. I want to like look up some. I'm gonna go online, see if we could find some related rates problems. EDH. Yes, that is yes, that is correct. What is these? Yeah, okay, this is a good question. This is the kind of question that I kind of wanted before I found that one. Hopefully, I can explain this one better. Okay, so this one is saying that a spherical balloon is expanding at a rate of 60 pi inches cubed per second. That's so it says the balloon is expanding. Okay, okay, I'm just gonna write balloon, balloon is expanding a rate of 60 inches per second. How fast is the surface area of the balloon expanding when the radius, so r is equal to 4 inches? Um, did you ever do the pre-calc questions? Only Bunny 672. Only which pre-calc questions are you talking about? I have a few people who told me about some pre-calc questions, so I if you could tell me where specifically, I could do that. But in the meantime, let's continue this problem. Okay, so for this is mainly specific for cat because I wanna try to redeem myself. And by the way, let me just like put a reminder for punishment. Like I'll just put like punishment due. Okay, so this is just a reminder for you guys. The study guide I sent. Okay, okay. Yeah. Okay, I'll pull up the study guide right after this, okay? It's just my trick stuff's a little messy, but hey, all practice is good practice when it comes to math. So this question is saying that a spherical balloon is expanding at a rate of 60 pi blah 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 per second. How fast is the surface area of the balloon expanding when the radius is 4 inches? And then this problem very kindly gives us what the volume of what a balloon is. So volume is equal to 4 over 3 pi r cubed. And then the area is equal to 4 pi 4 pi r squared. So let's figure this out. So they're asking for how fast is the surface area expanding when the radius is expanding at a rate of, okay. How fast is the surface area expanding when the radius is 4 inches? Okay. Okay, perfect, 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 perfect. Uh, so when it's saying that, I just need to have the question open here. When it's saying that a spherical balloon is expanding at a rate of 60 pi, that's saying that dv, I think, wait, is it dv or what is it saying? Yeah, dv dt is going to be equal to 60 pi. In this case, the units don't really matter. Um, so again, this that's where you have to figure out how to read these and kind of translate them into math, I would say. Something like that. So, let me see. Okay, so let's see. We're trying to figure out, oh my gosh. We're trying to figure out how fast is the surface area of the balloon expanding. So we're trying to find it's the derivative of the area if it's calculating the expansion. Yes, that's exactly what I was about to do. So we're looking for the derivative of the area with respect to time. So we have the area of equation right here. So let's take the derivative of that. So the derivative of that would be dA over dt is equal to um that's just 4 pi. That's 4 pi 2r times dr dt. I think that's one of the things I was missing with these related rates. I think they're always with respects to, yeah, I forget. It's been a while, but this is kind of why I'm doing this, just to keep the practice up. And we're at like an all-time high. We have 3 viewers right now. So, okay. So Cheyenne is right. We have to take the derivative of the area and we get this. Now we know what our radius is because we're looking for the radius when it's 4 inches. I mean, we're looking for the area expanding when it's the radius is 4 inches, but we don't know what dr dt is. So how do we find that? this is where related rates problems shine. So that's why they give us the volume and the area. Because if we know what the the rate at which the volume is expanding. We know that's 60 pi. So if we bring this over here, or bring this down here, this down here, and we take the derivative of this, we have dv dt. We take the derivative with respect to time because it's related rates is equal to 4 over 3 pi 3r squared dr dt, right? Because it's the power rule. We bring n down, we do n minus 1, we leave this alone, but we multiply by the derivative of that. And the derivative of the radius with respect to t is dr dt. So then we have this down here. Now, if we the only issue if we wanted to find dr dt is we need to know dv dt. But that's what they tell us over here. They say the balloon is expanding at a rate of 60 pi inches cubed. Now, the cubed should also be a telltale that it's volume. And that means that dv dt is equal to 60 pi. So therefore, we can put that in here and we could say that 60 pi is equal to 4 over 3. Actually, these threes will cancel. So I'm just going to cancel them out right here. These threes cancel. So 4 pi r squared dr dt. Now we can cancel out the pi's because there's a pi here and there's a pi here. We can cancel those out. We can divide. We know that r is going to be 4. So 4 squared is 16. Uh, 16 times 4 is uh 32, 64, right? Right? 16 times 4, 32, 64. So then we can divide this by, and do this over here actually, sorry guys. Then I should have 60 over 64 is equal to dr dt. And we can simplify this, obviously. I'm going to do this, simplifying this slowly. So I know this is equal to 30 over 32. And then if I divide both sides by, uh, okay, simplify that further. 16, divide both sides by 2. Yes, and that's 15 over 16. Okay, great. So 15 over 16 is equal to, Caleb, I just woke up. Burger Gaming 101. Um, it's 1 o'clock, man. You gotta lock in. You gotta lock in on that. DRDT. Okay, so I know, sorry that I've been explaining this a little bit poorly. If some of you guys are confused, I can re-explain it. I just it's all coming back to me right now as we're doing these practice problems. So I'm trying to explain as it's coming back to me, which sometimes it comes out a little bit convoluted. Um, but let me just give a quick recap for the person who just woke up. So we're given a related rates problem about a balloon. We know that the balloon is expanding at a rate of 60 pi inches cubed per second. And we're trying to find what rate the area is increasing with respect to time. Now they give us two equations. Oh, sorry. The air, like the surface area is expanding when the radius is equal to 4. And then they give us these two equations. They give us the equation for the volume of a sphere, and they give us the equation for the area of a um, sphere. So what we have to do first, as Sean pointed out, is ultimately we're trying to find the rate at which the area is increasing with respect to time. So that means first we take the derivative of this equation with respect to time, and we get this. We get dA over dt is equal to 4 pi 2r times dr dt. Now, we could solve all of this except for the dr dt, which we don't know. And you might be stumped there, but that's why they give us this volume equation. Because if we take the derivative of the volume equation, which would be this down here, we get dv over dt is equal to 4 over 3 pi 3r squared times dr dt. Now, you might be thinking, well, what's dv dt? They told us what dv dt right here for the other part of the problem where they said the balloon is expanding at a rate of 60 pi inches cubed. Cubed usually means volume. Well, it does mean volume. So then we know that dv dt is equal to 60 pi. The units don't really matter here. They matter in terms of understanding like where things go. But in the final problem, we don't need to like add or like we don't need to multiply our units. That'd be too much work. So then we can plug that in here and we get 60 pi. And then I canceled out these threes. I canceled out the pies, and then I plugged in 4 here, and then I divided it, and then I got 60 over 64 is equal to drdt. And then all I did is I did some scratch work over here just to simplify that. And then we have drdt is equal to 15 over 16. So yeah, now you're caught the speed. And now we can plug in everything we know to find the rest of the problem. So we could say that dA over dt is equal to 4 pi times 2r. The radius is going to be 4. So 2 times 4 is 8. So I'm just going to say times, I'm just going to put 8. I'm just going to put, actually, I'll just multiply the 8 right now. 8 times 4, that's 32. 32 pi, right? 8 times 4, 16. 32. Okay, cool. And then times the RDT, which we figured out was 15 over 16. So times 15 over 16. And that should be our final answer. But I think we can simplify this a little bit. I know that, actually, wait, this is going to be a question, actually. Where, I can't, oh, there we go, question 11. Uh, I think we can simplify this. 32 goes into 16 goes into 32 two times. So then this would be equal to 2 pi times 15, which would be equal to 30 pi. That should be our final answer. That was a that was a mouthful. That was a mouthful, but that's why I'm really happy I'm doing this because it's like it's a refresher, you know. Yeah, I realized I forgot to do uh things like this, and now it's all coming back to me. I think now I want to try to actually do some Riemann sums because I forgot how to do them. But before that, I need to go to the restroom real quickly. I'll be back. Be back in just a jiffy. The restroom's right here in my house, so just hold on tight, guys. Bam. We'll be right back. Okay, we are we're back. Um, my legs are starting to get a little tired from standing. I might bring in my chair, but we've been doing this for a little bit. Actually, hold on. I'm gonna go get the sparkling water. Yep, Spindrift, if you're watching this, I drink. My family, we drink cases of you every week, so we too bad. Okay, okay. Uh, let me find. I'm gonna do a Riemann sum question now. Let's try to find it. I'm starting to get a little tired. Nope, not doing I'm not doing the trapezoidal rule. That is just not going to be happening right now. You're not in the mood for trapezoidal Riemann sums. If you guys don't know, for Riemann sums, there's left hand, right hand, midpoint, and then trapezoidal. They all work differently in terms of what you're trying to approximate, and some are over approximations, under approximations. It depends, but trapezoidal is just the like an ugly one to remember. Hmm. Uh, okay, I believe I remember how to do Riemann sums correctly, but I have a problem set up that I would like to possibly try. Um, do, 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 do. So this is a Riemann sum question. I'm just gonna write the thing. So we have E hours, and then I have R of t. So it's trapezoidal. So so do a trapezoidal. Ugh, okay, I just need to like look up. Let me do this one first, and then I need to like look up the rule and I'll do it. It's just I think maybe I might remember. I don't know. Back in my prime, I was able to do them. Okay, so this question says a tank contains 50 liters of oil at T equals 4. Oil is being pumped into the tank at a rate R of T, where R of T is measured in liters per hour and T is measured in hours. Select values of R given in the table above. Use a right Riemann sum with three subintervals and the data from the table. What is the approximation of the number of liters that are in the tank at T equals 15 hours? Okay, now the problem, prepare the salt water. He doesn't know prepare the salt water. Dude, the salt water is dangerous. I don't. Birgit, who are you? I don't know your. I know your. I know you, but like I don't know who you are with your name. But prepare the salt. That's kind of dangerous. Maybe I might gurgle some salt water in a little bit. There's a punishment due, but I'm gonna wait. I want to wait until I have a few people that are gonna be joining soon, so I want to save the punishment due for when they come. But I promise you, I will do all the punishments I have to. Uh, to a trapezoidal that he doesn't know. Maybe I'll say times two. Do you want me to put times two? Okay, fine. I'll put times two because I don't know how to do Riemann sums. So for this one, we're asking to do a right-hand Riemann sum to approximate the amount of oil in um at 15 hours, and this is the rate at which the oil is coming in, and it also tells us that at t equals 4, uh at t equals 4, there's 50 liters of oil. Now, what you have to understand about what Riemann sums are is that they are like rectangles. An integral is basically just an infinite amount of rectangles to get a better and better approximation. Let me give you guys an example. So if I have this graph here, right? I got like this is a good example. So I just have this. This is like x squared, or this is whatever. So if I wanted to do a right hand Riemann sum, that would mean that like the it hits on the right side. So it would be like this. Every rectangle would hit on the right side of it, and like so on and so forth. And you could see like if I do three rectangles, it's the base plus base. Okay, thank you, Shahan. I will do that one next. Let me just do this one first. Um, so you could see that if I do three rectangles, it doesn't look too, it looks a little ugly. But as I do more and more rectangles, then the my approximation will get better and better. So if you do an infinite amount of rectangles, then you'd get the actual value, and that's the whole point of an integral. So right here, we're going to do a right-hand Riemann sum. And the trick that I know in terms of doing right-hand Riemann sums is that you move to the right in terms of like these values. If it was a left hand, you'd move to the left, I think. So, oh no, you pick the right value. So if we're doing three subintervals, right? Then this is how I would approach this problem. So our goal is to get to 15, so we're going to start at 4. So at 4, we know we have 50, but I'm just going to put a plus. So plus, from 4 to 7, that is a distance of 3. So I'm going to put 3 times, and then on the right side, it's 6.2, or that's the rate. The rate is 6.2. If this was a left hand, I would do the same thing. Distance from 4 to 7 is 3, but I would pick the left value, which would be 6.5. And then said plus from 7 to 12, that distance is 5 times 5.9, because I'm picking the right value. And then plus the distance here is 3 times 5.6. I believe that is it. I don't know if they want us to evaluate it. They do. This is okay. Oh, God, I don't know how to do decimals. This is gonna be rough. Okay, so let's this is gonna be ugly. So 50 plus um that would be 18.6, right? 18.6. And then 15, that would be that'd be 4.5, which would mean if that's 25, 25 plus 4 would be 29.5. 29.5 plus 15, 3, 18, 3, 18, 1.8, 15, 16.8, 16.8. And then uh, we're going to go back to the ancient methods. Okay, guys, 29.5 over 18.6, 16.8. Really ugly. So that's 11. That's uh 19. So 9. Let me just have is the stream good? Okay, I think everything's fine. Okay. Now that would be 9. Add a 1 up there. Uh that would be um that would be uh 15. That would be 15. 15 plus 8 is 23. 24. 4, 2, 4, 5, 6, and then add 50.9, 4, 11. 114.9. I believe, yes. Okay, that was correct. That was correct. Great. Great. Let me just hold on, guys. I just need to check something real quickly. Okay, I was just checking something. I wonder, does it say I'm not live anymore, or we're still live, guys? I think we are. I think we're still going strong. Hey guys, we've been going for 2 hours. I don't know if I should do like a milestone for every hour mark, or I don't know. What do you guys think? I need to get lunch soon. I might have to DoorDash or pause. I don't know what you guys. I kind of don't want to leave the stream, so yeah. Okay, you guys said trapezoidal one next, so we will be doing a trapezoidal one. No pausing, no pausing. Raw dog it. Okay. What about food? What about food, John? You want me to DoorDash and eat on the stream while I still do more math? Is that what you'd prefer? Okay. Okay, let's find a trapezoidal problem. You guys also feel free to write problems in the chat, or at least like where you want me to find other problems. I'll get you food. What will you get me? What will you get me? Also, you live pretty far from me. So I mean, I'm not opposed to it, China. Not opposed. Okay. Um, no, I'm joking, but if you raw dog it past 5 p.m., I'll get you like a reward. Dude, 5 p.m. That's only like that's only like 4 hours from 4 hours from now. That's easy. That's easy. Actually, I don't know. I'm kind of talking out of my butt right now, but I was just trying to find a. Let's look one up online. Um, Riemann questions, Aves or something. Okay, but Chan, what about lunch? I might just have to DoorDash Chipotle. Oh wait, let me look up trapezoidal Riemann sums. DoorDash lunch. I'll get you. Okay, if we make it that long, I mean, I hope I can, but I know. Sorry guys, I'm just trying to find a problem right now for trapezoidal rule. Um, gems. I don't get that how that works. Oh gosh, you guys, I really don't want to do trapezoidal rule. Base one plus base two. What did you say? Base one plus base two divided by two times the height. Oh wait, actually, wait, never mind. Wait, hold on. Maybe I was just being a big baby. It doesn't actually seem that bad. Okay, if it's not continuous intervals, if it is, oh yeah, you mean like the heights? Is that what you're talking about? Okay. 246 f of x 4. Okay. Let me write this down. This one is a okay, so uh Oh, this is just 246. 246. Oh, yeah. Okay. So this question says the function f is continuous on the closed interval from 0 to 6, and it has values given on the table above. The trapezoidal approximation from 0 to 6, found with three subintervals of equal length, is 52. What is the value of k? Okay, so if I believe that I am doing this correctly, then as Cheyenne said, base 1 plus base 2 divided by 2 times the height. So for the first one, base 1 plus base 2 would be 4 plus k over 2 times the height, which is 2, plus, um, wait, is the base, wait, did I mix up my bases? Or am I doing that right, John? Or it should be base 1 plus base 2 over 2, right? Base is x. Oh my goodness. Okay, thank you. I appreciate that. Wait, then how do I find the height if this one is k? You know? Hmm. Because if it's base 1 plus base 2, so that means it's 2 divided by 2 times the difference from 4 to k, but we don't know what the, if that's x and this is f of x. You peeping what I'm preaching here? Or you understand what I'm saying? Uh, just just do it's even intervals. Okay, so base, is that times? Or is that, what's the A? I'm confused. Base base minus area over 2? What are you saying? I'm sorry, I'm confused by this. I always avoided trapezoidal sums. I need help up here. I'm gonna wait, no, this was for the that rule over there, so actually pretty impressed, like the chat's been going on for a little bit. I'm actually really happy that people are watching. Oh, at least for a little bit. Base is the A area? You just tell me that is the A area? Base minus A over 2? What is the A? Am I missing something? It's just the points, muchacho. Okay, well then do the first one right here. So if it's base, it would be base is x. The base would just be 2 minus, so usually it's base 1 by its base 2. Yeah, yeah, I'm following. H is the interval. Oh, so the H is 2? So you can disregard it. It's 2 over 2, which is 1. So the first one's 1, and then plus, Uh, this is good. I like that I don't know any of this. Sean, please. So it's 4 plus k plus. Oh, okay, okay. So it's 4 plus k. Let's see, 4 plus k, and then solve for k because it said equal to whatever. I think it said equal to 52, it said. So 4 plus k plus 8 plus k plus 12. And now I think I know what you're saying because you said, oh, okay, so since the interval's 2, you divide by it and it's just, oh, okay. Okay, I understand now. And then this was equal to 52. Okay, yes. 32 plus 2k equals 52, whatever. Yeah, so what, like that's, yeah, 2k. I'm just gonna skip 2k. 4 plus 8 is 12. 12 plus 12 equals to 32. So plus 32 is equal to 52. So 2k is equal to 20k is equal to. Yeah, if I just did that. Ugh. Okay, I think we gotta crack open the next one. My tables. Punishment times 3. Okay, wait, hold on, because I we already said earlier that I said I'd add the punishment for not knowing the thing. That's why I put times 2 right there. Because the first one was for the related rates problem, and then the second one was because you guys said trapezoidal, and I said I didn't know trapezoidal, but you said do it anyway. So actually, it's just times 2 now. But should we spin the wheel, guys? Is it wheel spinning time? If someone says yes, then I'll spin the wheel. Spin the wheel of pain. I need some confirmation though. Yes, yes. Okay, guys. I've been waiting to do this. We have 4 concurrent viewers. This is the time to do it. Okay. So put the punishment wheel. Oh shit, that's the wrong thing. The punishment wheel. All right. Again, for those people who haven't been here, we have things such as doing it with we have peaceful things like wearing oven mitts, doing it blindfolded, and then we have other things like spicy peppers and ice bucket challenges and other things that I actually don't really want to do, but we keep it interesting. All right, guys, it's time to spin the wheel. Hold on, let's please, please, actually, please. Okay, okay. The pogo stick. That means that we have to do the next problem on top of a pogo stick. Um, okay. Here's the pogo stick. Bro, respin. That's not a punishment. This is I told you sometimes the some of the punishments on the wheel are bad enough that let me do the pogo stick one, okay? Listen, there's still another punishment, okay? There's still another one. So I'll do that one soon, okay? Now I just need a problem. What kind of problem do you guys want me to do on the pogo stick? Open suggestions. Like what type of math problem? You want me to do like algebra? Do you want me to do trig? I'm open to anything. I'm gonna put this on the floor. Um, let's see. You asked about some trig problems a while ago, right? I still don't know who you are, so I don't know. Like double integral, I don't know how to do those, man. I'm not in Calc 3 yet. I'll do this. I will. I'll do another one of these next during the next school year when I'm in Calc 3. But right now, my knowledge only goes up to BC. Okay. Dude, my iPad's not updated with my latest text. Did someone send you a pre-calc sheet? I think they did actually. Hold on. Might let me not put my before. Let's erase this. Learn it while on the pogo stick. Learn double. You want me to learn double integrals on a pogo stick? Wait. Okay, I'll tell you this. I'll tell you this. Okay. Um. Okay, Shayan. I know pre-calc is disgusting. Okay. How about if I get like the spicy pepper or something like that, then I will try to learn the basics of double integrals while having the spicy pepper. Does that sound good? Because I think that'd be more entertaining. AP Pre-Calc is not a real class. Yeah, okay. I have feelings about AP Pre-Calc, but the pre-calculus as a class is pre-calculus as a class is a real class, okay? Let's all like pre-calc is technically useful, I guess. I don't know. Uh, I did take a screenshot of, hold on. Okay, how about I get you the spiciest Dave's Tender and you have to teach double integrals? Okay, but okay. I'm down for that. The only thing is though, is that I can't teach it though. Maybe like you want me to try to explain a problem that I already know? Like you want me to explain another concept? Because I can't teach it if I don't know it, you know? But I'm totally open for that, Sean. If you want to buy me the spiciest thing, I will do that. Okay? So that would be like the blind being the blind triple integrals. Sean, no, I don't know that much. I can't do. Okay, if you can find me like a topic that I would know, I can explain the basics of calculus. Like I could explain limits. Why don't I could just start teaching AP Calc AB from the beginning, like do limits, do um basic derivatives like the power rule, the chain rule, product rule, quotient rule. I go over the trig derivatives and integrals, like basics of integrals. Like I could just teach that. Would that be okay? Would you be cool with that? How are you feeling about that? I'll learn it and teach you if you stream. Wait, what do you mean? Learn it and teach you if you stream past 5:30? No, I don't get what you're saying. I'm just trying to find this packet that my friend sent me. Um, okay, yes. What question are we on now? We're on like question like I think like 14. Um, okay. I have the image pulled up for us to do one. This is a very simple problem because on the pogo stick, I don't know how this is gonna go. But the question is, um, we're trying to verify each trig identity, and what that means is basically make each side equal to each other. Cheyenne, let's not, okay? Let's try to keep this with things on. Okay. So okay, so this one's fun. So we have sine. I'm just gonna write it down first and then I'm gonna go on the pogo stick, okay? So this is sine of 1/2 x cosine x. My God, why am I doing this? Sine minus sine of 5 over 2 x cosine x is equal to cosine cubed x square root of sine x. All right. Oh my God. Okay, wait. Okay, so guys, so first off, oh shit. Okay, first off, we're gonna want to. I could tell that we're gonna want to isolate. Oh, we're going to want to isolate the sine x and the cosine because I see there's one on each side. I can't. How do you do this? Okay, so like we're gonna write. Oh shit. Oh, shoot, my bad. Can't swear. We're gonna write. We're gonna write sine sine x. Oh my gosh. Okay, you know, I want to take this out. I might have to remove the pogo stick one after this, guys. Okay. Okay. So I can see here that there's a sine x and a cosine x and everything. So what I'm going to do first is I'm going to cancel cosine on that side and that side, and then cancel the 3 over there because then there's, oh my God, then there will be, I can't do it. I have to go to the pogo stick like that. So there, now we have sine of sine of 1/2 minus sine of 5 over 2. Oh my gosh, I can't do this. 5 over 2 equals cosine squared, the square root of sine x. Um, Now, what I'm noticing is that um, we can factor out another sine x of 1/2 from each side. Oh my God. Wait, maybe you guys want to, let me, hmm. Okay, I'll go on a little more. Wrap it up, bro. You can leave the stream. Okay, fine. I'll try to do quickly, but I'm gonna remove this one. This was not a good idea. Um, maybe I'll do something after this. I'll take like do you want me to take a shot of like lemon juice or pepper or something? Okay. So, oh fuck. Oh shoot. Ow. Okay. You know what? I'll add 2 punishments onto this. I can't do this with the pogo stick. This is not a good idea. I'm sorry, guys. So, what we can do is we can factor out a sine x. Let me move this back. Hey, you want me to do the ice bucket challenge? Let me uh let me get this. Let me get my camera back where we were. Here we go. All right, guys, I promise you. Okay. In a little bit, in preparation for that, I will let you guys choose the punishment, okay? I'll show you the punishment, I'll let you guys choose it because that did not work out as well as I thought. I need to remove that one from it. So anyway, sine of 1/2, we can factor that from everything. So then we have 1 minus sine of 5 over 2. Uh, Post on your story again that you're doing a punishment so people join. Can you do it, Shylon? You do. I'm in the middle of stream right now. Um, so sine of 5 over 2, if you factor out a sine of 1/2, that's 5 over 2 minus 2 over 2. Oh no, sine over, wait, no, 5 over 2 minus, oh yeah, sine, if you're factoring out a sine of 1/2 from this, you'd subtract 1/2. So 5 over 2 minus 1/2 is equal to 4 over 2, which is equal to 2. Then this would be 1 minus sine squared x is equal to cosine squared x times, again, the square root assigned to the 1/2 x, which is just what the square root is. And then we can cancel this and cancel this. We have 1 minus sine squared of x is equal to cosine squared x, like that. And then this looks like just like one of our Pythagorean identities, where it is um, sine squared x plus cosine squared x is equal to 1. If I subtract a sine squared x from both sides, I get cosine squared x is equal to 1 minus sine squared x, which means I could plug that in over here. So then I would have cosine squared x is equal to cosine squared x, and that would be the completed answer. Yeah, guys, sorry about that. I did not. I thought of the pogo stick one last night, and that ended up not being a good decision. But I promise you, I'll let you guys pick I'll let you guys pick one punishment that you want. Any punishment. If Cheyenne if Cheyenne actually if we make it past 5:30, Cheyenne can put the Cheyenne can um do the spicy pepper. All right. Alrighty. Okay. Brazen Bowl. What is Brazen Bowl? Right now. Yo, okay, so that doesn't look like the best thing, Sharon. I don't know if I have that in my tool house to do right now. So maybe next stream. Maybe not this one. Maybe next stream. Okay. Um, all right. Let's we got a little distracted, so let's go back these problems. Kylie Jenner lip challenge. Ooh, okay. Wait. How do you do that again? Do you need like a jar, right, or something? Tide Pod challenge? I'm not trying to die. Caleb, yes. Hi, Evan. How you doing, Evan? Can I come over? Sean White, you can't answer for him. Okay. Uh, okay, Evan. You can come over if I make it past 5:30, and Sean has to deliver me the spicy wing or the spicy tender. Okay. Let me do a math problem with you. You want to come all the way over to my house to do one problem. Okay. In the meantime, let's go. Let's go back to let's go back to what we were doing. So I'm in the mall right now. Evan, I don't think you're peer trained, if you know what I mean. Okay. Okay, good guys. So now we're gonna on the next question. So this is the integral of from 1 to 2 of dx over 2x plus 1. So this to me is looking like a u substitution problem because in math when we're doing an integral, right, we're trying to make it look like something that we know because you can't just integrate all willy-nilly. There are rules that we have to follow, and the whole point of integrating basically is to manipulate the integral to make it look like one of the rules so that we can actually integrate it correctly. So in this case, this denominator is looking really ugly. So I'm just gonna make this equal to u. So I'm gonna say u is equal to 2x plus 1. Okay. And then I'm gonna take the derivative of this, so du is going to be equal to 2 dx, and du is then equal to dx. Well, sorry, it's du over 2. Okay. And now that we have this is equal to dx, we could plug this in right here and then just pull out that 1/2. I believe, yeah, we could just pull out the 1/2, which would be, it would turn into, let me see. If I have the integral down here of 1 to of du over 2 over u, then that would be the same as pulling that out as a 1/2. This would just be du over u times 1/2. Okay. And then we can do now is then we can integrate this. And if you don't know, the integral of du over u or dx over x is going to be equal to ln x or ln u. So then this is going to be equal to 1/2 times ln of whatever this was, which is 2x plus 1, from 1 to 2. Now we have to actually evaluate it, which is the next part of the problem. Uh, do, do, do. So now we have to plug in 2, and then we have to plug in 1, and then we have to combine them all. So when we plug in 2, I get 4 plus 1, which is 5. So that's 1/2 ln 5. And then minus, when I plug in 1, I get 2 plus 1, which is 3. Then I get 1/2 ln 3, which on the answers, they just have this 1/2 factored out. So they have it looking like this, where they have 1/2 of, do it like this, 1/2 of ln 5 minus ln 3. So yeah, there we go. That is that problem. I know that one's right. I checked that one. Uh, Average. Oh, we actually have a lot of people on the stream right now. This is crazy. There's 5 people. It's a new day. It's a new day. Okay, on to the next one. Okay. Hmm. Ooh. Okay, so this is d over dx of sine cubed. Oh, that's awesome. Thank you. Thank you, Sophia. Shout out to you guys. All right. If you guys have any specific questions again, let me know. I will try to explain them, spice it up a little bit. Uh, no more pogo sticks though. That was a bad one. Okay, so this one is saying what is the derivative of sine cubed x squared? So this one is a little bit complicated if you don't know how your trig works, where we have to just be careful of what we do here. So another way that I would like to write this is I'm just going to do it over here. We could say d over dx of, and then I'm going to put this in like brackets, and then this sine of x squared cubed, because this cubed is for this entire thing. Because the way that the what is it called, the formatting for trig is that if I have sine squared x, it's the same thing as saying sine x squared. These are the exact same thing. So that's why when you write it like this, it makes it a little bit easier, because then you realize that we actually have to do the power rule and the chain rule in order to differentiate this, which makes it actually a pretty fun problem, because there's a lot of room for error in these derivative trig problems. So let's walk by it. So the first step to um, is to bring down the 3, because it's like the power rule. It's like the power rule where if I have x to the n, right, and I'm deriving this, then the derivative of this would be n x to the n minus 1 times x prime. So in this case, the x is our sine x squared, and the n is this 3 that we have up here. So that means this would be equal to 3 sine x squared times the integral of sine x squared. And the integral of sine x squared is going to be cosine x squared. But we need to multiply that finally by 2x. And you might be thinking, well, why do we do that? It's because of the chain rule. So if we look at this, we bring we bring the 3 down, we do 3 minus 1, which is 2, and then we have this inward x, which is this right here. We have to take the derivative of that. Now the derivative of sine x, so d over dx of sine x, or no, I guess sine u is going to be equal to cosine u times u prime. Okay, so the derivative of this sine x squared is going to be cosine x squared times u prime, and in this case, the u is here. So originally, like on the very first problem, this was the u, then this became the u, then that's our final thing. So that's why this whole thing is the answer, and there's multiple steps to it. It's a very fun, very fun problem, in my opinion. So yeah. Do, 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 do. Okay. We've been going for we're about to hit the 3 hour mark. I can feel my legs getting tired and all that fun stuff. Um, okay, keep it going. Ooh, I don't know if I remember how to do these problems. What about a word problem? Okay, Evan, the only thing that I have against the word problems is just that when I'm doing it on the whiteboard, in case you guys want to do them with me, or you want me to explain them, or you have a question, it's hard, like the shadow ones using. Oh, you mean like the ladder problems? You mean related rates? Oh, okay. Well, someone earlier in the stream was asking about related rates problems, so we can I know exactly the type of problems you're asking for. We can do it if you want. I can do a ladder problem for you. Uh yeah, low key. Okay. 'Cause I can't do them. Yeah, Evan, I wasn't able to do them a little earlier. Shan, help me out. Okay, let me find you they're known as ladder problems for I'm looking up AP Calc ladder problems. Okay, I'm just trying to look right now for one that looks fun.
I know you guys can hear me now, right? Right? Hello? What about now? What about now? Now I can. Okay, is the audio okay? Because I originally had my AirPods connected. Now I'm just using my voice. So I had it disconnected. I don't know what happened. It just broke in between it. Okay. Okay, so shoot, I was trying to find a related rates problem for Evan. I remember that. Um, okay, guys, sorry for the technical difficulties. First time trying to do these stream things, so um, I don't really know what I'm doing. Oh no, I mean I know what I'm doing in terms of the streaming. Okay, so this is for Evan. I found this related rates one. Let's try to do it. And then Sean, what were you talking about the daily integral? Where is that? Is that on the? Where would I find that? Or, you know, just let me know. Okay, so this is a. Just search up daily integral. It's a website. Okay, I'll do that. I'll do that after I explain this one for Evan. Evan, are you still here? So I know that like I can try to explain this to you. All right. I mean, I actually I don't know if you're still here. Okay, so basically, let me set up what this problem is. So, okay, yes, I don't know what that. I don't know what it says. Okay, yes. Okay. So it says a 10-foot ladder is leaning against a wall. This is the wall here. Let me make it like this actually, so you guys can tell that it's more of a wall. So the base of the ladder is sliding away from the wall at a rate of 1 foot per second. So that's what this is. It's sliding away from the wall at a rate of 1 foot per second. And it's asking how fast is the top of the ladder sliding down the wall when the base is 6 feet away from the wall. Okay, so this is awesome. We have everything we need. The first step, these ladder problems, I remember when I first did them in my calculus class and I hated them and I struggled with them and I did not know how to do anything. I remember on a test, the teacher, he literally left up like the steps you're supposed to do for the ladder problem. He accidentally left it up and it was the last question on our test and I still couldn't figure it out. I drew like a triangle and then I called it a day. I did not do well on that test. Anyway, so with all related rates problems, the way to do them is you have to find the function that relates everything, and then you basically differentiate the function. You plug in what you know to find out what you don't know. Now, for ladder problems, I believe every single time you're going to want to use the Pythagorean theorem. So we have x squared plus y squared equals z squared. This is how I was taught to do it, but you can do whatever you want here. So in this case, z squared is going to be our hypotenuse. X squared and y squared, they can be whatever, but one of them is going to be 6 feet, the other one's going to be a variable. So let's, first off, let's figure out what this distance here is. So the way that we do that, we plug everything in. So we have, I'll just put in 6 feet for x squared, so that's 36 plus y squared is equal to 100. And then y squared is equal to 100 minus 36. And that is what? 64, right? Which means that y is equal to 8. So nice. We know that this distance is equal to 8 feet. Does that make sense, Evan, so far? I'm just going to erase this so that we have more time. We have more space. Okay, I hope your answer to that is yes. Uh, quit farming. All right. So now that we have that, this is the function that we're going to want to differentiate. Okay? So we're going to differentiate this whole thing with respect to time. So we can do that. This is going to be 2x dx dt plus 2y dy dt is equal to 2z dz dt. And I'm only writing this like poorly because you can notice that all these 2's cancel out. So then I'm going to write it again neatly here. X dx dt plus y dy dt is equal to z dz dt. Okay? Oh, shoot. So now that we have this set up, okay, we can plug in everything. So right now what we're trying to find, let me reread the problem. We're trying to find how fast the top of the ladder sliding down the wall when the base is 6 feet away. So if we're trying to find out how fast the top, this is where the hardest part of the problem comes in for me, is figuring out based on the question what we know and what we don't, because you have to translate it into like your DDTs. So it's asking how fast is the top of the ladder sliding down the wall when the base is 6 feet away from the wall. So how fast the top, that sounds like our dy dt, because y is 8, which we found here because we made x is equal to 6. So we're looking for how fast basically this distance is decreasing, which is basically how fast the ladder is falling. And they also tell us this. They say that the base of the ladder is sliding away from the wall at a rate of 1 foot per second. That is our dx dt. Now, the hardest part here, and I might get confused on this as well, is figuring out whether or not dx dt is positive or negative. Okay? I actually, let's mess around with that one later. Let's plug in everything we know. So, we know that x is equal to 6, because this is the distance here. We know this is 6. Our dx dt, I believe if it's going to the left, usually in math it's going to the right. Usually in math, to the right is, usually it's positive. I'm going to keep this one as positive, but I might mess around with this later. I'll refer back to the video. I don't know. This could be positive or negative. I have trouble interpreting that. And then we have our y value, which is 8 feet. And then dy dt is what we're solving for. And now our z is equal to 10. And you might be thinking, well, what is dz dt? Because we know what dx dt is. Well, I mean, kind of. We're looking for dy dt, but how the heck we find out dz dt? Here's the trick. These things these ddt's refer to the rate at which a thing is increasing or decreasing. Like, for example, for dy dt, the distance from the top of the ladder to the floor, that can increase or decrease. For dx dt, the distance between, again, the ladder and the wall on the floor, that can increase or decrease. Z refers to our ladder itself. The ladder is not going to collapse or expand. The ladder is going to stay constant. So therefore, dz dt, or the rate at which the ladder is changing, is going to be 0 because our ladder doesn't change. So actually, this whole thing would go away because it'd be multiplied by 0. Bada bing, bada boom. Now, what we can do is we can move the 6 over to the other side. Just want to make sure, like, okay, yeah, in this video, the guy says that the 1 is positive, so yeah. So now we move the 6 over. So we have 8 dy dt is equal to negative 6, okay? Now we just divide by 8, and dy dt is going to be equal to negative 6 over 8, or negative 3 over 4 feet per second. I believe it's feet per second. And yeah, that's how you would that's how you'd approach these ladder problems. Does that make sense? Yeah, negative 3 over 4 feet per second. Evan, do you have any questions on that? Did that solve? So all the questions for the ladder are going to be pretty much the same. They might usually the biggest thing that stumps people is the dz dt, because they're stuck with not figuring it out. And everything else I usually give you, again, for me, the hardest part is figuring out whether it's to the left or to the right in terms of whether or not it's going to be positive or negative. Thank you, Evan. Very helpful. I know if I had my donations open, you would send me $1 billion. So, okay. Oh, guys, I didn't even notice we hit the 3-hour mark. Yes. 3-hour mark. Okay. Here. If only this came a month ago. I'm sorry. I'm sorry, Evan. I was busy. Okay. Okay, so I need to update my question count. I don't know, we're on like 17 now. This is honestly just for whatever. This is for aesthetics. Alrighty. Hold on, I'm just gonna figure out something. Alright. Now let's just do more calculus problems, because that's pretty much what this is. Just doing them until I can't. I'm surprised it really hasn't felt like 3 hours. 3 hours yet. This hasn't felt that bad. I think, but my legs definitely feel it. That's the rough part. Okay, let's gonna do more calculus problems from my sheet. Just trying to. Need to like. Don't have the anymore. Okay. So this question is the limit as x approaches infinity of yes, I am having, wait, hold on, x cubed over e to 3x. Okay. Okay. So, we're trying to evaluate this limit at infinity. To my better judgment, I believe that if we plug in infinity on the top and infinity on the bottom, we get infinity over infinity, which is no bueno in the mathematics world. You don't want infinity over infinity, you don't want 0 over 0, you don't want indeterminate, because those are what's known as indeterminate. Those are so if we plug in infinity, then we get, now we can do if you get infinity over infinity, then you're allowed to do something called L'Hopital's rule, which basically allows you to take the derivative of the top and the derivative of the bottom, the numerator and the denominator, and then evaluate it again. And then you just keep doing that if you get 0 over 0 until you get an answer. So if we do L'Hopital's rule, I like to do this. I think some other people do it as well, where you put an h and three slashes just to indicate that you're doing it. We would say the limit as x approaches infinity of 3x squared over 3e to the 3x. All right. E to the u. Yes. So then these 3's cancel. We have x squared over 3x, e to 3x, which is the same thing. Well, it's not the same thing, but it's like, it's also that, so we could do L'Hopital's rule again, I believe. Limit as x approaches infinity of 2x over, because I mean e 3x, the derivative of that is just 3e to 3x. And then, yeah, so that would just be 3e to the 3x, which is the same thing. So I think if we do it one more time, sorry, 1 second, guys. Then I believe this is right. 2 over 9e to the 3x, which should be wait, I actually don't know this one, which means it sounds like who's here still watching. There's a few people here, so like I'm curious who's still watching the stream right now. It says there's 2 people. Me? Yes, Cheyenne, my boy, my goat. Who else? Honestly, Cheyenne, the other viewer might be me. Oh wait, Louisa. Yes. Okay, guys. Okay, yes. Oh, sorry. I think my view count says 3. It says 2, but okay. I'm glad that there's still a few people watching. Okay, so Cheyenne, you want to help me out here on this this limit, because I think I messed up somewhere. I don't know if it's with e or whatever. It's the limit of x cubed over e to the 3x. So I might need your help here. I will do a punishment once you help me, because that is the next punishment. So I'll spin the wheel again, and I'll try to actually, I don't know, maybe it will be an actual punishment. So, because I'm thinking like, it's infinity over infinity, right? For at least the first one. It'll be D and E, does not exist. Okay. Okay, it'll be D and E. Well, 0 of infinity. Why would it, like, was I on the right track though with doing L'Hopital constantly? Or what, did I seem to do one more time? Do you know? I'm trying to figure that one out. But the numerator goes to 1. But if the denominator is infinity, then it'd just be 0. Or what does the denominator become? Because if I do L'Hopital's once, then it's the limit as x approaches infinity of 3x squared. You'll get 1 over like 24e to the 3x. But 1 over infinity is 0. So Sean, that means you have to do a punishment. No, I'm joking. All right. So yeah, so it should be 0. Okay. All right, guys. That means it's punishment time. So let's get the wheel out. Let's interact with this. I'm gonna remove the 1 over infinity. Yes, it does equal 0. That's correct. Let's spin the wheel. Oh no. Okay. So I got salt water. So okay guys, I'm gonna try to do this in the, let me like look something up. Like how dangerous is drinking salt water? Okay, so I added originally about about I don't know how much salt. That's like a lot of salt. Okay, I don't know if I'm gonna drink the whole thing because I added like a tablespoon. How many punishments do you have to do? How many punches do you? Oh, that's just this one because I tried the pogo stick and it didn't work. Oh, actually, there's one. There's one that I have to do that you guys get to decide because I tried the pogo stick and it failed so miserably. So I thought I would let you guys pick one. Let me fill this up with water. I'll be right back. Okay. So eat the pepper. Okay, I'll do the pepper in a little bit, but right now I have to do the saltwater one. Okay, I don't think I can drink all this because I think I will go into like kidney failure. But um, use no. The salt water looks disgusting. Okay, I'm gonna do another problem. Just let this try to dissolve a little bit, and then I'm gonna drink it. So I'm gonna do one more problem, but I have it right here, and I need to get like a I need to get a trash can just in case. Okay, let's just do one more problem, and then I will. I'm gonna drink a little bit. I'm not gonna drink all of it because I don't want to throw up. I don't want to. I don't want to have my body shut down on me and other things. So okay, let's just do this. Let's just do the. I'm gonna do this in red because I need to mix things up. Shoot. What type of calc questions are you doing right now? I'm just doing AB questions. I'm not doing anything BC specific. So these are just, I guess these are technically AB and BC questions, but BC are going to be like series and other fun things. This is just, I've done a lot of studying for calculus, so I have a lot of questions saved in my files. So right now, that's the easiest thing I can do, just pull questions and just grind them out. And things like that. I think we're on question like 19 or something. All right. So the derivative of this is going to be another quotient rule question. So remember, for quotient rule, you want to do low d high minus high d low over low squared. So in this case, low, which would be x squared plus 1, d high, which in this case would just be 1, minus high, x plus 1, d low, which would be 2x, all over low squared, which is x squared plus 1 squared. So now let's clean this up a little bit. This would be equal, I don't know why I'm starting to write this stuff at an angle. I think it's starting to get to me a little bit. X squared plus 1 minus x minus 1. Which I need to multiply this by the 2x, so this would be 2x squared plus 2x. So it would be minus 2x squared minus 2x. So these would subtract here. So this would be minus 2, minus x squared minus 2x plus 1 over x squared plus 1 squared. Okay. And then low d high minus over rho squared. I know you can factor this. It's looking factorable, but I just hate these. I hate these negatives. These negatives make me very annoyed. So I don't know if the answer choices are left like this. Oh, they are. They are. Okay. So okay, then yeah, this will be the answer. I didn't know if they wanted me to simplify it. Okay, so guys, just excuse me 1 second. I'm gonna go to the bathroom again. I'm gonna drink a lot of liquids, and then I will drink a little bit of the salt water. So stay tuned for that. Okay. Okay. So, guys, it is time to drink. Yes. Yes. Okay. I will be drinking a little bit of this salt water now. How many people are here? I think there's a few. How many viewers? We had 5 viewers at one time. Wow, that's crazy. That is that is insane. I am so proud of us. Let me just like. There's 11 likes. Let's go. Let's go, guys. Okay. So. Okay. So. Oh my gosh. Okay, so the water is cleared down now. You'll have more soon. Thank you. So you can see the salt at the bottom, but a lot of it's dissolved. Let's give it just like a little preliminary taste. Oh. That is potent. Oh. Okay, so I think how much drinking do you guys think is fair for the first punishment? Like where do you think? I'll leave it going for a second. I think you gotta drink more than that. Well, I will drink more. That was just a taste. I'm telling you, it's just a taste. Okay. What do you guys think? I want to follow what you guys say. Half. Half. Okay. So I will drink. There's like you guys can't see it, but there's like a little ridge line around here. So drink that. Oh my god. Oh. Half. Still more to go. You're actually my enemy. Oh my god, guys. There's a lot of salt in here. Oh my god. Ugh, I don't like this. You want more than that? Like a little more? Just don't throw up on stream. This is supposed to be PG-13. I know. Okay. I'm gonna do like one more sip. One more sip. One more sip. Oh. Oh my gosh. I need. Okay. 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 That's good. Okay. That's disgusting. Okay, you said that there'll be some more people joining. Okay, I will say this. So when um when there are more people here, if we can get to 10 viewers right now, if we can get to 10 viewers, I will do the ice bucket challenge. I will go outside and I will dump an ice cold bucket of water, and then I have towels set up across my room, and I'll just keep doing math problems. If we can get to 10 viewers, guys, I will do that, okay? Oh my god, that was I looked it up. Drinking salt water like that salty is not good for you. I think it's dangerous or something. So, I would just like don't follow what I'm doing. Seriously, this is not don't do this. Don't do this. Okay, it's okay. Did you guys hear? Whoever's here, did you see if we get to 10? If we get to 10 viewers, I will do it, okay? Because right now it says there's only one person watching, I think, or three, or I don't know. I have it open on my screen, so. Oh, we have. Oh wow, the subscriber count's been going up. Thank you guys for the subscribers. Wow, I didn't even notice that. I think I'm at 81 now. Thank you guys so much. I have promoted you. Thank you. I don't know what that. Like, on your story, or um, what do you mean by that? What do you mean by promoting me? I'm scared. So, okay, guys. What kind of questions do we want next? What kind of questions do we want next? I'm open to anything. I'm trying to keep my momentum up. That salt water, I'm actually think I'm only gonna do that one more time for my safety and also for my sanity, because that was not good. Like that really was not good. I did not like that. I would rather have done other things. Okay. Uh, okay. Only Bunny 672. You've been typing a lot. What question do you want next? What kind of are you craving any sort of math question? Do the ones I sent from pre-calc. Okay, I don't want to do those though. The guide I sent. Let me specifically. What do you mean specifically? Why? Wait, wait. What do you mean specifically the guide? Like the number 26? Oh my gosh, what is this? I failed that on my exam. Okay, wait. Wait, let me check. Yeah, can you send me that problem specifically just so I know to do it? Also 23. Okay. 23. Observe two ships directly offshore. The angle of depression of the ships. Wait, hold on. Oh my gosh, wait, that's salt, guys. Don't drink salt water. Okay, hold on. Let me open it up here. So you said 23 and 26, right? Right. Also 23. Okay. I got you. I got you. Okay. Okay. I don't. Let's see. I don't know. I remember these types of questions. Can we see it? Yes, yes, you can. Let me let me let's pull it up. So so we're looking specifically for question 23. Makes so I'll leave it up there for a little bit. Okay. Hope that was enough time. Uh, the first thing I'm thinking of is okay. An observer in a lighthouse 350 feet above sea level observed two ships directly offshore. How far apart are the ships? Okay. Okay. Only Bunny 672. Let's. Why don't you walk me through what your thought process was in the beginning? Like we could try to go through this together. Because these questions, I'm gonna be honest, I suck at them too. Okay. I'm not good at these questions either. You know. Let me see. Hmm. Well, what's an angle of depression again? No, no, I'm going to cry. Okay, that's no, that's not true. Or 4 and 6.5. Uh, I think I need a calculator for this one. And then, oh wait, and then could I? Okay, but I started with sine 4 and sine 6.5, an angle that comes down from the horizontal line, and then 350. You do. Hmm. You do. You do what? What do you mean? So, you started off with sine. Could I be wrong? Okay, let's. For an angle depression. So basically, sine of 4 equals 350h and sine of 6.5 equals 350h. Is an dot 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 is an angle of depression. I actually don't know. Let's figure this out. This is what the whole point of this the streams for is. It's for learning new things. So why don't we figure out what an angle of depression is? Angle of depression. So an angle of depression is an angle formed between two horizontal line of sight and a line of sight down to an object below. It is commonly used to calculate heights and differences. Oh, okay. Basically, it's okay. So in this case scenario, like this, I'll show you. Wait, I need to open up OBS. Um, so for this, an angle of depression, for we see this horizontal line. That's basically your line of sight, and then the angle of depression is the angle between that and these objects. So we have the two ships here. So the angle of depression between these two ships for this one, it's 6.5 degrees, and for this one, it's 4. So the angle of depression just refers to like your line of sight versus the object, I believe. This is more geometry, basically. Yes. So, hmm. If we know. So yeah, I know it's I could tell it's basically more geometry, but um yeah, I'm still just like a little bit I'm not good at these questions. I do remember doing them and I remember struggling a lot. Uh how far apart are ships? So I think what we need to do first though is we need to find the distance between the lighthouse and each ship. And then we just subtract the difference because then that should be the distance between the two ships. So the angle of depression, the ships are 4 and 6.5. So, hmm. Um, honestly, I don't. This one's really stumping me. I hate these types of questions. Do you still want me to try to keep doing them? Because I don't know if I can help you with these. Honestly, this might be this might be my what gets me is these simple geometry questions. Well, they're not simple. They're difficult, but yeah. Whatever you want, because I don't know if I'd be able to help you with this one. Hmm. Try doing it and I'll help you out. Okay. So it looks like kind of an upside down triangle, right? If anything, I'll send you others. I don't like these questions. Um. Hmm. Hmm. Oh, okay, wait. Okay, hold on. I think use trig to get the lengths. Okay, yes, I believe. Okay, I think what you have to do is only bunny 672. I think the issue was that you use sine. I think you need to use tangent, because in this case the angle you have to think of like if the horizontal line, if it's like, yes, because it wouldn't be the hypotenuse. It would be like, because it's kind of like this. So you have it like where it's kind of, it looks like this, and then we got like, this is like the horizontal line. This is 350 feet, and we have like, for example, like one thing towards like one ship, right? And what I'm thinking is that if we know that, like, for example, one of these like 6.5 degrees, then if we want to find like the distance, you can't think about it like this is a triangle. You think about like this is a triangle, and then we have it would be adjacent over up or whatever that's why it would be tangent, I believe, because if we're trying to find the distance, I would believe that it'd be something like tangent or like that. Does that make sense or no? Because yeah, okay, great. Because the opposite side, because this would be that the adjacent side is this distance. So then if we do like tangent of 6.5, my gosh, that was bad. Tangent of 6.5 would be equal to uh is tangent opposite over adjacent? Or, yeah, it would be like whatever this side is, like 350 over x, and that x would be the distance. So then it'd be 350 over tangent of 6.5 for like one of them, and then you just do that for each thing. So make sure you figure that one out. That was impressive. Sometimes it's these other questions that they're just difficult. Just very, very difficult. And trust me, I struggled with these exact same problems, and that's why I still can't do them, because I avoided them, which you should not do. Okay, let's see. Well, you sent me another one. What's the next one you want me to do? What is the okay? Consider okay. I'm looking. Been sent a lot of questions, so let's look at these. Great. Guys, remember, if we can get to 10 viewers, I'll do the ice bucket thing. It'll definitely wake me up a little bit. Okay, I'm trying to see. So there are some of these like simplify questions. Alright, so I'm gonna try this one. I don't know exactly if I'm doing it right, but it's gonna be, it just says simplify. It just says simplify. So x plus 4 over 9 x plus 9 plus x plus 4 over x plus 9. Oh yeah, that's all it is. It says simplify. Also, guys, we are. Do you have the answer to the trig problem? Oh, no, I didn't. I think only Bunny672 might have the answer. It's just because I helped her understand it um, because what she said that she did earlier is that it she used sine when it should have been tangent for evaluating the angle, but you need a calculator. I don't have a calculator on me right now, and I don't want to do that. But I can leave the problem back up if you want to do it, but I don't think I'm gonna finish that one because it gets a little messy with the trig. I want to try to leave it only to stuff that you don't need calculators for. So if that's okay, hopefully. And then we are also, again, I think I already mentioned, we are approaching 4 hours. So I'm excited. Okay, just checking. All right, awesome. Okay, so this just says simplify. Also that's salt water, kind of hurts my stomach, but I guess I'm just gonna try to simplify. So the first step I would do is to just distribute the 9, do x plus 4 over 9x plus 81 plus x plus 4 over x squared plus 9x. And then I think I just need to multiply this side by x. Oh wait, no, I need to multiply this side by yeah, because these are the same, and then multiply this by 9 and this by x. Yes, so I think I just need to multiply this side by 9, because that would give me 9x squared plus 81x. And then if I multiplied this by x over x, then this would give me 9x squared, which I would get here, and then this would give me 81x, which I would get here as well. So that's what I'm thinking. Now we distribute everything. We can pretty much put parentheses over this to make these easier to look at. And then, why do I keep writing like that? Also, okay, I think I might have to take away the salt water because it's not making my stomach feel good right now. It might have been a little dangerous. Anyway, x squared plus 4x divided by 9x squared plus 81x plus 9x plus 36 over 9x squared plus 81x. Alright, cool. So now that we have the same denominators, we can add these. Also, Only Bunny, I need you to send me the answer, or at least check to make sure that I got this one right, because I actually don't know. I don't have a way to check it. So now if we add these two together, and I'm going to do it over here, this would be x squared plus 4x plus 9x would be 13x plus 36 over 9x squared plus 81x. Okay. Okay, I already know, like, oh, I don't know anything, but at least in this denominator here, I know that I can pull out a 9 and an x to just give me x plus 9, or x squared plus 9. That might be, well, x plus 9. So now if I see x, okay, bam, that kind of made everything click in my head. I'll explain what just happened. So I see that I have a quadratic on the top and I have a quadratic on the bottom. And just based on the nature of these types of problems, I know that something's probably going to cancel. Now, this top part looks ugly right now. I don't even want to think about it. But this bottom part, I noticed that there's a 9 and an x in both terms. So I pulled out a 9x and I got x plus 9. And I was thinking, like, okay, wait, I can pull out a 9 first and I get x squared plus 81, or x squared plus 81. Or no, sorry, I pull out a 9, so I get x squared plus 9. But then I was like, because if I factor this, there's not going to be an x squared. What's the answer right now? Wait, hold on, I'm almost done. I'm almost done with it. Since I noticed this x plus 9, I saw back here, like, these 4s and these 9s, like, it connected somewhere. And I know that 9 times 4 is 36. 9 plus 4 is 13, which means that I know this factors to x plus 9, x plus 4 over 9x times x plus 9. And this cancels, so then you're just left with x plus 4 over 9x. That would be at least what I think is the answer. I'm waiting for some confirmation. Well, from how I did it, it's not. Wait, how did you do it though? Explain. I might have skipped a step. I might have done it a little too quickly. You gotta talk to me here. What did you do? Here, let me check my steps. I multiplied by. Yeah, what do you mean? Like, tell me how you approached it, and we can figure this out. So, yeah, you have to find the common denominator. This was the original problem, and if you notice, this x plus 9 is the same as this x plus 9. The only difference is that there's an x in front of this and there's a 9 in front of this. So that would mean to get them the same, multiply this by 9 and multiply this by x. So then we have 9x for both of them. Or at least that's how I approached it. I don't know. Yeah, I'm just waiting for. Wait, sorry, I read the wrong one. You're right. Oh, okay. All good. All good. Well, in light of that, let's do an even uglier one with M's. Good job, bud. Thank you. Thank you. That means a lot. Also, look at my. This is the towel. I've been using this towel since I got this whiteboard, and it's been with me through 2 years of calculus, and you could just see that the. It's had better days. It's had many better days. You can see this there, and then the back side. There's a few splotches, so it's kind of crazy to see how the things go by over time. All right, or wash it? No, there's we gotta get you a new one. No, this has memories. This has. I will wash it or buy a new one when I literally can't use this anymore. You know what I'm saying? It's special. It's special. It's been through me with a lot. Okay, so this is another simplifying one that I got sent. So this is m plus 5. Oh, never mind. It's m plus 9. M plus 9. M plus 5. M plus 5 divided by 20 m plus 8 divided by m plus 5 m plus 7 divided by 15 m plus 7. Okay, I believe I did that right. Okay, so all right, I did not give myself that much space, but let's try this out. So first things first, dividing is the same thing as multiplying by the reciprocal. So I'm gonna, even though I spent all this time writing this, I'm just gonna write this again as. Let me try to do this a little neater. M plus 9, m plus 5 over 20 m plus 8 times 15 m plus 7 over m plus 5 times m plus 7. Wait, there's okay, so now that we've cleaned this up a little bit, I can tell that there's a lot of things that will cancel. First off, this m plus 7 is going to cancel with this m plus 7 up here. This m plus 5 is going to cancel with this m plus 5. And now we can rewrite this again as m plus 9 times 15 over 20 m plus 8. And now the 15 and the 20, you can divide both of those by 5. So then that would equal m plus 9 times 3 over, I'm just going to put the 3 actually over here because that's how you're supposed to write it. So 3 4m plus 8. I believe I'm doing this correctly so far. And then it's just simplified, so I'm gonna go all the way. So we have 3m plus 27 over 4m plus 32. And then I believe that's everything I have. So let me know if that's correct or it's correct. If you're still watching, I don't know. Oh my god, guy, we're about to hit 4 hours. About to hit 4 hours, guys. I can't believe it's already been 4 hours. That doesn't felt. I mean, I don't know if I'm lying to myself at this point, but. Four hours already? Yes, 4 hours already. 4 hours already. I might DoorDash some food just because I haven't had anything today. So maybe I might take a little break just to have a burrito or something, you know? But yes, it has been 4 hours. It has been 4 hours. Okay, so is that the answer though? Is that correct? Is that right? Yes, but let's simplify it more. I guess. Like you want me to like separate the fractions, or is that what you want, or even more? 3m plus 9 divided by 4. Wait, no, I had that. I have that right here. I just distributed it because I thought I don't know. Oops, I didn't see. Okay, you're all good. You're all good. Yes, we're covering it. Yes, you were covering it. Oh yeah, you just called me fat. Okay. Okay. Oh, all right. Okay, let's that was not said, and remember, kid friendly, but I said that you were calling. Okay, my bad. My bad. So this is gonna be 20b. This is gonna be x plus 2 over 2 plus 3 is equal to x plus 3 divided by 7. All right. Now, this just says solve the following rational equations. So yeah, let's just multiply everything out. Multiply everything by 2. That gives me x plus 2 plus 6. So this is just 8. X plus 8. Wait. Yes, x plus 8 is equal to, then this would be 2x plus 6 over 7. And then, are you ready for the AP scores? No, I'm actually not. I'm not. I actually saw the score distribution for AP Calculus AB. For BC 46. I think it's 46% of people got a 5. So I'm hoping I'm part of that 46. I don't know. I'm scared. As long as I can get a 5 on BC and a 5 on stats, then I do not care about anything else. But if I don't, then I'm a little bit, I'm a little scared. Okay, multiply everything by 7. Is 8 times 7, is that 56 or 54? I always confuse them. Well, because 8 times 8 is 64 minus 7. Is it 57? How about stats, though? How about stats, though? Stats? Stats, I want to get I don't know what the score... Actually, let's look up what the score... Did you see the distribution for people that didn't pass stats? Okay, let's see. AP stats, score distribution. Okay, so the stats score distribution says... Wait, why is my thing weird? AP statistics. It says 17% of people got a 5. So... But the amount of people that didn't pass stats... Oof. A good chunk. 38% of people did not pass. That's rough. I think I definitely did pass it. I think I got a comfortable 4, maybe a 5. That's how I felt but also I noticed that from where I live, or where we live, when I was trying to look up afterwards and compare questions for both calculus and stats, we had different tests than the majority of people. Like, a lot of people had different forms, but we had a like, not the common one, I guess. I don't know. What's 8 times 7? 56. It's 56. I'm stupid. Okay, 56. Oh really? Yes, I just looked it up right now. Is this the answer? Is x equal to negative 10? Because for physics, a lot of people got the same for the FRQs, hashtag trauma. Yeah, hashtag I did not study for AP Physics because there are reasons for that. There are reasons for me not wanting to do that. Because my passion lies in calculus and the pure mathematics, not really applied, even though I was talking about stats, which is basically just applied math. So, what is there to do, you know? Because, yeah. Okay, wait, hold on, I'll be right back. Okay, wait, this one, the type of question I want to do for calculus, and it has to do with the convergence test, like, because I want to see if I remember how to do these things. Also, I know that, Only Bunny, I know that you just finished pre-calculus, but would you want a little bit of a calculus lesson, perchance? Because I could just, like, teach calculus for a good 3 hours or something. If you want. I don't mind, because it might be also just a little bit easier to do that for me, and then just, like, looking up problems over and over again, but whatever you guys want. You guys are the audience, so... That would be amazing. Okay, great. Okay, so let me just look at like the curriculum Okay, so that'd be amazing. Okay, so before I teach a little bit, I wanna say something very important. That this goes for everything. Um, for calculus and when you're approaching any new uh, type of math, you just have to be very open to being bad at it because especially for calculus, it's going to be the biggest jump you've ever done from anything. Because I remember when you first learning algebra and you learn about x and like they say x can be any number. You're like, how can that be any number? It's x. What's a variable? That jump is gonna be way, way, way different when you learn about these squiggly lines and everything. Cause calculus is rough and it's hard, but there's no substitution for practice. Because a story that I always tell people is that my calculus teacher gave us a full length practice test. I think about I think it was like two. I think it was about 2 or 3 weeks before the actual AP exam, and I scored. He told me on the screen it showed a 3, but I calculated myself, and it was more like a 2. It was a very comfortable 2. Like maybe it was a 3 with some insane curve, but it was a 2. And I don't know if you know this, but there are 6 FRQs. They're each worth 9 points, and on my first test I got like a 7 out of 54 in the FRQs. And then I studied really, really, really hard. And I did hundreds of problems, and then I got a 5 on the actual AP Calc AP exam. So I just want to say that first. Don't be discouraged, um, for with anything like that. So yeah. Hey guys, can you believe we streamed for 4 hours and 10 minutes? I might bring in my chair. Because I really need to stretch. I will try to be like you. Well, I could always help you. I plan to post some actual videos, like some actual lessons that are, curated. I just really want to do this live stream. I just wanted to get something out there. But just watch out because I will post a whole curriculum for Calc AB because I love calculus. So, the first thing that you really learn in calculus are these things called limits. Okay? And it's going to be written like this. It's going to say lim as x approaches something. Usually it'd be like infinity or 0 or like a number. It's whatever. But as x approaches something, I'll just say as x approaches 2 of a function or whatever. So let's I like to write them like this. I like to do a little cursive L. Or I like to go like, I don't actually do that, but you just have, that's kind of the thing. But let me give you an example of what a limit would be like. So if we have a graph, okay, and let's say that I just have a line. This is the line y equals x, right? It should look familiar. Okay, let's just add some points. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, this looks pretty familiar, right? So let's say I wanted to ask what is the limit. I'm actually just going to call this f of x because it'd be better. What is the limit of f of x as x approaches 2? Now, what this means is basically what y value does the function approach at a given x value. So x equals 2 is right here. This is x equals 2. Okay. So we could see right here that I have it lined up incorrectly, but let's just call this 2. We could see that this point here at x equals 2, y equals 2. Okay, but if we're asking for the limit, that basically means that as we get infinitely close to this point from the left side and the right side, as we just get closer and closer and closer and closer and closer, what point are we approaching? And in this case, it would actually be 2. It would equal 2, because as we approach the limit from the left side and from the right side, we both get 2. And let me give you some more helpful examples that will make this a little bit clearer. So, let me just maybe to do like a different color. Let's do this. Okay, so let's say I have this graph, and like again we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So let's say I have like okay. Have you seen something like this before in your pre-calc class? Kind of like, you know what these closed circles and open circles mean? Or no? Yes, I have. Okay, so just in case anyone who's watching and doesn't, when it's a closed circle, that means that that value is included in the line. So for example, at 3, for this part of the line, for this part of the graph, it's included. For this part, it's not. So it just means like it's undefined at that point. Okay? So this actually is a very popular type of graph to explain all the properties of limits. So now the definition of continuity basically just means that I believe it's that the limit from the left equals the limit from the right. And how you'd write that is you have the limit as x approaches, let's just use 1 here. Let's just use 1 as an example. As x approaches 1 from the left is of f of x, we're just going to call this whole thing f, is equal to the limit as x approaches 1 from the right of f of x. Now, we could see that at the point 1 here. Wait, this was taught in the first chapter. Oh, this was? You guys learned limits? Oh, shoot, my bad. I did not realize that. Okay, do you want me to just move on to the next thing then?
On each side.
Do you guys want me to just move on to the next part then? Or here, I'll just keep teaching this just for the sake, but yeah, okay, wait, not fully. Okay. So again, the limit from the left equals the limit from the right. Now at the point 1 here, which is this point here, we can see that on the graph, as we approach 1 from the left side, as we approach 1, our value is 3. And as we approach 1 from the right side, our value is 3. That means that the function is defined at this point. So that means that we could say that f of 1 is equal to 3. Because it's continuous and it's defined and all that good stuff. But just like life, it gets a little bit more complicated than that. So I didn't oh my gosh, I did not draw this here for any I drew this here for a specific reason. So if we take the limit as x approaches 3 of f of x, what would this equal? Now, as we approach, to figure out what this is, we have to evaluate the limit from the left and the limit from the right. So I'll do right over here. The limit as x approaches 3 from the left of f of x, let's see. As we approach 3, from the left side, we get 3. Oh no, sorry. As we approach, the y value we approach, as we approach 3, is going to be 3. So this is going to equal 3. Now, the limit of f of x as x approaches 3 from the right, as we approach 3 from the right side of the graph, we could see that we approach 1. So, what's going on there? So, this means because our left-hand limit and our right-hand limit approach different values, then the limit itself does not exist. Because again, if we continue this from the left tail end, we get 3. We get 3. But if we approach this from the right, we get 1. And that's not good. But yeah. However, you could see that these points are overlapping. So what that means is that although the limit might not exist, f at 3 actually does exist. Because there's a filled in dot here. So even though they approach different values, the function at 3 exists because of this point. If this point wasn't there, then it would not exist or be undefined. They're the same thing, pretty much. So, yeah, and then here's another good example. Hopefully that made some sense. Let me redraw this like this. So let's say I had this, right? Say like this just continued. So we have this line here. Okay? Now, the limit, now let's say I do remember about this, but this is a good refresher. Okay, I'm glad. So, in this case scenario, let's say I wanted to find the limit as x approaches 3. So, the limit as x approaches 3 of f of x, in this case, it would equal 3. The limit is 3 because as we approach 3 from the left, we get 3. As we approach 3 from the right, we get 3. So in this case, the limit is equal to 3. However, f at 3 is undefined because there's an open circle here. So that's one thing important to understand about limits. Limits are when we get infinitesimally close to a point. Like, what are we getting there? Like, imagine right now I have like chat opened up right here, and right now I'm right here. Let's say like I know that this distance, okay? I know the distance between me and my computer, but every time I walked forward, I went half the previous distance. So like this here, I walk half of this, and then I walk half of this, and half of this, and then half of that, and then half and half and half and half and half. This is a very famous problem because people debate on whether or not you actually arrive at that destination, but you will never actually touch it. Like if you are in front of a wall and you try to get to that wall, but every time you go half the distance, you will never actually touch the wall forever. Okay? But you'll basically get there. And that's the point of a limit. We're not at the point, we're really, 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 really close to it, and we're just seeing what it does. Because the point itself is undefined. Hopefully that makes sense. So, yeah, at this point f of 3 is undefined, but the limit, they change like that. That's pretty much all you have to know about limits. Just like the open circles, the closed circles, the how to read limits from the left, limits from the right. Because a lot of times on the calculus exam, on the AP calculus exam, they'll give you a graph and there's like a bunch of squiggly lines, there's a bunch of sharp turns, and there's a bunch of open circles, a bunch of closed circles, and they basically ask you like a lot of questions like, is the limit as x approaches 3 from the left, is like, what is it, defined, undefined, whatever. And that made a lot of sense. Good example. Thank you so much. That means so much to me. I might need to do like I might need to go get food. Well, maybe I need to like I am so hungry. Hold on. Actually, I do not know. Here, we'll do that in a little bit. Um, we never stop. We never stop the math grind. We never stop the math grind. Uh, okay. So, take a good break. No, there's no breaks. I would be eating as I do this, but maybe I would like to get like a Chipotle burrito or something. Let me figure out how to get DoorDash on my iPad, so I don't have to break the camera. But I mean, yeah, I hope to do more of these. I know I mean, the whole point of this was just kind of like just to do math. I don't know. I haven't mentally broke down yet. I've been going pretty strong, but this has not been as taxing as I thought it was gonna be. I just kind of wanna. I do want to keep knitting my sweater though, because I'm making good progress. But we've also making good progress on the stream. We're almost at 4.5 hours, so that's something to be proud of. Hold on. I'll find a good diabolical question for you. Okay, but make sure I can actually, do it. Okay. Well, you're finding a problem trying to order a little bit of food. Oh my gosh. Okay, I hope these problems are not horrible, but sorry guys, this is taking me a second. Here, wait, let me just fix this up real quickly. Should have done this in the beginning. Okay. We have successfully DoorDashed Chipotle. So feeling good about that. Now in the meantime, a good friend of mine has just kindly sent me some very diabolical problems. So let's see. We're back. We're back and we're ready for more. Okay, let's see these problems. Problems show that the limit. Okay, so only bunny 672. I will let you know that for the first one you sent me, I can't do. It's with I don't know I don't know that some of that notation and stuff. And then the other one, I don't know if I can do that. Wait, hold on. I need to get my chair. I need to bring a chair. I can't. I actually can't do this anymore. I've been standing for 5 hours straight. Oh no! I broke my chair. Oh. Ugh. Okay. Maybe I should like put this down. I'm starting to I think I'm starting to reach my. Can you move the camera? Do you want me to move it more down or? Oh, actually, I think I can actually. Hold on. Is that better? Okay. Oh my gosh. Yeah, I think we're doing this for 4.5 hours. Okay. Okay. Yes. Okay, I'm just trying to I think it's actually starting to get to me a little bit. I think it's actually starting to no, I have to control myself. No Red Bulls. I think someone's ready to give up. Listen, I already spent the extra like $7 that it would cost to DoorDash food, so I think I have a little bit of fight left in me. But it is I think like I took a little break when I was talking to you and other things, and I think now it's starting to hit me a little bit. Hit me a little bit. Okay, so let's continue on with what I was talking about. So the next step um, in calculus are the next step is derivatives after you do limits. Now there's a way to formally define derivatives. Derivatives are known as like the rate of change. So a good example, which I've given a few times in this stream, is like we have a graph. I feel like such a chud sitting down. I probably should stand up for this. I'll sit down when I'm eating, I guess, a little bit. But so if we have a graph, right? I think yeah, I'm not gonna give up. Okay. If we have like x squared, right? So the derivative basically tells us how like the rate is changing. So the best way to say it's not the best. I need to prepare a little more actually before I talk about this stuff. Yeah. Wait, actually, I need to. I don't want to. When I'm trying to teach something like this, I want to be very confident about it instead of just doing that. Let's do. Let's. Oh my gosh, I need to. Let's. I know because I still haven't even been able to do the ice bucket. I have so much stuff prepared, but not. I never got 10 viewers. So. so mad I forgot to do the series and stuff. Okay, I think next time we have to promote more. Yeah, I do agree, but I hope like for this, I think we got a few, people. I'm happy with I'm happy with this one, but I want to try to fight a little more. You know. So we will promote. Okay, so for this is something that well, this is something you're not gonna have to do till BC, so probably for college or I don't know. I don't know, but this is called it's called integration by parts. Uh. Uh. Oh my god. Yeah, you should be scared of some of these things are kind of scary. Uh, oh yeah, sorry. This one I'm I'm losing it. Okay. Oh, yeah. Uh, is he the only person watching right now? Might just be you. I don't know. I don't know if anyone else is actually on the stream anymore. People come on and off. It's okay. People will join. Yeah, I don't know. If you say so, we have 69 views, and the average view duration is actually 12 minutes, which is. I'm actually not too happy about that. So. Doing very well, thank you. Okay, so I could explain a little bit of what's going on here. So basically, when you have a fraction, right? Let's say, like, oh, I don't, well, I like don't know if I'm able to do it, but when you separate you can separate a fraction into like different things. Like for example, here, I have 1 plus 3x divided by 1 minus x and 3x minus 5. What I want to do here is I want to try to separate this denominator here so I can integrate this, because in calculus when you're integrating you basically can't integrate this. It just doesn't work. It doesn't work like that. I, this doesn't work like that. And so sorry, my chair is broken, so like it's falling off. And so what we're trying to do here is just separate this denominator into two separate fractions, because and then what we're doing right here is we're just trying to find what the numerators are. So basically I could write it down here. So basically the integral, just think through this. The integral of 1 plus 3x over 1 minus x, 3x minus 5 dx, is basically going to equal to some coefficient, or not, some constant of 1 minus x plus some other thing times 3x minus 5, right? Because yeah, well no, it's not actually the integral, but no, I guess it's like this. Yeah, it's equal to this. So I'm covering this. So we're just trying to split up this fraction here, because if you would multiply this all out, we should get this. And you cross multiply these things to get this up here. You have 1 plus 3x is equal to a times 3x minus 5, because you cross multiply that to cancel that out. And then b times 1 minus x, cross multiply to get that out. And then you just set x equal to different things to cancel either a or b to get them individually. And then you integrate that, because then usually, well no, not usually, that's how it works. Then it should be integratable. Sorry, I keep wondering here because I have my stream opened up here, so it's easy for me to see the chat and stuff. Yes. Oh. 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 Do. Man, guys, we were peaking. One time we had 5 viewers at one time, 5 concurrent viewers. Those were good times. This is very interesting. What, me or the math? It's GG's. What? What are you talking about? For next year? No, don't worry. This is BC stuff. I think you're gonna take AB, right? And also, it's really not. I mean, I just did not explain this well because I'm running low. But it's really, it's not horrible. And also, you just have to do more problems because it will eventually make sense, but only after you do more and more problems. And yeah, I think at this point I'm gonna try to sell. I'm gonna try to start doing some linear algebra and whatever, because unless you have more problems, because I'm not answering like those other ones. But you're tutoring me, right? Yes, I got you. And also, again, on this channel, I know that right now I seem like I seem out of it, but I promise you I will actually try to make high quality videos of me. You're not you, but you're tutoring me, right? You're not doing the pre-calc. Yeah, listen, I'm not. I don't want to do the pre-calc questions. Okay, I don't want to do those pre-calc questions. You're not answering the pre-calc. No, it's time for me to crack open this other book. Because I have a book right here called Linear Algebra. No! Oh yeah, is this the break? Linear Algebra done right. My only break will be when I actually eat some food. So, I guess, should I just read this? Like, why don't we learn this together? Because fun fact, for linear algebra, you actually don't need, you don't need to, like, take in other things. It's just that linear algebra is usually taught with Calc 3 or after it, or sometimes before, just because it's a little bit complicated. So yeah. But we could actually learn this together. We could learn this together right now. You and me, Only Bunny 672. It's a crazy name, by the way. It's a crazy name. Okay. You know what, C? What? I don't appreciate the negative comments from you. You know. No, not negative comments. I'm sorry. No, please don't. You're my only viewer right now, please. You don't understand. Please just stay. Wait, I think there's like 3 viewers right now. I don't know. I can't tell, like, I need to open up the stream on another tab for me to be able to, like, see if there are people. Oh, it says there's 3 people watching. That's crazy. What? Treat your fans right. Okay, yeah, you're right. I'm sorry. I apologize. Your name's great. I would love to know the origin of the name. So, yeah. Okay, so chapter 1, vector spaces. Linear algebra is the study of linear maps on finite dimensional vector spaces. This was from elementary school, okay? No, don't worry. On PlayStation, my username was always AwesomeDude2424, but it was Awesome Dude, and I always said it was Awesome Dude because the Awesome Dude was taken. I had to spell it incorrectly, but the truth was I just didn't know how to spell awesome back then. So yeah, I got you. Let's continue the story time. Linear algebra is the study of linear maps on finite dimensional vector spaces. Eventually, we will learn what all these terms mean. In this chapter, we will define vector spaces and discuss their elementary properties. In linear algebra, better theorems and more insight emerge if complex numbers are investigated along with real numbers. Thus, we will begin by introducing the complex number and their basic properties. We will generalize the example of a plane and of ordinary space to capital R to the power of n, and capital C to the power of n, which we then will generalize to the notion of a vector space. As we will see, a vector space is a set of operations of addition and scalar multiplication that satisfy natural algebraic properties. Then our next topic will be subspaces, which play a role for vector spaces and analogous to the role played by subset for sets. Finally, we will look at sums of subspaces and direct sums of subspaces, and then they give you a nice little portrait of stuff. We're approaching the 5-hour mark, by the way. Oh my gosh, my food's gonna be here any minute. Yes. Yes. Okay. Oh my gosh. Now we're actually getting into the fun stuff. Why we should celebrate, you should eat the pepper with your bowl. Okay, that to celebrate. I want to celebrate by eating the food, not throwing it back up, you know? Maybe again, listen, if we get some people going, maybe. Maybe. But let's continue. Okay, page 2, chapter 1, vector spaces. Okay, complex numbers. You should already be familiar with basic properties of the set R of real numbers. Complex numbers were invented so that we can take square roots of negative numbers. The idea is enjoy the food first. Yes, I should very much enjoy the food first. The 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 idea is to assume we have square root of negative 1 denoted by I that obeys the usual rules of arithmetic. Here are the formal definitions. A complex number is an ordered pair, A to B, where A, B is included. I don't know a lot of these symbols actually. I think the little like pitchfork, I don't think they teach that usually in the US. Well, I mean, this is a US book. I don't even know what I'm talking about. We're A and B, but we write this as A plus BI. The set of all complex numbers is denoted by C, where C is equal. I'm gonna write this down. These are notes and everything. So this is good stuff. This actually might be able to make me go on a little bit longer by actually trying to study the linear algebra. I might be going on for longer. Let's see. I don't know. I just wrote that down so that there's something on the. Oh, you guys can't even. Can you even see that? Oh yes, you can. Sorry, I have my screen set up incorrectly. Okay. It says addition and multiplication on C are defined by A plus BI plus C plus DI equals A plus C plus B plus D times I. I'm not gonna read the rest of that. What is that? What is that? I need to figure out what this math symbol means. Math symbols. I'm not getting. What does this mean? Oh, X is an element in the set of A. X is an element in the set of A? What does that mean? Belongs to. Okay, I guess just belongs to. If A here, A, B, C, and D all belong to the set of real numbers, okay. If A belongs to R, we identify A plus 0 times I with the real number A. Thus, we think of R as a subset of C. We usually write 0 plus BI as just BI, and we usually write 0 plus 1I as just I. To motivate the definition of complex multiplication given above, pretend that we knew that I squared is equal to negative 1, and then we use the usual rules of arithmetic to derive the formula above for the, what? Then we then use the usual rules of arithmetic to derive the formula above for the product of two complex numbers, then use that formula to verify that we indeed have I squared equals negative 1. Do not memorize the formula for the product of two complex. Yes, it's here! Okay, I need to wait for the DoorDash driver to walk away, but sorry if you could hear my dog barking. That's just how the cookie crumbles. So, as I was saying, I'll go pick that up in a second. Actually, wait, let me go right now. Guess what? We'll be, uh... Oh, shoot. We have food. We have food now. It's time for just a little break. Put this over the towel so I don't like make a mess. Uh, so what's the order? Okay, so my Chipotle order is a little basic. I don't like a lot of like crazy stuff. So I literally just get I got the honey chicken, guac, pinto beans, and white rice. You know, I'm lactose intolerant, so I can't have the cheese and everything. So, you know, we improvise. Oh, this is the only thing I've eaten all day, apart from the salt water. Now it's a fire order. Guys, we're about to hit 5 hours. How many more minutes until 5? 20 seconds. Oh my gosh. We hit 5 hours. Let's go. It's now 4 p.m. Wow. So my dog's down here, and he's looking at my my food, looking pretty delectable. But yeah. I'll feed my dog in about an hour. You still feel motivated into doing more hours onto the stream? I'm gonna try. I think I want to. I think I want to try to actually get a little bit of progress on the linear algebra, but I mean, man, I'm starting to feel it. I'm starting to like, I'm starting to get pretty tired. But also the sitting down helps because my legs are just so tired from standing all day. But I'm gonna go till I can't. But thank you guys for sticking with me this whole way so far. Also, who is Burger Gaming 101? Sorry, I just don't know I don't know a lot of people's names. Gotcha, yeah. You're really enjoying that burrito? Listen, this is the only thing I've had all day. And I've just been trying to get that taste of salt out of my mouth the whole time. It's good. And Chipotle always hits, you know? Always hits. Mm-hmm. I did get the pepper. Let me see them. I kept it in the bag. There's only two. Well, I'm gonna be right back. I need to throw it. I have to throw it. Okay. Okay. That was the lunch break. That was like a 5-minute little break here. Let me show you guys my dog. Alright, Saki, come on, you're gonna be on stream. This is him. This is Saki, because he has like little white feet, so it looks like socks. Yeah, he's a little chihuahua. No, it's Saki. It's Saki, not Rocky. It's Saki. So there you go, bro. Okay. Let's continue. Back open to the book. Okay. Okay, yes, now we're back onto... Yeah, honestly, I'm trying to think of how much longer I think I can go. I wanted to try to hit 8 hours because that'd be like a full school day. But that's 3 hours from now. I don't know if that's possible. We're just gonna keep going. We're not gonna think about that. Do not memorize the formula. Okay, the product can be evaluated by using the distributive and cumulative properties. Okay. Someone needs a Red Bull. That is some bad advice, but maybe. Maybe someone does need a. Does it say how many viewers are? How many people are watching this right now? How many people are we got here? Because I do not know. Is anyone watching or? I'm confused. I'm confused, guys. Hold on. Like two? Two means. I'll start sipping this. I'll start sipping this. You got two, big bro. Wait, Merrick. Yes. Merrick, welcome. Welcome to the stream. I hope you're doing great. Hope you're doing good. We're doing some linear algebra. We're doing this until I can't, and I'm getting close. Oh wait, you got three. Collab with Merrick right now. I don't know. Yeah, you want me to collab? Oh my god, I'm gonna fall. Caleb with Merrick right now. Yes, that's three guys. Three viewers is crazy. We're almost at an all-time high. You made it. You made it out of the big leagues. That's true. Oh my gosh, I did make it out. I'm doing fantastic. I hope you don't feel too bad after this. You know, you missed the salt water. The salt water was pretty bad. I will. That was. I still feel that, and I don't. That was bad. That was bad. Properties. Yeah, guys, right on the bill. Like, look at that. We have so many people commenting right now. Is this what it likes? Is this what it's like to be a big time streamer? I don't know. Okay, never mind. Okay, guys, there's not been. We need some more activity. We need some. Okay. We're doing fantastic for a little bit, but yeah, I think yeah, our view count has gone down a little bit. Is anyone still here? Hello? Can someone type in the chat they're still here? Or I just want to know that I'm not like fully alone. Earth to Caleb? Yes. Sorry, I don't know why on the YouTube Studio it doesn't show me. It only shows me like I don't know. It's not been super accurate right now. So. Oh no? What does that mean? Oh no. Why are we oh knowing? We should be oh yesing. Okay. So the properties above are proved using the familiar properties of real numbers and the definitions of complex addition and multiplication. The next example shows how commutativity of complex multiplication is proved. Proofs of the other properties above are left as exercises. Okay, now I'm actually trying to like use my brain and wrap my head around this stuff. Oh my gosh, guys, we have 3 viewers right now? Oh, whoa. For anyone who just joined, I don't know, we're trying to do a little bit of linear algebra. I don't understand anything about this book, but we are trying. Actually, 5? What? No, that's crazy. Wait, no, now we're back to 4. Wait, yeah, it's okay. It's okay. It's okay. Honestly, wait, this book might be a little bit like too. I might not have the willpower, but I have someone left. Yes, someone's fake. It might actually be better. I have this other book here that's just called oh shit. Oh shoot. It's called Algebra by I.M. Gelfond. I was looking online for uh some math books for my fundamentals, and a lot of people recommended these books. So I think this might be better just for everyone and maybe my sanity. So yeah. So I'm gonna read the introduction and stuff. This book is about algebra. This is a very old science, and its gems have lost their charm for us through everyday use. I like the cover very nice. Yes, the cover is very cool. The cover is very cool. The main part of this book is made up of problems. The best way to deal with them is solve the problem by yourself, compare your solution with the solution of the book, if it exists, go to the next problem. However, if you have difficulty solving a problem, and some of them are quite difficult, you may read the hint or start to read the solution. If there's no solution in the book for some problem, you may skip it. It is not heavily used in the sequel and return it to later. I don't know what that means. The book is divided into sections devoted to different topics. Some of them are very short and others rather long. Of course, you know arithmetic pretty well. However, we shall go through it once more, starting with the easy things. Let's add 3 plus 5. That's literally how this book starts. It goes pretty in depth in some other stuff, and you go like binary and polynomials and stuff, but it actually starts with just 3 plus 5. This is gonna be a very nice book. Okay, so let's add 3 plus 5. 3 plus 5 is equal to 8, and now change the order. 5 plus 3 is equal to 8. We get the same result. Adding 3 apples to 5 apples is the same as adding 5 apples to 3. Apples do not disappear, and we get 8 of them in both cases. Okay. Exchange of terms in multiplication. Multiplication has a similar property, but let us first agree on notation. Usually in arithmetic, multiplication is denoted as an x. In algebra, this sign is usually replaced by a dot. We follow this convention. Let us compare 3 times 5 and 5 times 3. Both products are 15, but it's not so easy to explain why they're equal. To give each of 3 boys 5 apples is not the same as give each of 5 boys 3 apples. The situations differ radically. One of the authors of this book asked a seven-year-old girl, how much is 2 times 4? 8, she answered immediately. And then 4 times 2? She started thinking, trying to add 2 plus 2 plus 2. 2 plus 2 plus 2 plus 2. A year later, she would know very well that the product remains the same when we exchange factors, and she would not forget that it is not so evident before. The simplest way to explain why 5 times 3 equals 3 times 5 is to show a picture. I'm not showing you guys the picture. Addition in the decimal number system. If we want to know how much 7 plus 9 is, we may draw 7 apples and then 9 apples near them, and then count all the apples together. 1, 2, 3, 4, blah blah blah, 15, 16. We get 7 plus 9 is equal to 16. This method can be applied for any numbers. However, you need a lot of patience to try it. Say 137 and 268. Some mathematicians invented other methods. One of them is the standard addition method used in the positional number system. In different countries and at different times, people use different notations for numbers, and entire books are written about them. We are so used to the familiar decimal system using the digits 1, 2, ... 8, 9,
and we don't realize how unbelievably convenient this convention has proven to be. Even the possibility of writing down very big numbers quickly was not self-evident for ancient people. A great mathematician of Greece, Archimedes, even wrote a book called The Sand Reckoner. The main point of the book was to show that it is possible to write down the number that is greater than the number of sand particles filling the sphere whose radius is the distance between the Earth and the stars. I have no idea what that means. Now, the decimal system has no rivals, except the binary number system, which is popular among computers, not people. This binary system only has 2 digits, 0 and 1, but the numbers have more digits. The computer does not worry about the length of the numbers, but still wishes to keep rules of operation as simple as possible. We shall speak about the binary system in another section, but now we return to our ordinary decimal system and to the addition system. We shall not explain it to you once more, you know it without us. Let us solve problems instead. Okay, problem 1. Several digits 8 are written down and some plus signs are inserted to get the sum of 1,000. Figure out how it's done. For example, if we oh wait, I already said the solution. I'll just read the solution this time. Okay, so it's saying several digits 8 are written and some plus signs are inserted to get the sum of 1,000. Figure out how it's done. Okay, so for example, if you were to try 88 plus 88 plus 8 plus 8 plus 88, we fail because we only get 280 instead of 1,000. Assume that... My brain's starting to hurt now. We keep going. We do not know how many rows are here, nor how many digits are used in each number, but we do know that each number ends with 8, and that the last digit of the sum is 0. How many numbers do we need to get the 0? If we use only one number, we get 8. If we set 2 numbers, we get 6. 8 plus 8 equals 6. To get 0, okay, let's see. If we wanted to get 0, in this situation, the problem is saying something like, it's something that's saying along the lines of this. Like, we have like we have dot dot dot, we have like 8, and then it's only be 3 dots, and then we have like dot 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 like 8 dot 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 8, and then this is somehow going to be equal to 1,000, and we're just trying to figure out maybe drinking the salt water will help. Stop! No more salt water. That was revolting, and my stomach still kind of hurts from that salt water. That was a dangerous amount of salt water, and I only drink half of that. No, you want to come over? You could try it. No more salt water. No more salt water. Okay. So now it's saying like basically what combination of stuff, because you could do like 88 plus 8 plus blah blah blah, and we're trying to figure out how to add these all together. So it says here, we do not know how many rows are here, nor how many digits are used in each number, but we do know that each number ends with an 8, and that the last digit of the sum is 0. Could I come over and do a cameo later? Making and drinking is just a suggestion. Merrick, you actually live pretty close. If you would want to do a very quick cameo, you could, if I'm still streaming. Yes, you are allowed to. So, anyway, as we were saying, but on another one, we should hang out. But we don't know how many 8s or anything else is going on. But we do know that yes, W profile pic. We do know that our digits end in 8, and if we have like 8 plus 8 is equal to 16, and our last digit here is a 6. And if we have 8 plus 8 plus 8, you guys even see this? I don't even know. This is going to be equal to 24. And then I think it's like what? It's 8 times 5, right? It's 8 times 5 that is equal to, let's see, to get 0, we need at least 5, yes. So we know, this is basically how they're setting it up. We know that 8 times 5, where's my trusty rag? There we go. We know that 8 times 5 is equal to 40. And the last digit in the 40 is a 0. And over here in the 1,000, we need a 0.
So that means that there has to be at least 5/8. At least 5/8. After we get this 0, we keep 4 in mind because 8 plus 8 plus 8 plus 8 equals 40. To get the next 0 in the tens place, because this is the ones place, we need to add at least 2 8s, since 4 plus 8 plus 8 equals 20. Okay, now I'm starting to get I see. Because this here is going to be 0 and there's a 4. So 8 times 5 is equal to, there's a 40 there. So that means that there's a 4 in the tens place. And that means we need to add at least 2 8s from this 40 to get this to equal to 20. Because don't think about this 40, think about this as 4. And then that will equal 20, and then we have another 0 because we need a 0 here. So that means we need to add at least 2 8s, yes. So that means like around here, we know there's going to be at least 2 8s here. We add another 8, and we add another 8. Okay, and then, let me see if I can try to do the rest. So this is 8 plus 8, which is 20, so that's 2. And then we just need to add another 8 to get a 10. So there's an 8 here. And then that should be it. Yeah, okay, cool. So the problem is solved. So we know that 8 plus 8 plus 8 plus 88 plus 888 is equal to 1,000. Wow. The power of math. Oh my gosh. Okay, so this is giving us another little weird example thing. Okay, yeah. In the addition example, it's like a row of A's plus B's. Wait, this is all that shows up. It has A over B is equal to AAAC. So C A. In all A's denote some digit, all B's denote another digit, and all C's denote a third digit. Very powerful stuff here. Dude, why do you keep changing your profile picture? This is very... We're about to reach 5.5 hours, guys. 5.5 hours. We're almost at a full U.S. school day of 8 hours. Oh my gosh. I don't know what to do here. Okay. So if all A's denote something, all B's denote something, and all C's denote... One of them was you. Oh my gosh, wait, I didn't even notice that. I thought I see it from a distance, and also it's been rough. I just never changed. Okay. So, I actually have no idea how to do this question. Because A plus B this actually makes 0 sense. In the addition example, all A's denote some digit, all B's denote another digit, and all C's denote a third digit. What are these digits? Yeah, I'm lost on this one. Dude, I'm trying not to read the solution. I just kind of want to figure it out, but this is actually stumping me like crazy. It's funny, I mean, if we think about it, like, this is the second problem in the whole book. The first one, it's like, what? Oh, who just sent the heart? Yes, if we know in the last example, like, if we had 8 and we had 8, we get, like, 1 and then we get a 16. Oh, I wrote that wrong. We would get a 6 and a 1. Or something like that. I don't like this no more. Why are there more letters in math and numbers? I don't know. This is a very popular book, that I found online, and this is literally the second problem they give. Can you please go back to like? To what? "19 plus 1 equals 21. What? What are you talking about? Please? Please what? I'm so confused. Also, my eyesight's getting worse, and I like. Please what? Just addition? This is addition. Hold on, okay, fine, let me read the solution. I don't want to read, I need to, no, hold on. I pray you don't get my vision from this. Yes. I pray too, Merrick. I think you need saltwater break. No, stop with the saltwater stuff. I'm no more saltwater. I told you. I'm gonna vomit if I have more saltwater. No. Why does this make no sense? Maybe if I add like a plus sign, that might help me a little bit. These are numbers. There are numbers here somewhere. I just have to find them. Maybe the vomit is like a physical reset. Good for the brain, you know. Merrick, I don't like how you're going on this side now. Exactly. Okay, you guys have to stop. Okay. Solution. First of all, A denotes 1 because no other digit can appear as a carry in the thousands position as a result. What? I like your thinking, Merrick. Okay. A denotes 1 because no other digit can appear as a carry in the thousands position as a result. To find what B is, let us ask ourselves, do we get a non-zero carry adding the rightmost A and B? If we had no carry, we would get the same digit in the other two places. What? I'm so confused. Ugh. A denotes 1 because no other digit can appear as a carry in the thousands position of the result. What does that mean? That did not help. I like your thinking. I know it did not help. I know. I don't. What can appear? Do we get a non-zero carry adding the rightmost A and B? If we had no carry, we would get the same digit in the other two places. But this is not so. So, can you collab with Mr. Allen, please? I would. He has to contact me. I would. Digit is not 0. What the? Therefore, we get the okay. So the answer is supposed to be. That's the answer, guys. Do I understand it? No. I don't know if it's the Red Bulls, the salt water, or just the fact that it's been 5.5 hours. But we. I just realized. What did you realize? What did you realize? I like this is the second problem in the book, and I can't do the second problem. Cliffhanger? What? You have Smitsky's? Yes, I do. I have 2 Smitsky's set up right here. I have more in my room. Smitsky's are these things. Yeah. They've been there the whole time. They've been with me. Yeah. Smitsky's are great. They're wonderful. Can you show the collection as a break? There are no breaks. There are no breaks. I didn't realize because you were covering them. Yeah. Yep. Caleb, my guy, your dedication is unmatched. 5.5 hours doing math is insane. Yep. Well, it's I would say it's more like, it's been more like 5 hours and 15 because, you know, took a few bathroom breaks. I spent like 6 minutes eating, but it's been a very solid 5 hours. Now we're just going through this book. Or at least trying to. I don't know, the second question already stumped me. So, okay. To compute the product of, say, 17 and 38, we may draw a picture of 17 rows, each containing 38 points, and then count all the points. But of course, nobody does this. We know an easier method of multiplying using the positional system. This method, called the multiplication algorithm, is based on the multiplication table for digits and requires that you memorize the table. There is, no way around it. And if, on being asked, what is 7 times 8, in the middle of the night, you cannot answer 56 immediately, and instead try to add up 7 digits, 7 eighths, half asleep, we are unable to help you. There is some good news, however. You don't need to memorize the product of 17 times 38. Instead, you can compute it in 2 different ways. 17, what is this way? What the heck? 55, 5, what? Both results are equal, though the immediate results are different. A lucky coincidence, isn't it? Here's some problems concerning multiplication. This book explains nothing. This book explains nothing. That book explains nothing. Oh my gosh, wait, there's 6 viewers right now. Oh, that's a new record. That's a new record. That's a new record. Oh my god. Guys, we are climbing the social ladder. We are climbing the social ladder. Honestly, okay, I think I need to go back to just the base calculus problems. I think that was my bread and butter. Shoot. Ugh. Yeah, guys, our viewership is... oh, never mind. It just dropped. Okay, never mind. It was nice for a time. My average is like 3 viewers. Yeah, my bad. That might have been my alts. It's okay, America. It's okay. I forgive you. Okay. All right. Okay. Let's do some more things. Let's move this back up here. Oh, whoops. There we go. Okay. Yes. It's okay, Merrick. I forgive you. Okay, so this problem is saying that a spherical snowball is melting in such a way that it maintains its shape. The snowball is decreasing in volume at a constant rate of 8 cubic meters per hour. So that means that dV dt is equal to -8 because it's decreasing. And then per hour, at what rate per hour is the radius of the snowball decreasing at the instant when the radius is 10? So r equals 10. dr dt is equal to question mark. Okay? Okay, the volume is so volume is equal to 4/3 pi r cubed. Okay, wait, what's our... Oh my gosh, guys, we're back up to 6. Unless it's someone's ult. I actually don't know anymore. Okay, anyway. Wait, Caleb, my phone is going to die and there's no charger. I wish you don't give up so easily and I hope more people come. Aren't you at your house? Okay, no, whatever. Thank you so much. You've been here for so long. You've been here for like 2 hours, so thank you. I appreciate you. Mimi's Ocean. Okay, thank you. No, I'm not. Oh, you're not home. Oh, whoopsie poopsie. I did not realize that. Okay, well, good luck wherever you are. I will keep mathing. Okay, so this is a related... Ow. Okay. This is a related rates problem. For related rates problem, they usually give you some sort of function. In this case, I think I just hurt my neck. In this case scenario, it says a spherical snowball is melting in such a way that it maintains its shape. The snowball is decreasing in volume at a constant rate of 8. I got you up on my monitor, so I'm gonna be here till you end, hopefully. Thank you, Merrick. You're so W's. You math, do your mathing. You math. Okay, bye. Alright, thank you, Merrick, and thank you, Mimi's Ocean. Okay. The snowball is decreasing in volume at a constant rate of 8 cubic centimeters per hour. At what rate in centimeters per hour is the radius of the snowball decreasing at the instant when the radius is 10? So basically what we do is we first off want to differentiate the function that they give us in terms of t. So dv dt is equal to 4/3 pi 3r squared dr dt. Yeah. So just like this, because even though Merrick, I know you haven't taken calculus yet, with these types of problems, there's a certain rule called it's called the power rule. So for example, I'll do it right here. If I have x, yep, that's this here. Okay, yeah, if I have x cubed, right? The power rule states, I'll show you what let me actually write what the actual power rule is. So the derivative, which looks like this, it's just like this. The derivative of x to the n is equal to, you bring n down, you leave x alone, you do n minus 1, and then you multiply it by dx dx. You multiply it by you just multiply it by the derivative, but usually when it's in terms of x, when it's the same variable, it just turns out as 1. But in this situation, it won't. So I'll show you what that's like. So now that you know this is the power rule, like if I want to take the derivative, for example, of x cubed, so d over dx of x cubed, this would be equal to, I bring the 3 down, okay? So I'd have 3. I'd leave the x alone, x, and I do 3 minus 1, which would be 2. And in this case, the like x prime would just be 1 because dx over dx is 1. What actually is a derivative? Or is it a placeholder type thing? So a derivative is the instantaneous rate of change. Oh no. Yeah, the derivative is just it's just the rate of change. So like for example, this is a good example. So if I have a graph here, right? I have the graph of x squared, correct? This is x squared. That looks pretty familiar. Okay? And over here, I'll have the graph of x, okay? So these graphs look pretty familiar. So based on our power rule right here, the derivative of x squared would be x, right? Because for 2, I bring 2 down. Oh no, well no, the derivative would be 2x, sorry. The derivative would be 2x, which would I guess look something more like this, okay? But the derivative is 2x, so I bring the 2 down, x minus 1 would be x. If you look at these graphs, the derivative tells us about the rate of change. So you could see that from 0 to positive infinity, right? The graph is increasing, right? And you could see on our graph here, shoot, it's really ugly. You could see on our graph here that from 0 to positive infinity, it's increasing, right? And then we could see on this side, from negative infinity to 0, our graph is just going downwards. It's decreasing. And on this graph, we could see that it's negative down here because it's below the x-axis from negative infinity to 0. And then at 0 it changes, just like right here it changes. So it just shows us like the rate of change of a function. So in this case, we're trying to find out like we're trying to figure out at what rate in centimeters per hour is the radius decreasing and stuff. So that's kind of like a very crude example, but yeah, they're not placeholders or anything. They're just like that. And then okay, so again, this 3r squared, it was 3 over here. We brought it down. We did 3 minus 1, which is 2. And then we multiplied it by d over dt, which was this right here. But since we were doing with r, it's dr dt. So that's how we get this. And they already told us that the volume is decreasing at a rate of negative 8 cubic whatever. The units don't matter. So I know that dv dt is equal to negative 8. This is equal to 4 over 3 pi. And they told us that the radius is going to be 10. Oh wait, these 3's cancel. I forgot. So this is 4 times 10 squared is 100. So 4 pi times 100 times dr dt. And then 400. So negative 8 divided by 400 pi. Wait. Yeah. So 8 goes into 400 like 50 times. So this is equal to negative 1 over 50 pi, which is equal to dr dt. Oh, fun, Caleb. I'll pop in more if you do more streams. Thank you. I appreciate that. All the support helps. Everything helps. Yes. Okay. Great. All right. So that would be the answer, but I think it wouldn't be. Oh wait, this is also decreasing, so it's negative negative. So then this would be positive. Yay. 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 Make sure my phone's actually still fine. It's not overheating or anything. Yeah, wait guys, hold on. Okay, we should be back. Okay, great, we're back. Okay, cool. Let's do some more problems. If is equal to the integral of 0 x cubed cosine t squared. Okay. I don't know if is anyone actually watching right now? Or I'm still gonna continue, but it's like our viewership spikes a little bit and then it just goes right back down, but it's okay. So this question, it gives us this function, f of x. Oh yeah, I forgot, Merrick, you have it up on your monitor. F of x is equal to the integral from 0 to x cubed of cosine t squared dt. And the question is asking us, what is f prime of the square root of pi? Okay? Yes. 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 Okay? That looks terrifying. I know it does. I told this to Mimi's Ocean earlier. For calculus, a lot of things look very, very scary, but in reality, they really are not bad. It's just like when you look at another language, right? Another, like a simple word in another language, like hello, can seem like insane. And then when you learn how the language works, you're like, okay, wait, that's pretty easy. It becomes intuitive. Math is genuinely a language. I cannot think of a better way to describe it. So anyway, in this case scenario, when you take, like, integrals and derivatives are inverses of each other. You know, just like how multiplication and division are inverses of each other. So when you take the derivative of an integral, they cancel. When you take the integral of a derivative, they cancel. Okay? So f prime, therefore, of x is equal to, now in this situation where we have something like this, what you do is you basically just take away the integral, you plug this in for whatever t is, but you got to keep that squared, and then you multiply that by the derivative of this. So then this would be cosine of x cubed squared, you multiply x to the 6th times 3x squared. Okay, I believe that's looking pretty right. Now they're asking us to plug in the square root of pi for every x that we see. So therefore, f prime of the square root of pi would be equal to cosine of the square root of pi to the 6th. Actually, that doesn't look right. This is So 1/2, right, would be a square root. Times 6 would be equal to 3. So this is just pi cubed. Times 3, the square root of pi squared is just pi, so that's 3 pi. So then this should be 3 pi cosine of pi cubed. Alright, so 3 pi cosine of pi cubed. Yep. Sorry, I know it's a little bit messy right here, but still going strong. We're almost at 6 hours, guys. We're almost at 6 hours. All the hours go by. Honestly, I think the longest time was hours 4 to 5. Maybe from 5 to now. I don't know. I'm forgetting a lot of things. Ooh, yes, I love that energy, Merrick. It's exactly the type of energy that we need. Exactly. Yes. Celebrate everything. The stream so far has gotten 90 views, which is pretty cool. I mean, we've only ever been able to keep like 2 or 3 viewers at a time, but for those people that stay, I notice you guys, okay? I notice all of you guys. All right. Next question. Ooh. Okay. Merrick said that looks scary. Let's look at something scarier. Polar coordinates. R is equal to a 90 is really good, man. Yeah, no, it's good for just views. I mean, I think that means just like at least 90 people clicked on it, which is pretty good. I am very happy with that. Okay, so from what I remember from polar coordinates from BC, so like a Cartesian plane, that's like your x and your y's and stuff. And when you have a graph, right, and you have like a point, you know, like this is the point, you know, we got the point 1, 1, right, you know, and you graph that like this, like maybe you draw a line and then you draw another point at down here, you got like 2, 0 and stuff. A Cartesian plane just says screw that, and instead in a Cartesian plane, that's a Cartesian plane. In a polar plane, what they do is instead, I believe that your x-coordinate is your radius, and then this other part is the angle theta. I believe that's right. And then they give you formulas in order to convert from a Cartesian plane to a polar coordinate plane. And I believe it should be x is equal to r cosine theta and y is equal to r sine theta. I am 80% sure that is the correct way of doing that. Let me just make sure. X equals r cosine theta. Yes. Y equals r sine theta. Great. Okay, I do remember a little bit, which makes me happy. Hold on one second, I'm just checking some stuff. Oh, Merrick, I will respond to your reels. I'm sorry, I just opened them real quickly, but I will look at them. I promise. That Flash one looks really cool. I have the reverse Flash figure. I don't know if you know that. I do have the reverse Flash because I pre-ordered him. Okay, so log in, bro. Log in. Yes, we're 5 minutes away from 6 hours. So let's do this. So if they're asking us what is the slope of the line tangent, so we basically want r prime at pi. Yeah, that's pretty much what we're looking for if we were to put it into terms like that. So we have to take the derivative of both of these. So x prime. So dx dr dx. Sorry. Wait. No, dx dr. Dx dr is equal to the first times the derivative of the second plus the second times the derivative. Wait, no, it's dx dr. Or no, dr dx. Yes. And then for this one, dy wait, hold on. It's not like, it's just like x prime, I guess. First times the derivative of the second plus the second times the derivative of the first. So basically what I'm doing right now is for polar coordinate questions in BC calculus, basically the way that they work is, in this situation it's very popular, is to ask you to find the tangent line, or the slope of the line tangent, which basically means you don't have to construct the whole line, because to do that they would usually give you a point. But they're asking for just the slope, which means the derivative at a point, because they're asking for the slope at a point, and they give you the polar curve. Now all we need to do is we use this polar curve, we use these two base formulas or base equations, and there are other equations that I forgot, but we don't need them right now, and we use these to construct, these help us convert from a Cartesian plane to a polar plane, and then we use these to construct our tangent line by taking the derivative of them, because a tangent line is the derivative, and then we have an ugly mix like this. We clean it up, we divide the two, then we plug in some stuff, and we have a good time. So let's do this. So what I'm noticing here is, like, there's a few things we need to figure out. So wait, I think I did that wrong. Hold on. Wait, I think I have to, like, it's just r prime. Just write r prime, yes. First and derivative of the second plus the second times the derivative of the first. Yeah, just write r prime. I confused myself. So r prime, we have r right here. We have to find what r prime is. So if r is equal to 2 theta squared, if r is equal to 2 theta squared, then that means that r prime should be equal to 4 theta. And then r prime at pi is equal to just 4 pi, because theta is basically our x here, and that just means it's a variable that we can just plug in whatever we want. Oh, by the way, we made it to 6 hours. So yay. 6 hours. 6 hours and a dream. 6 hours and a dream. Okay. Party. Yes, it's party time. Okay, so now we know what r prime is. We know what r prime is at theta. We need to also find r at theta, which would just be r at pi. Message retracted. What did you say? Yeah, you made 6 hours. Keep going. Keep going. I will try. I was really close to giving up at the 5 hour mark. After how much pulley burrito, but ow, I think it's clicking in now. Okay, So r pi, so that's just 2 pi squared, whatever that is. I don't know if this will all cancel. I don't know. This is freaking me out a little bit. So then, so tangent, isn't it y over x? Right? Isn't it? I believe it is. Oh, that's polar to Cartesian. That's why. I mix it up, guys. This is the way of going from polar to Cartesian, not Cartesian to polar. Okay, and then I believe it's y over x. So if we have d y dr over dx over dr, this will be equal to dy over dx because the dr's cancel, which is then equal to, let's keep all the cosines here, r, and r is equal to 2 pi theta, so then we have like 2 theta squared cosine theta plus sine of theta times 4 theta divided by, I'll keep the cosine over here, so r prime is 4 theta cosine theta minus sine theta times r, which is 2 theta squared. Something like that. And then we plug in pi. So we plug in pi. Let me sit down. We plug in pi. This will be equal to uh, 2 pi squared. Cosine at pi is 0 plus sine of pi, which is 1, times 4 pi, so that's just 4 pi, over cosine at pi is 0 minus 2 pi squared. You go away, 4 pi minus divided by 2 pi squared, which is equal to negative 2 over pi. Wait, shoot, I did something wrong. Wait, what did I mess up on? 4 theta it's r prime sine of theta, sine of pi is 1, 2 pi squared. First after the second. gosh. Wait, yeah, shoot, where did that minus come from? Oh, from there. Cosine minus sine. Sine of r. R is that. 2 pi squared. I'm so lost, I'm so lost. I'm coming? What does that mean? Shayan? I just don't, I went wrong somewhere. I'm trying to understand where. 2 theta squared, which would be 2 pi squared. What do you mean? Sean, what do you mean you're coming? Wait, hold on. I gotta do damage control. Let's check on. Sean, no, please do not. Don't come here. Okay, I don't know. Oh my gosh, I'm shutting down. I don't know where. I went wrong somewhere. I'm so confused on where. Because if it's a cosine of pi, that would be gone. And that would be gone. Time to erase all this goodness. Oh my gosh, one of my friends is saying that he wants me to go 12 hours. I don't even know if I can do 12 hours. I don't know how much more I have in this. I'm just trying to chug along. Okay. Just trying to find some more problems. I hope my friend actually doesn't. He might actually show up at my house. I don't know. Okay, so the integral of 6e to the 3x dx pull the 6 out. Do u sub, so we could do u is equal to 3x, du is equal to 3 dx. Pull it out, over 3 is equal to 2. So then we have 2 integral of e to the u du, integral of e to the u is just e to the u, so that's 2e to the 3x plus c. And we know that, did I just get, we know that this is right. Actually no we don't, but, well, the c could be whatever, but that would just be like a constant, I think. But if we take the derivative of this, that'd be 2e to the 3x times a 3. 3 times 2 is 6e to the 3x, which is what was up here. So okay. F of x is equal to 4 over x plus 5 plus 5x minus 1. Hold on. Okay, so this question's asking me what's f prime at 2. F prime at 2. F prime f prime of x is equal to so 4 over x is the same as 4 times 1 over x, and then the derivative of 1 over x, that's x to the negative 1, so then that's negative 1x, then negative 2, which is negative 1 over x squared, so then this is equal to negative 4 over x squared plus 5, because the derivative of any constant is 0. And then we plug in 2. 2 squared is 4. F prime at 2 is equal to negative 4 over 4 plus 5 is equal to negative 1 plus 5, which is equal to 4. That is our... Did I just pause? What did I just do? Oh, wait, why are there's actually a lot of viewers right now. I don't know why there's so many viewers. Yeah. That's it. Sorry. You know, guys, it's starting to, it's starting to get me. It's starting to get me. Okay. This one is saying f prime of x is equal to 3x squared plus 2x. So, for this question, I'm thinking like, well, we're gonna have to integrate this, because we know that, do I have to integrate this? Wait. Fundamental I know it's I know it's fundamental theorem of Koch. I was thinking something else. But yeah. Because we know that the integral of f prime of x from a to b is equal to f of b minus f of a, right? Right? Yeah. So in this case, we know that when you plug in 2 of, so we know that, so in this case, yes, King, okay, thank you. So in A is going to be 1, B is going to be 2, of f prime of x. We know this is going to be equal to f of b, which is f of 2 is equal to 3, minus basically f of 1. So then therefore, f of 1 is going to be equal to 3 minus the integral from 1 to 2 of f prime of x dx. So what is that? I don't know. Let's figure it out. 3 minus 1, 2, 3x squared plus 2x dx. So 3 minus 2, 8, 4, 12, 2, 14, 3 minus 14. Is that it? Wait, no. I went too quickly. Wait. No, that's 8. 2 cubed is 8. Plus 4 is 12, not 14. Wait, 12. 12. 12 minus. 12 minus 1. 12 minus 2 is 10. 3 minus 10 is negative 7. Yes. 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 It's equal to negative 7. Ice bucket. Sean, I said it early in the stream. If we can get 10 people on the stream, I'll do the ice bucket challenge. But the highest we ever got was at one short point we actually had 6 people. I don't know how that happened, but we had 6 people. So you know, if you can get 10 people here, then I will probably do it. I'll probably do it. But I'm not gonna do it just for you, Sean. Y prime. So we have y is equal to x squared times e to the x minus 1. Now we can either distribute this first or take the derivative, I think. Actually, wait, is we all going to Caleb's house? What? Wait, whoa, is someone at my house? What do you guys, wait, what do you guys mean? Guys, don't break into my house. Okay? No, please don't break in. Anyway, we do the product rule. If you all go, I'll go. What? Guys, I have to do math. We've almost gone for 6.5 hours. I can be there in like 5. Merrick, what the fuck? Sorry. What the heck? We can do math with you to let off the load. My setup, I don't have that much space, but I will whatever, sure. Okay. Are we there yet? Yes. What does that mean? Okay, whatever. So the first times the derivative of the second, which is just e to the x, plus the second, e to the x minus 1, times the derivative of the first, which is just 2x. I'll do calculus with Caleb. It's summations with Cheyenne. E to the x, x squared, plus e to the x minus, plus 2x e to the x squared e to the x minus 2x. Sean, when is this happening? Guys, why is everyone coming to my house? And how can the guys? I've been. Let's chill out. Okay, let's chill out a little bit. Let's chill out a little bit. Okay. I got that question right. I think. My body hurts. I think it's from the salt water, the Red Bulls, the fact that I haven't been moving my body much. I've just been standing for 6 hours and sitting down for like 40 minutes, but I could feel my body like parts are shutting down. Okay, no. Trying to find some more problems. So I can grab some Tums or something on the way to your house. Can you get me like the Hubba Bubble, like the gum? I want the big gum. Minus tan y equals 4. Okay. Also, when did we all decide we're coming to my house? I have to do a stream. 4. 3x minus tan y equals 4. They're asking what's the derivative in terms of y. So the derivative in terms. I'm back. Hubba Bubba Gum. Yes, Hubba Bubba Gum. That's right. Okay, so if we take the derivative of this, we get 3 minus. The derivative of tangent is secant squared y times y prime is equal to 0. 3 is equal to secant squared y times y prime. 3 over secant squared y is equal to y prime. I'm just not gonna. But wait, what's the derivative of tangent? It's secant squared, right? What is it? What is it? Secant squared x. Yeah. Then I added it and then divided it. Are you working on calculus? We're back to calculus. Whatever. So no more. Yeah, no, because I I got lost. I got lost too quickly. Look at the towel. Another towel check. I mean that side doesn't matter. I've mainly been using this side, but you could see it's been through some stuff. So next step, y equals. Wow, wow indeed, Louisa. Wow indeed. Y equals sine of f of x squared. Caleb, would you be open to tutoring my little sister next year? Of course. I tutor everyone. Just yeah. Yeah, of course. I would happily tutor your sister in any math subject. I love helping people with math. When x equals 3. Thank you, such a big dog. Don't thank you, you. Thank you so much, big dog. Don't give up. What? How long do you guys think the stream's gonna go on for? I mean, it's been 6.5 hours. You know, this is the most viewers we've ever had. I could just. That's. I think it's starting to get to me. I think it's just starting to get to me. Eternity. I don't like that. I don't like the way it sounds. This question's saying that we have y equals sine. How long are you trying to go for? I mean, you saw the title. It's till I can't. I said mentally break down. I should have also mentioned physically because my legs can't do this for that long. But who knows? Who knows? Okay, so y equals sine of f of x. This is like an f of x squared. The derivative, so y prime would be equal to cosine of f of x squared times f prime of x squared times x squared. Cause you did say until you hit 8 hours, but when did I say till I hit 8? Oh, I said maybe because that'd be a full school day. I never wrote anything down in stone. So this is saying now we plug in 3. So y prime at 3 is going to be equal to, this is going to be 9 cosine of f of 9 times f prime of 9. I never said you wrote it and said it. I'm sorry, I'm starting to like... Yeah, okay, you have to understand, I can't. Wait, this is 2x, this is a 6, shoot. Six cosine f9. I feel like I just want to like lay down and crumble into a little ball. What? What do you mean you're coming? Why? Okay. I want to do calculus. I second that. Okay. Okay. Plus, it looks like you need some support. I need a lot of things, Merrick. I need a lot of things. Ugh. I think it's getting to him. No, it's not. Ow! Oh my gosh! Like I need to move my body. Okay, it's the limit time. Limit as x approaches 0 of. Is that a pogo stick in the background? You should do that to wake yourself up. Listen, Luisa, I tried to use... Fans of the stream who were here earlier in the day know that I tried to do the pogo stick and it did not go well. The pogo stick did not go. I tried to do it in my room. It did not work very well. It was very bad. Ugh. Okay. Okay. What was this? Oh, yeah. Have an apple day? A, I'll deliver the Hubba Bubba. So we have the option to give him a better punishment. What? Because of the... I'll do the ice bucket. Okay, now there seems to be a decent amount of people. Okay, I'll probably do the ice bucket. Okay, just get. Let me do this problem. Let me do this problem. My back hurts. Oh my gosh. E to the 4x minus 4x minus 1. Because of the pogo incident. Oh my gosh. Shit. Okay. So if we plug in 0, so we plug in 0, we get e to the 0, which is 1, minus 1, minus 0, over 0. So we get 0 over 0. May the mental eel bless you with bountiful. The giggly amongster. Do you want something from Starbucks? We have basically 10 viewers, Caleb. Oh my gosh, this is awesome. Okay. From Starbucks, I will give me like the refresher. Okay, fine. Guys, hold on 1 second. I'm gonna go fill my bucket with ice. Okay. I have a bucket of water. I'm gonna go fill it with ice, okay? Just give me a second. Okay. Look what I have. Wait, what's happened? Ice bucket now? Which refresher? Wait to do the ice bucket until there. Okay, I'll do the ice bucket once Shion gets here. I want the dragon fruit refresher. Okay, guys, look. I filled. Oh wait. I do not want to spill it, but you can see it's filled with ice. It's up to about here with water. So we need to get P4K. Who? Or perhaps Guac Monster 15? Oh, that's a good idea. What? Dude, you guys are oh my god, you guys are in cahoots. Okay, that me, the Guac Monster. Okay, wait, I do want to say, oh my gosh, we have 9 viewers! Okay, wait, I do want to say something. For the people that are for some reason coming to my house, this stream needs to be, PG, so, like, please just keep no profanity or anything. Alright, we need to, trying to reach a wide audience, so just note that. Okay, where was I on this problem? Oh, shoot. Okay, I did not say anything. Okay, who's allowed in the house? Okay, Mimi's, I will do it once Shion gets here. Merrick, who's allowed? Have a guac. Who is the giggly? Oh my gosh. I feel like I'm hallucinating these names. Merrick, you're allowed to come. Okay. Oh my gosh, we hit 10 viewers. Okay. I promise to do it. Guys, if everyone can just hold on for whenever my friend Shion gets here with my mango dragon refresher, okay? This is what we need, guys. This is momentum. I feel like I'm coming back, okay? So, this is equal to 0 over Caleb. We stop tweaking out. Can the giggly monkster go? Okay. Anyway. Vote to ban him. Guys, what is going on? I'm not just gonna ignore you guys. Okay, so when we have 0 over 0, this is known as indeterminate, okay? So when you're doing a limit and you do direct substitution, do you want anything besides the Hubba Bubba? Can you get me an orange Red Bull? We're banning Caleb? You should drink apple juice on stream to celebrate the apple juice SMP. That is never happening. Okay, fine, Merrick, buy apple juice. Buy apple juice. Okay, so when you have 0 over 0, when you plug in direct substitution, well, you do direct substitution, which in this case, as x approaches 0, plug in 0 into this function, we get 0 over 0, and it's a limit. We're allowed to do something called L'Hopital's rule, which basically means we take the derivative of the top, take the derivative of the bottom, and we evaluate it again. So, thank you for the apple juice. Have an apple day. I am so lost. But hey, guys. Oh my gosh, we're at 11 concurrent viewers, guys. It only took... I'm keeping under the $10. Any other ideas? Okay, apple juice, gum, and... actually, no, Merrick. That's enough. That's enough. Guys, I have been streaming for 6 hours and 40 minutes. The entire time, I've had like 2 viewers. Those 2 viewers, I know who you are. Those 2 to 3 viewers, okay? But we're gonna keep going. I'm getting distracted. We're not even doing. We gotta do more math. This is what the whole thing's about. Okay, so L'Hopital's rule. One way of abbreviating it that people do on tests is they just write H and they write dash dash. Where did my magenta go? What? What the heck? How do you feel about oysters? I wish people... Evan, I like oysters, but now is not the time. They make you feel... I love oysters. Yes. No, oysters are so... Okay. No, first off, okay, guys, check the language, okay? And oysters are not bad. It's just you have to go to a good place to get some good oysters. Oysters make you feel so good. Okay, I don't know what the giggly monkster is about. He might have a different relationship with oysters than I have. Anyway, if we take the derivative at the top, we still have to write the limit. So the limit... as x approaches 0, of bring the 2 down, subtract 1, 2 times 4 is 8, x, divide that by the derivative of e to the u is equal to e to the u times u prime. And let your fans ask questions, don't be negative. What is going on? What is our amazing essay? Guys, why is everyone coming to my house? Okay. Who is the guac monster? Who's the guac monster? Anyway, this is gonna be 4e to the 4x minus 4, right? Yeah, and then the 1's just gonna go away. So now, okay, if you can tell me who you are, there's 15 people in live. I want to visit you. Guys, who are these people? If you say Guac's name, we can partake in apple juice. If someone could tell me all 15 people, let's go to Caleb's. Guys, okay, guys, listen. Let's chill out. Let's chill out a little bit. Okay, let's chill out. All right. Who is calling me? Oh my gosh, my dad's calling me. Guys, let's hold on. Let's we're gonna be right back. Okay, yeah, sorry, we're back. Okay, genuinely, we have to be careful because I feel like someone's gonna get doxxed. Okay, hold on, guys, let's just chill out. Yeah, I'm gonna need to. What is going? Okay, guys, we need to all slow down. What is that address? Oh my gosh! Wait, why? So many things are happening at once. 558 Candy Lane. Caleb, where do you live? Pick up. Let's give the lovers some privacy. I love this is professional. A screen and everything. Yes, Riley. Can you type louder? I can't hear it. What? Guys, let's all just be careful with whatever information we're sharing, okay? On the stream. I don't believe that any of these are real addresses though, but let's all just be careful. Let's all just be respectful. Okay? All right. Okay. Okay, let's so if we plug in 0, we get 0, and then we still get 4 minus 4 because e to the power of 0 is 1, because any number to the power of 0 is 1. So therefore, we have to do L'Hopital's again. So if we direct substitute, we get 0 over 0. So now I'm just going to do it like over here. We do L'Hopital's uno más, and then we get the limit as x approaches 0 of 8 over 16 e to the 4x. Now, if I plug in 0, e to the 0 is 1. 8 over 16 is equal to 1/2. We should throw a math party at Caleb's house. Okay. Mimis, let's actually chill out. I don't. Everyone dressed up as a mathematician. Oh my gosh. Okay. We dropped to 5 viewers all because of Cheyenne. We dropped to 5 viewers. Yeah, that. Wait, was Cheyenne like what? Was Cheyenne? Were these all like Cheyenne's alt accounts? Mater Pipfay? It's all his fault. I don't know what's happening. But anyway, guys, the answer is 1/2. So. What happened to the others? I don't know. I don't know. We peaked. We peaked at we had like 12. I would be honored to be a Cheyenne. Oh, I don't know what's happening. I'm going to be there in 15 minutes max. Cheyenne, just be respectful, okay? Be careful where you park. I'll actually help you guys later. More math right now though. More math right now. We had 15 people. 15 minutes. Oh my gosh. Who's Mr. Mo? E to the 3. Riley, I told you I'd do the ice bucket when Cheyenne gets here because he asked me to wait. I have the ice bucket ready. It's it's marinating. The water's really cold. Yeah, oh gosh, the water's actually very, very cold. Um, so don't worry, it's coming, okay? It's coming. One person is not worth the people here. Evan, are you guys not gonna? You guys tell me you can't stay? I've been streaming for almost 7 hours at this point. You can't wait 10 minutes. Ln of t squared plus 1. Caleb, if you don't do it, I'm gonna throw a mutiny. Oh my gosh, Mini Bach. Guys, just wait for Cheyenne. In the meantime, do some math, okay? That's the whole point of this. That's what I've been doing for around 6.5. Even though the stream's almost at 7 hours, there's been a little bit of in between stuff. So for basically 6.5 hours is what I've been doing. Okay. I actually feel schizophrenic. Anyway, as we all know, if you take the derivative of an integral, they cancel each other out, and all you do is you take this top part, you put it in here where the t is, and you continue. So basically, this answer would become ln of x to the 6th plus 1 times 3x squared. You should brute force the integral of root tan x. I still dislike horsers. I've been waiting so long. I know you've been waiting so long for the ice bucket, okay? I have not been waiting so long for the ice bucket. You made me drink the salt water, okay? Just wait. Just wait patiently, okay? Just wait patiently. If anything, it would help to have someone to pour it on me. And maybe Merrick would be here and then he could record it. I don't know. I miss Guac Monster. Who are these people? Anyway, that's actually the answer, so. You should brute force the integral of tan x. You should brute force the integral of tan x. I can time you out, right? You should brute force, okay. Someone's at my house. But these are in timeout. Okay. I'm really happy, guys. We have about 9 concurrent viewers right now. This is very good. Very good. We used to have 15. I know, Riley. We used to, listen. I'm happy. You know, having more than 2 is a massive accomplishment. So, I am not complaining at all. Yeah, that's like all of PBS right here. That is true. That is true. Sean, don't text and drive. Okay, so this right here, it's asking. Oh, this is equal to y. My bad. So this right here is asking us. They give us this function, and they're asking what's the derivative at the point 2, comma 8. Top 3 disciples of the mental eel. What? Sean, can you just teleport? Number 1, the Giggly Monkster. Okay, I might just mute Giggly Monkster at this point. I'm joking. Okay, so we take the derivative of this. So the derivative of x with respect to x is going to be 1 plus 3 over 3 y 1 over 3 minus 3 over 3 equals negative 2 over 3 to negative 2 over 3 times y prime. And this is equal to y prime. So then, if we have 1 is equal to y prime minus y prime over y to the 2 over 3, factor out, oh, wait. Yes. I believe this is correct. Then we have 1 is equal to y prime of 1 minus 1 over y to the 2 over 3. And then we have like 1 divided by 1 minus 1 over y to the 2 over 3, which is basically just like 1 over x plus 3 y to 3 to the 2 over 3. That's 2. 2 times 6, 2 times 3 is 6, plus 2 is 8. 8, 2. This whole thing is 4, so 1 minus 1 over 4 over 1. So 4 over 4 minus 4 over 4 over 1. Wait, 4 over 4, wait. 4 over 4 minus 1. 3 over 4. 4 over 3. The answer is 4 over 3. Okay, give me 1 second. I'm gonna go to the restroom. Okay, we're back. I'm a little scared because I don't know who's coming to my house, but yeah, sometimes you just gotta live life. I don't know, guys. I forgot we hit 7 hours. Yes. We've hit 7. Oh my gosh, we've hit 7 hours of Zaniac Pipfay. What? I'm so tired. I'm so tired. 7 hours, yes. More like Matthew Pipfay. Make it to what? What do we? What? Oh my God! Someone's here. Okay, wait. Hold on. Hold on. We'll be. Everyone. Here, the camera's right there.
I know, you have to introduce me.
Okay, so this is Cheyenne. He's one of my pupils. It's just like yeah. So the chair's broken, by the way. Don't lean back. So he told me he's very. How excited are you to learn calculus on a scale of 1 to 10?
10.
Okay, that's great. All right.
The Giggly Monkster. Hi.
Who is the
Hi,
giggly
guys.
who is the giggly monkster?
It's not-
What? Okay. So. Okay, my dog might keep barking, so I gotta like hold it.
That's okay.
Here.
Here.
Wipe the board.
I'll wipe the board.
Wipe
I'll
the
be your
board.
pupil. I'll be your
Wipe the
pupil.
board, yeah. Yeah.
Alright. So are we gonna do the ice bucket challenge or are we gonna wait?
Well, I don't know.
That's what the people want.
I know it's what the people want. I just don't know when I don't know when like Merrick and Mimi's. I don't know when all these people are getting here though. That's the thing. I want to do it. I just want to make sure that the people who really want it are here to see it.
I see.
So do it now. Wait, Evan, just chill out. Just chill out. Okay, so okay, let's see. You said when Sean got here. I know, but I don't know where Mimi's is. Mimi's has been here since day 1. I'm hanging out right now. Okay. And also, Merrick is coming because Merrick's going to hold the camera. Sean's going to dump the bucket. You don't have to wait for me, though. Oh, okay. Wait, hold on. Wait, are we? No, bro's ducking harder.
Harder than John Jones.
I'm not going, guys. I'm sorry, it's so disappointing. Okay, then we'll do it right now,
Okay, well, look at that.
Okay,
How
wait,
the
hold on.
stars align.
Hold on, let's prep the area. Saki, don't bark.
Alright.
Okay, wait, go over there.
I
Go
go?
over there. Go over there.
I'll go over there.
That's right, good boy. Okay.
Hey.
So I'll be there in around 20. Okay, perfect. Okay, guys, hold on. We're prepping the area. It's happening, okay? See the prepping area. Okay, hold on. Move over there. Go on the treadmill.
I'll go on the treadmill.
Okay. I need to just
Should
set
I
up.
open the... Should I open the...
Yeah, open that.
Okay.
Okay. Yeah. Okay, don't be careful. Be careful with it. Yeah. Okay, hold on. Okay. Oh, yeah. Okay, that's good. That's good.
Okay.
That's good. Okay.
Okay.
Hold on.
I'll move this over to the side.
Okay, so then, move that. Okay, perfect. Let's take a little path.
Alright.
Okay, the rest of the water should be fine. I'm not too worried about that. Okay, so this is the camera. So I want to make sure that we hold it correctly. So this is the go outside. So here, just
Alright,
go.
I'll go outside.
Here, take the camera.
Okay. It's connected wirelessly?
Yes, yes. Okay. I hope this works. Okay, hold on. Yeah, give me the camera. Give me the camera. Okay, so Cheyenne, I want you to. This is the bucket, Cheyenne. I want you to stick your hand and just give your honest reaction.
That's cold as hell.
Okay, yeah, exactly.
Heck.
Okay, just do the ice bucket. Okay.
It is very
Here,
cold.
take-
I can vouch.
Okay, take that.
The ice.
All right, guys, we're going outside.
Alright. Can we see? Okay. We're good. Should I bring the computer?
Is this a good angle?
Yeah. I prefer you finish.
I'll bring the tripod. No, you don't need to bring the tripod. It's okay. Wait, actually, yeah, we get the tripod. Get the tripod. Here, get the tripod. I'll get the computer.
Alright, so this is the moment you've all been waiting for.
Yeah. This is what 7 hours culminates
7
to.
hours. 7 hours.
I don't-
Give him a new refresh.
It's the mildly
To put him on
uncomfortable.
for the 5.
It's a mildly uncomfortable water challenge, as you've said, Xander. Okay. Saki, stop. Okay. Okay, that's the camera angle. Here, just check the angle.
Okay. So, okay, do you want to get a chair? Get a chair, get a chair. I'll pour it on you. I'll pour it on you.
Oh, okay.
This is good. Alright guys, so we're setting the scene. Alright, everybody spam likes. Everybody. This is the moment you've all been waiting for. So share it to as many people as you can. We're gonna do it in 2 minutes. In 2 minutes.
That's
Get
ridiculous.
everybody there.
Send the
Get
galaxies.
everybody here. Send galaxies. Send donuts. The more Kai Cenat will come out if you guys get at least 13 people here.
Dude, let's not shoot for the stars here, okay?
All right, let's not wait. How many people are even here? How do you check?
You can see my concurrent viewers down here. Like this.
Analytics.
Yeah, it's about 60.
There's 6 people. Okay, let's get 10.
This is amazing.
Let's get 10. Here, let's get everybody that was here that wanted to see it. Cause this is the time. This is the time.
Hold on. Just don't like type.
No, you're good. You're good.
After after this, we're going right back to teaching. By the way.
We're going right back to teaching.
Yeah, right back to math.
Right back.
Right back.
Right back. We wasted a lot of time.
Exactly.
You got 131 views.
I know.
The chat rate's 7.
Dude, I started this thing at I started this at 11 a.m. It's
Average view duration is 11 minutes, bro. You gotta up that.
yeah.
I'm trying to get as many people as we can. That's why 2 minutes.
Okay, we'll just.
We're trying to get. Cause there was like around 15 when I was driving over here.
Yeah.
It is about 1 minute now. So if they miss it, they miss it. That's how it's gonna go. All right, let's go. I'll give a countdown. Yeah, 45 seconds to join. All right, ready, guys? Can they see it? Okay.
Wait, hold on.
All right, we're good. All right. 44, 43, 42, 41, 40, 39, 38, 37, 36, 35, 34, 33, 32, 31, 30, 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19,
Wait.
18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Oh my God!
Oh my gosh. Bro, Xander, all the ice melted.
Yes, no. If you look
It was
at the
cold, it was
screen,
cold.
When I first poured the bucket, I showed all the ice originally in it. So don't worry. Here,
Yeah.
I'll get the tripod.
Do you guys want to run it back? It was the cold water challenge. We can fill it back up. They're calling it the cold water challenge. I think we have to do it again.
No. If we can get to 20 viewers, I'll do it again.
Okay, if we get to 20 viewers, we can do it again. So you guys have to stay. And
Why
then
is
learn math.
Why is this broken? That's not good.
That's fine. It don't bite.
Wait, like, no, my house is actually broken.
Let's see.
Okay. Is the camera? Wait, set back up again.
That's good, yeah. Yeah, we're getting...
Don't wait. I'll bring more people in.
Gotta,
Okay, so.
gotta zoom it out a little bit. Bring it back. That works.
Yeah, don't worry.
As far back as possible.
Yeah, just like that.
That works. That's good.
All right. We just move this up just a little bit.
Alright, let's see. Alright, what's the next topic?
Okay, no, we're gonna do more calculus questions because you've taken calculus, so
I have taken
let's test you out. Dude, don't. Oh, my dog's outside.
Oh, shit.
Wait, no, don't open that door though. Don't open that door.
Okay.
Here, wait, hold on. Here. Don't show the iPad though, but here. Just do
Okay.
this problem.
Do that problem? Alright,
Yeah,
let's do it.
don't the screen.
Okay. So, we have... I'll be taking over. Alright, let's see. How many people are there? There's good 8 people. Okay, look. Alright, so today we're going to be continuing differentiation with Sean Habibpour. Merrick's calling you! Alright, I'm sorry, Merrick. Okay, we got d over dx, the common variable. I know a lot of people are new here, haven't been learning along with Caleb for the past 7 hours, so let's get a nice big recap. So this is a differential. We have d over dx of x to the 5th minus 5 to the power of x. All right, so when we're doing this, there's a very important thing that we have to think about. It's called the power rule. The power rule basically says we have a constant, x to the power of n is then n times a times x to the power of n minus 1. That is the power rule for differentiation. So, then, for this one, we can put that into action. We have 5x, right? We're bringing the 5, multiplying it by the original integer, or what's that called? Coefficient?
Yeah, coefficient.
Yeah. And then that's just 5x, and then n minus 1, 5 minus 1, that's 4, minus 5x. There's a special rule for this, which I'm pretty sure it goes
It's
x ln of
no
5.
no it's ln
ln base of the
No,
it's x ln of 5, right?
times 5 to the x.
Times 5 to the x.
Yeah, times 5 to the x.
Times 5 to the x.
Yes.
So it's this one times the natural log of the base, or the coefficient, which is 5, times the original function. So this is our answer. And then that is concurrent with this.
Yeah, perfect. Now do that one. Good, my
Good.
good student. I taught him everything he knows.
All right, next one. Calculus with Caleb has turned into calculus of his pupil.
Yeah, when you're in BC, we're gonna do summations with Cheyenne.
Summations with. All right, so now we have a limit.
Ooh, okay.
That's one too many squiggles. As x approaches infinity. And then we have 10 minus 6x squared over 5 plus 3e to the x. All right. So if you're in tune with the stream earlier, we saw a problem very similar to this. And what we do first to evaluate kind of what is kind of going on, we look first what happens when we plug it in. Of course, when we plug in infinity to the top, if we look at the function as the x-axis goes to infinity, the function will always increase to infinity. Therefore, we put infinity at the top. Similarly to the bottom, as e of x increases, we know that e of x looks like this. As it goes more to this one, it will always go more and more infinity. So therefore at the bottom, we always have infinity. Therefore, this is indeterminate. That means that there's no answer. It is the same thing as having 0 over 0. You can't do that.
And what do we do when there's 0 over 0?
What do we do when we have 0 over 0? This means we can do something called L'Hopital's rule.
You say L'Hopital's?
L'Hopital.
L'Hopital's.
L'Hopital.
It's L'Hopital.
Why do you say L'Hopital?
L'Hopital.
L'Hopital.
It's French.
L'Hopital.
It's French.
L'Hopital.
L'Hopital.
Alright, anyways, so L'Hopital rule says that you can take the derivative of the top and the derivative of the bottom, re-plug in, see if anything happens. If it's still indeterminate, then you do it again. You can only do L'Hopital when it's indeterminate. So now, what we can do is take the derivative of the top, as well as the derivative of the bottom, and see where that leads us. So 10, any derivative of a constant is nada, 0.
0.
So we just leave it. So we have negative, the derivative of negative 6x squared, we use the power rule. Again, so we do this one, multiply it by the coefficient. So we have negative 12x, and then n minus 1, 2 minus 1 is 1. So we just leave it as negative 12x. At the bottom, same thing, 5, nada, it's a constant. So 3, e to the x, e to the x always is e to the x. So we leave it 3 e to the x. We replug in our infinity into this equation, and as we can see, 12x, 12 infinity is always going to be infinity. Over 3e to the x, as we saw previously, e to the power of infinity is always going to be infinity. So once again, we have indeterminate form. So what do we do? Shanhabipur, Caleb with calculus with Caleb. What do we do? We just did L'Hopital. Nothing happened.
We could do it again.
We do it again.
Do it again.
It's called brute force.
You can do L'Hopital's rule as long as you get an indeterminate form. So you can do it as many times as you want, as long as you get 0 over 0 or infinity over infinity. It does not matter.
Gorgeous. So we run it back. Negative 12x, boom, it's going to be negative 12. X to the power of n minus 1, 1 minus 1 is 0. Anything to the 0 power is 1. So we have negative 12. Over 3 e to the x again. And now we have something very interesting here. We have a constant at the top. However, we still have e to the x at the bottom. So when we plug in infinity, we get a constant at the top over 3e to the x. 3e to infinity is just infinity. So we get negative 12 over infinity. Similarly, well, not to really anything. Anything over infinity will end up equaling 0.
No, if infinity is in the denominator...
Isn't the, well, yeah, that to equal?
Yeah.
Anything divided over infinity is going to be 0. So, in the end, we write it out. Limit as x approaches infinity of this function, 10 minus 6x squared over 5 plus 3e to the x, ultimately ends up going to 0.
And I just want to add something. So the reason why, when we have infinity in the denominator, the reason why it's going to go to 0 is because if you imagine a fraction, right? Let's say I have 1 over 2, right? That's 1/2. 1/2 is going to be larger than 1 over 3, right? And then 1 over 4. And basically, if we go to infinity, like we have 1 over like 1, 0, 0, 0, 0, 0, 0, 0, 0, and we keep on going for infinity, this is basically the same thing as 0. So that's why when we have a fraction over infinity, we usually just say it's 0. Okay, hold on. We might need to be going right back. Hold on, guys. We'll be right back. We'll be right back. Okay, Sean, get out of the frame. Okay, so yeah, just sit in the chair. Okay, so now, hold on, let me see. I need to open up this stuff. Okay, so let's continue. Don't do the pogo stick.
Why?
Don't. I tried. Just don't. Seriously.
I want to try it.
You go outside then. Wait, go through the door over there.
Okay.
Take the poke stick. Go outside. No. Just go. Go. No, see. Just go through there. Go through that door. All right. Okay, everyone. So let's continue on doing more and more problems because that's the whole point of this, the why we're here. So next up we have let's see. This is another one. So we have the limit don't mess up the concrete, okay? Alright, whatever. Alright. So, we have the limit as x approaches 0 of sine x over e to the x minus 1. Now, again, the first step whenever you're doing a limit is to try direct substitution. Okay? So, if we plug in 0, sine of 0 is what? 1, right? No. Wait, what sine of 0?
Sine of 0 is 1. No, sine of 0 is 0.
So sine of 0 is 0. We e to the 0, anything to the power of 0 is 1. So then we get 0 over 0 because 1 minus 1 is 0. So then we have to do L'Hopital's. So again, to do L'Hopital's, I like to use this notation just to signify that I'm doing that. Variable. And then now we just write the limit again. We have the limit as x approaches 0 of the derivative of sine x is cosine x. The derivative of e to the x is e to the x. And the derivative of any constant is going to be 0. It did energize me. Yes, it did. And now if we try direct substitution, we get cosine of 0 is...
Cosine of 0 is 1.
Cosine of 0 is 1. And this is 1 over 1, which means that our answer
Is 1.
is 1. All right.
Wait. Oh, never mind.
Okay.
Okay, there you go.
I love how you could see it. We could see the... So yeah, 11 from this side, yeah. All right. So now this next question, we have if dy over dx is equal to 2 minus y, and if y equals 1 when x equals 1, or in other words, we have this point 1 comma 1, then, then y equals what? Y equals question mark. Okay. Now, here's how we would do this problem. So we have this, we know that when we plug in 1, we get 1. Okay. I think we just need to solve the differential equation. Yeah, I believe so. So we should just have to move all this stuff to one side. So we do dy over 2 minus y is equal to dx. Integrate that. Get negative ln of 2 minus y is equal to just x plus c, and then multiply believe you would use separation of variables for this one, right?
If it's a differential equation.
It looks pretty differentially to me.
think it's linear approximation. Right.
No, it's not linear approximation.
Yeah. They're trying to make you find the particular solution.
Yeah, I know. But this is like ugly.
That's okay.
But the negative sign,
What about it?
it's just like ugly. Because then if I raise this both to the power of e. Oh, actually, it might be easier just to do this. To do this first. Because we know that it's, that y equals 1 when x equals 1. So then we know that negative ln of 1. ln of 1 is 0, right? ln of 1 is 0?
ln of 1 is 0.
Yeah, so then this would go away, and then that means c is equal to negative 1. So then we have negative ln of 2 minus y is equal to x minus 1. Now what we can do is, we can just move this around. We could just, actually no, we should raise, now we just need to isolate y. And I know it's going to be an e, because I can just see it from the solutions. Have you tried rejecting the null hypothesis? Okay. Well, see, that's wrong class. Okay, so, I know, it's just the format is what's throwing me off. Here, I might just do this just to make it make sense in my brain. Where's my refresher?
The line was too long.
Okay.
There's like 6 people.
Okay, raised to the power of e to the 1 minus x is equal to 2 minus y. So that means that y is equal to 2 minus e to the 1 minus x. Yep. That is the answer. So, for those of you who were confused, okay, we've dropped down to 1 viewer. Okay, oh shoot. It's fine. So for those of you who were confused on that, basically we have this differential equation, which is dy over dx is equal to 2 minus y. And then they gave us this point 1 comma 1, or in other words, they said that when y equals 1, x equals 1, and then they said they just wanted us to find y, so they wanted us to find the original equation. So usually when you have a differential equation like this, you want to use separation of variables. And that's what we did right here. We moved the 2 minus y down, and then we moved the x over. You usually don't want to add the y to both sides. You want to try to bring the whole thing, because then you could just do ln. You can just have du over u, which we have dy over 2 minus y. Better than my calc teacher. Thank you. Just 2 minus y. This is just, again, that just comes with practice, because usually when you do separation of variables, like I think almost 10 times out of 10, you're going to want to have it in some sort of format where it's dy over y, so that it's the integral, and this rule is just equal to ln y. So you just want to be able to do that, because when you think of separation of variables, you should already be thinking of natural logs and Euler's number, and you'll usually see it in your solutions. If you look at the solutions, and if you see some e's, then it's a pretty big hint that you're going to have to do some sort of ln y, and then your first goal is figuring out how to get that originally. So we move the 2 minus y over here, we move the dx to this side. The integral of just dx is going to be x, because if you understand what the power rule is for integrals, you add 1 and then you divide by it. So technically, when you're doing the integral of dx, there's an invisible x to the power of 0, which would just be 1, and then we add 1 and then we divide by it, which would make the x appear. So then once I did that, I had negative ln of 2 minus y. The reason why there's a negative here is because you have to be careful, and I did a u sub here, because I can't just do du over u. It has to be I can't just do dy over y because this is a 2 minus y. So I have to do u sub. So I just did it in my head, but if I wanted to actually write it out, I would say that u is equal to 2 minus y, du is equal to negative dy, and then I move the negative, so then I'd have negative du is equal to dy, and then I would plug that into here, and I would just pull out the negative sign, and that's why there's a negative ln of 2 minus y, and this is equal to x plus c. We always put the c on the x side of the equation, we never put it on the y side. Then, for me, I was having a little bit of a conundrum because I didn't feel comfortable like raising it to the power of e when there's a negative in front of there, mainly just because it just didn't look familiar. So one quick tip in math is usually sometimes it's better to manipulate the equation in a way that looks comfortable to you, so that you actually can see it. Because sometimes if just a few things are moved around, you might not be able to do it. Like, you can tell someone, like, oh, what's 4 times 2? And they can get like, oh, that's 8. But you ask them what's 2 times 4, and they might be a little bit slower in saying that it's 8, even though it's the exact same question. It's just formatted differently. So once I did that, I decided to I decided to find c, because they told us this point 1 comma 1, so I plugged in 1 for y and 1 for x. ln of 1 is 0. So then I got c is equal to negative 1. I managed to plug that in up here. And then afterwards, I just decided to move the equation around a little bit to make it more comfortable for me, because I wanted my natural log where my y is to be positive. So once I did that, I raised everything to the power of e, and I got e to the 1 minus x is equal to 2 minus y. I moved the y over, and then I looked at my solutions, and it was just like this. Some solutions might have you separate these. Some might have you keep them the same. It really just depends. Hold on 1 second. Another person has arrived in my house. So let's just wait 1 second. Why can I not do this?
We have another special guest. We have another special guest.
Greetings. I brought. Here, Caleb, do you have the stuff?
He brought the sour.
Oh yeah,
He brought
right here.
He brought the Sour Patch Kids.
We have some orange Red Bull, and we have a fantastic Hubba Bubba roll. Look at that, fresh.
Alright, so the next challenge, if he gets another one wrong,
You have to eat the whole
he has
thing.
to eat the whole thing.
Yes.
And he has to swallow it all.
What?
I went to the first gas station didn't have Red Bull or Hubba Bubba, like that. I was just out of everything. Thanks.
It's in high demand.
And we're good though. Now we got
It's
it.
in high demand.
Yeah.
All right.
Now I'm ready to learn.
You want to learn?
I'm ready to learn.
We have a student corner.
Here. Okay. Try. Just.
Always like that touch.
Okay. Wait. You've already. Okay. So. Saki, I just need you to chill out a little bit. All right. So. Saki. Yeah. Thank you. Yeah. Here. Always. Here. Merrick's the one who doesn't actually understand calculus.
Yeah,
so
I'm in pre-calc right
don't
now.
worry about the back.
Pre-calc?
We're one step
good.
behind.
That's a good introduction.
Okay. So we'll actually be quizzing you.
Oh.
So let me just give you a quick intro on how the rules work. Take a seat. Don't lean back too far. The chair's broken.
All right, I remember.
Yeah, the chair's very broken. Okay, so. Okay. Just don't worry about the back. Don't worry about the back. Okay, so Merrick.
Yo.
I'm just gonna teach you this thing called the power rule. Okay.
Right.
Don't
I'm not gonna.
don't touch
If
me.
he bites my toes, that's
Okay.
gonna be rough.
Okay. So the power rule states if I have this is just one way of like saying a derivative. It's d over dx.
my pants.
Just let him be. Let him be. and we use this of x to the n, then the way that we solve this is we bring the n down, we leave x alone, and we do n minus 1. Okay?
Right.
So, if I wanted to take, get off the poker stick, bro, dx of x squared, how would I do that?
I got you. So basically, it would be 2x to the power of. Oh wait, I got one more. 2 minus 1.
Yes, to be 2
Okay.
minus 1, just 1, so you can just leave it alone as x.
Okay.
Okay, so actually chill out.
Wait, well, why do we just leave it if it's 2 minus 1?
Because
so it would just be 1.
Because
and
2
then
minus
the
1 is
power
just
of
1.
okay,
Power of
I
1
got
is
you.
just 1, yeah. So let me give you another example. If I wanted to do the derivative of 6x cubed, what would that be?
6x.
Try and get out of the frame.
Wait, no, he's moral support.
I'm modding.
Yeah. So that would be.
Just go over there, turn the computer around, just go over there on the
Is
side.
your webcam on?
That's my webcam.
Why is it? It's not saying.
No, because it's late. It's latency.
That's too late.
It's fine. It's not accurate for me. See.
Yeah.
Okay.
So
Anyway,
is it?
so
Oh, that's right.
6x cubed.
6x cubed, right? So all you gotta do is you gotta put hold on, wait. You keep standing in front of the whiteboard. It's kind of like, resetting my flow state. I feel like you adding the 6 just like my brain just shut off. Bro, I've been doing art for the past month.
No, it's
in
okay.
summer
Just
school, bro.
just remember, just this 6.
So the exponent goes first, right? So it'll just be 3.
Yeah,
and
so you
then
bring the 3 down.
actual-
Here,
yeah.
let me help you. So for this one,
Would you keep 6x or would you
No.
kind of separate? That?
so think about it like this. The way I like to think about it is it's kind of like 6 times x cubed. So in this case scenario, you bring the 3 down, so it would be 6 times 3, and then we do x to the 3 minus 1. So then the final thing would be 18x squared.
Right.
So basically
right.
bring the 3 down and you multiply by the 6.
Okay.
So like let me give you another one. I'll give you an easier one. So if we have 2x squared, the derivative of that would bring the 2 down, and if you bring the 2 down, it'd be multiplied by this 2. Because again, you bring it. If I had 2x squared,
Yeah.
it'd be like 2 times 2x to the whatever. So then 2 times 2 would be 4. X to the 2 minus 1, which would be 1 or just x.
Okay.
Okay, so here, this one you're gonna have to do on your own.
I got you.
That's ugly. Dx is equal. Oh, dx. Oh shoot.
There you go.
Of let's do 3x to the 4th.
So it'll just be 4 times 3, right? So 12x to the power of. Wait, where do we get the? Hold on, wait, give me something. Is it to the power of 4 or 3?
3.
3.
Because it's just whatever the number is. The n just means whatever number. So it's always just minus 1.
Okay, so it's 3 minus.
So
1.
if this was 16, if this was x to the power of 16, it'd be 15 because you just
Okay.
minus 1. And bam, that's literally, that's actually
That's
like
it.
that's unit 2. That's literally unit 2.
That's all of unit 2?
No, that's not unit 2. But that's like the premise. It's all questions like that.
I'm so excited for calculus experience next year.
Okay, so you see the towel.
I peeped the towel. I saw it when you were showing it.
Towel, yeah. So now let's give you something a little harder. Of
See, now that you erased everything else, like it doesn't work anymore.
you want me to write them the rule?
Wait, no, I got it. So it's 1x, or it'd be 1 times a half x, right? 1 times 1/2. There you comment.
Sorry, what were you saying?
Beautiful. Yeah, I love your assistant teacher, bro. So is that right? Would it not just be 1 times 1/2 x to the power of
Wait, here. Wait, what do you mean?
Oh, am I writing it?
Just write the one part. I have to do something.
Okay. Hold up.
Because really, you're writing it like this, right? It would just be 1 times, and then you would bring down this. So not just that?
No,
Or like, what am I missing?
so if you think about it in terms of the exponent. So the exponent, in other times it was like 2, 3, or whatever.
Yeah.
This time it's 1/2. So if you bring it down to 1/2.
What about it? Yeah.
Hold on.
All right,
Yeah, I need
okay.
assistant
Let
teacher.
let Xavier Shawn take over. All right. So
Give him the magenta marker.
when we
Oh,
have
no, he uses the purple one.
I use the purple.
magenta.
It distinguishes that.
Yeah. Sit down.
All right.
Okay.
So we have x to the
Uh-huh.
power of 1/2, also known as x, like this, right?
Mhm.
Square root of x.
Yeah, I got you.
Regardless, this is easier for this case. So when we're taking a power rule, remember we bring n down.
Is there someone else?
Another person?
We bring n down.
Mhm.
So we have 1/2. We bring it down. 1/2. So you're right.
Mhm.
And then we have x, and then we multiply that by the regular coefficient, but in this case it's just 1. So we can just write x times, or to the power of n minus 1. So the only difference here, when we're dealing with a fraction, is when you do this, it's difficult to do this. But what happens is you rewrite it as 2 over 2.
Yeah.
And so you solve that now, so you get negative 1 over 2. So then you get 1 over 2 x to the power of negative 1/2. So then you can rewrite this as x over 2 times negative 1 over half, or as you know, negative exponent just means it flips. So I have 1 over 2 x to negative 1/2, or even 1 over 2 root x.
Oh, this would be positive. So,
Yeah, you're right.
Here. Go back in the corner.
Yes, master.
Oh, wait, because
So-
you're blocking it.
So, thank you, Assistant Xavier Cheyenne. Now, the one other thing I will say to that is that Cheyenne is completely correct in the way that he's explaining it. But one thing, oh, bro, don't lean on this. Just don't lean on it fully. Is it,
Prove, what was this? Prove 1 equals 0, please. Okay.
prove 1 equals 0. I will try my best. Give me 1 second. So, one other thing is I recommend writing the exponents like this, because it just seems easier when you write your 1/2s, like minus 2 over 2, because it all lines up, you know?
Mhm.
That's just me, because I find this easier to read than that. Did you just crack open a Red Bull?
That's good.
No. This is why I've been able to go for almost 8 hours.
That's good.
Just feel the tension in the room here.
Vitamin B. What does vitamin B do?
Makes you the best. Okay.
Glycolysis.
So,
I need some
no
vitamin C.
radicals in the
Calculus.
denominator. No radicals in the denominator? Okay.
Now that's not always true.
Mackenzie, I want to tell you something. Your whole life changes when you go to calculus, because in calculus, in other classes, they will fail you if you have a fraction in the denominator or anything. In calculus, they don't care. As long as the other side is right, it could be the most unsimplified mess in the world. If it's right, they don't care.
Matter of fact, sometimes you have to move the denominator to the bottom.
Yeah. How did Mr. Hammer prove that 1 equals 0?
Mr. Hammer?
Oh, that 1 equals 0?
Yeah.
You can say it here, let me see.
Here.
So,
I'm gonna have assistant Xavier Cheyenne explain it.
okay, 1 equals 0. If I remember, you can
Sounds beautiful. Thank you.
I forgot.
No radicals, Mackenzie, because in
I can
cal
do 1 equals 2, I think.
no, oh yeah, do 1 equals 2. So, Mackenzie, because in calculus, it's just they're not really concerned in simplifying because they don't care about that. Literally on the AP Calculus exam, there's a rule where all the videos you'll watch will tell you not to simplify because it's wasting time, and also if you simplify it and you get it wrong, then you get the answer wrong. So you can leave your answer as like whatever ugly fraction you want, and if it's right, then you're good. That's one of the beauties of calculus over like Maybe some like fake class like AP Pre-Calc. Okay.
Let's do another problem.
So let me do my best to explain why. Interesting. Yes, it is very interesting. It's very interesting. Oh my God, guys, we're at 4 viewers right now.
Constant.
Yo, and
Guys,
I have one on my phone right now.
By the way, we've almost hit 8. We've almost been streaming for 8 hours straight.
We need to do something for
WK
8
loves.
hours.
At the 10-hour mark, we do shower. For you to clean up. We'll entertain the stream, you know.
We'll do a group shower if we get 12. if we get 25 people, we'll do a group shower.
How did you guys?
We'll move this into the
How did you
shower.
guys end up
Do
in my
candles.
house?
You
You
asked.
asked. You told
didn't
us to.
ask- you-
I all I said was, do you want me to get you something? You
I said I was coming, and you said yeah. Sean,
Hubba Bubba
come.
would be great. Clip it.
Guys, we gotta keep this PG-13. There'll be no group. Okay.
It's very
Anyway,
18.
so if we want to say, we could say like you would agree that 1 equals 1, right? That's like a pretty known thing. Get out of the frame. Get out of the frame.
Sorry, my bad.
Get out of the frame. Wait, I'm genuinely curious about how 1 equals 0. Yeah, it's a crazy phenomenon. So, if we have 1 equals 1, right? 1 equals 1 is the same as 1 minus 1 is equal to 1 minus 1, right?
Mm.
Right.
Mm.
Yes, Caleb.
I thought you knew math, Caleb.
Mm.
Okay, well.
Mm-mm.
Okay, so and then this would be the same as like 10 minus 10 is equal to 10 minus 10.
Mm.
Bet that.
Mm-hmm.
Now, 10 minus
Did
10,
you steal this from Fab Lab?
we can like take 10, factor that out, and we can say like this is 1 minus 1 is equal to,
He took that from my class.
is equal to, what am I doing in my life? 1 minus 1 times 10, okay? Then we can like divide by this, and then we get 10 is equal to 1 minus 1 over 1 minus 1
That earlier too.
times 10, and that cancels out, and then 10 equals 10.
This guy's good.
So, I messed up there.
Hey, we got 7 people. 3 more, and we take Caleb's tie.
Guys, this is supposed to be like, how long are you guys staying?
I'll stay until 7:30
What time is it?
max. 7 o'clock.
I'm about whatever, cuz. Also, did you take this from Fab Lab? Like,
No, that's my mom's.
All right, next one.
Ow!
You know what we should do? We should definitely do.
see who can.
We should do a velocity question.
Wait, hold on.
We should see who can blow the biggest Hubba Bubba gun.
We can see who could blow the best.
No, dude, actually, stop. We gotta keep this actually.
What, the Hubba Bubba, bro. We just bought it.
Bubba.
You have like a full pack. We're good.
Here we go.
Bro, you're wet.
Okay, hold on.
We're having a family reunion in the chat. What is this?
I think so.
Here, try and do this one.
Me. Okay.
Do this one.
Why all these derivatives?
Because practice makes perfect.
Okay. Alright. So, we have f of x equals 5 minus x over x cubed plus 2. So, when we're dealing with a problem like this, we can't just take the derivative. There's a very special something that's called
The quotient rule.
it's called the quotient rule. The quotient rule, famously known as high d low minus low d high over
low d high minus high d
low squared. But essentially, what we have is f prime of x.
Wait, Sean, you want to move a little bit? Do you want to give them?
Yeah,
wanna
you
move
good
a
angle.
little bit?
No,
No,
wrong
the
angle,
other,
wrong
like, you
angle.
need to give them space to read it. Yeah, like that.
Yeah, that. They can see it. G of x minus f of x times g prime of x over g of x squared. Now it's very similar to the product rule, except it's different because this is here and this is negative and positive. Shut up.
Don't tell my dog to shut up.
I'm sorry, I'm just joking.
Only I can do that.
Okay, anyways, so we have f of x, which, okay, this is, if I'm saying f of x, I should probably call this like v of x. So f of x represents this top function, g of x represents this bottom function. So we have f prime of x, which is 5 minus x. So 5 we disregard, so we're only worrying about this negative x. When we do the product rule, we do take it down. So we have negative 1, 1 minus 0 equals 0. So it goes away. So we have negative 1. Here, times g of x, which is x cubed plus 2. Then we have that all minus f of x, 5 minus x, times 3x squared over x cubed plus 2 squared. Okay, and then we have that equal. We have negative x cubed minus 2. 2 minus 15 x squared minus 3x squared, which will eventually do something. Then we have x cubed plus 2 times x cubed plus 2. And then we can bring that over here. And then we get negative x cubed minus 2 minus 12x squared all over x to the 9th or x to the 6th plus x cubed 2x cubed plus 2x cubed plus 2x cubed plus 4. So it's going to be 4x cubed plus 4. 4x cubed plus 4. And then that will eventually equal negative x cubed minus 12x squared minus 2 all over x to the 6 plus 4x cubed plus 4. Which is probably an answer.
Is there another problem?
Do another problem.
Is there another problem?
Let's see, Merrick, are you going into calculus next year?
Yes, I am.
Merrick in calculus. So here, okay, we're going to keep doing calculus then. I want to find an... Ooh, this is interesting.
Sean, what would you give me if I end up streaming till midnight?
Oof.
What would I give you?
Yeah, you said you give me a reward.
I'll give you therapy, bro.
I would give you an award.
I'll give you a hug.
I mean, we're at 8 hours now. I think I can make it to 12 hours.
Told you 12 hours.
Do you want
Okay,
food or
if
something,
you do
bro?
12 hours, then I'll do... Oh no, that's not really an award. We could do some sort of handicap. Like whatever question you get wrong, I have to do the challenge.
My gosh. Okay, wait. Hold on. Just keep doing a problem. I gotta go. Just keep going.
All right, do something that. What's something that you would like?
Trusting you guys.
Uh huh.
Yeah, for sure.
Yeah.
Yeah.
Yeah. Yeah.
There's 2 viewers
computers, and I think it's my phone and his computer. Hey, we had like 9 though earlier when I was
We did.
watching, bro. I could have got here when you guys did the ice bucket. I was at the gas station and I got Red Bull. You gas station. All right, I'm ready. What is
Okay,
this?
so this is really more. What does integrals mean?
Mhm.
So, fundamentally, what is an integral? Do you have any clue in the world?
No, I've never heard in my life.
Never heard of an
We
integral.
didn't reach that.
Have you seen the squiggly sign?
I've seen the squiggly.
What does that look like?
Looks like a little S.
Looks like an S.
Yeah.
Right.
Mm.
What would S entail?
What would S entail? I think that's for teacher. I need help. What is
Sum.
Sum. So it's addition.
It's addition.
Okay.
So what we're doing is when we're talking about an integral, we're looking at like very fundamental basic explanation. We're looking at an area under a curve. So we're starting like this. You know, whatever, like this or something.
Mhm.
What we're looking at in a derivative, we're looking at a slope at a single point. Okay?
Yes.
This is a derivative.
Okay.
When we're looking at an integral, we're looking at this area under the curve.
Okay. So integral is everything under the graph.
Everything under the graph.
Okay.
And then it has its own kind of contextual application.
Mhm.
But fundamentally, when we're looking at curves, this is what an integral means.
Question:
Yes.
does this reach under the x-axis as well?
Okay, so it depends. If we have something that goes like this,
Mm-hmm. Oh, I see. So it's only going to the absolute
Then-
lowest y value.
absolute lowest, yeah, until the x-axis.
Okay.
And then here, if we have this, then it'd be this area.
Oh, okay. So I see. When it passes the x, it switches.
Yes. It's just
Okay.
basically what is in between this point and this point.
Okay. Perfect.
And that's very important. Because then when we start looking at, basically what are integrals, how do we solve integrals,
Mhm.
there's this thing called a Riemann sum that he did earlier in the stream. But basically, a Riemann sum says if I were to approximate an integral, let's just get rid of this whole thing. If I were to approximate an integral, I can use a bunch of little rectangles.
Okay.
So if I have just a very simple graph, x squared. What I can do is I can take it from the right, but I can also take it from the left. What that means is we're starting this.
Mhm.
Boom, we're going up. So here, like something like that. Here to the next
Okay.
point.
Oh, I've seen this before.
Here to the next point. Here to the next point. And yada yada.
Yeah.
And yada yada. Okay. So what we're looking at here is we're taking this sort of like interval where we're like going, say this is like 2, 4, 6, 8, 10, 12, whatever. We're drawing up from there, and then we're going to like some sort of point, however the hell you draw it, I don't know.
Yeah.
But this is basically like the most general idea of what a Riemann sum is and what an integral is. So what we can do is we can take this length and this length, say this is 2 and this is 2,
Mhm.
and then we can have this area 4, and we can do the same thing with each one, say this is like 8 and this is like 16, 24, 32, 24, something like that.
Yeah.
And then we can add them all together, and we can get some sort of approximation of the integral.
Okay.
So that is essentially what an integral is in the most fundamental when we're talking about curves.
So it's almost like the area of the curve.
Under the curve.
Under the curve.
And that's basically it. And then that has more applications further down the line when we're like, you do like cross sections, so you have like this like shape, and then you can say like, okay, I want to have a cross section, or I want to make like a 3D object that's like a semicircle, and so you can make like super cool shapes, and essentially you can calculate the volume of any shape whatsoever. which is cool. So in this problem, it says if the integral from 4 to negative 10, so if we're drawing some sort of random shape, like this or something, so, ooh. This is 4, around 4, and this is like negative 10 or something.
Okay.
We're saying that from. Okay, so realistically, what you do is you have the most negative number on the bottom and the most positive number at the top. So what you do is you can change this, swap it, and they just make it negative.
Okay.
So what it's saying is essentially the integral from, or the negative integral from negative 10 to 4. So this whole area is negative 3. Ends up to be negative 3.
Okay.
So this area plus this area is going to be negative 3. And 4 to 6, so it's a 6. This ends up being 5. Then what is the integral from negative 10 to 6? So we know the integral from 4 to negative 10, the is negative 3, and the integral from 4 to 6 equals 5, then what is this? So what we don't know, or what we can do, is sort of create this equation where we have negative, so the negative of negative 10 to 4 plus x dx plus the integral from 4 to 6 g of x dx equals the integral from negative 10 to 6. That's all it's asking. And that's all we need to do. So we know that this is going to be negative 3 plus 5 equals the integral from 10 to 6 g of x dx, and then that's going to turn into 3 plus 5 equals the interval blah, blah, blah. And then so it turns into 8. So all we're doing is we're saying we're given this information that this equals negative 3 and this equals 5, so it's this whole thing equals negative 3 and then this whole thing equals 5. All we are doing is we're adding these two together and then we're finding some sort of number, and then obviously since this is backwards we'll have to flip it, make it negative, and so this is going to turn to positive 3. 3 plus 5 equals 8.
Okay, perfect.
Let me take it back over.
Alright.
Okay.
I actually learned. I feel like that's gonna be useful next year. I'm probably gonna remember that.
Okay, I just want to say a word to the stream. Okay, let me see. So
One last next bucket.
no, I'm not done. We're not done yet. So I do want to say something because like for me this stuff is actually important to me. Get out of the frame.
Hey.
It's important to me too.
Oh wait, hold on. We gotta actually the sun's like going down. We gotta actually like
Oh, there's 4 people.
oh Sean, get out of the frame.
Producer tag.
Yeah, that's my producer. Yeah, I'll keep that there.
Producer tag. Caleb on the beat.
No, I do want to say like we have hit 8 hours.
That is one whole school day.
I know it's a whole school day. No, I know that probably I would say around 7 hours of this whole stream I was actually doing pure math, but a few things may have distracted me along the way. But I'm honestly very impressed with myself. I did not know how long I'd be going. I'm still gonna go on for a little bit longer. I just want to say a little message to like the few people. So
Tune in next time for the July 4th Bozanga stream.
okay, so let's keep going.
For every problem he gets wrong, he has to set off a firework in his house.
Okay, yeah, let's
I think Miranda finally logged off.
okay. So this one says I'm gonna die. So this is the integral of 0 to 2 of x cubed plus 1 1/2 x squared dx. Wait, let me just see like how you're so tough. Thank you, Woxy. I appreciate
You are
it.
tough, bro. I do believe that.
Bro, why does Caleb's brother low-key mog?
W. Caleb's brother. W. Caleb's brother.
W. Caleb's brother.
It actually does kind of look like your brother.
Who's Caleb's brother?
You saw when they're talking about Cheyenne.
No, Sean just got everything. Okay, what can I say?
He's got everything.
So, anyway, I might have to switch to a darker color. This is getting harder to see. The sun's going down. That's how long we've been doing this. Anyway, so the integral from 0 to 2 of x cubed plus 1 to the power of 1/2 times x squared dx. So it's looking like we're gonna have to do some sort of u substitution here. So I'm just gonna start off with trying these things. Usually with integrals, and you're gonna be doing when you're doing u sub, it's all about plugging and chugging. You just gotta try out some different things, and eventually, with enough practice, you'll kind of have a feeling which things are the best to use for u substitution. But there's no substitute for practice. So let's go. So we have u is equal to x cubed plus 1. Du is equal to 3x squared dx. So then du over 3x squared is equal to dx. And now if we try to plug that into our function, we have the integral from 0 to 2 of u to the 1/2 x squared du over 3x squared. So if you notice, these x squares cancel. We can pull out this 3 to the other side, and now it looks like something we can actually differentiate. However, there's one last step, and that's changing our bounds, the 0 and 2, in terms of u. And the way to do that is to literally just plug them in for x up here and see what we get. So we plug in 2. 2 cubed is 8. 8 plus 1 is 9, so I'm just going to erase this and write 9. Now we have 0. 0 cubed is 0 plus 1 is 1, so then we have 1 to 9. Now we can write our integral as 1 over 3. Pause that. Integral from 1 to 9 of u to the 1/2 du. Okay, and then now we can just integrate that. So 1 over 3, the integral of u to the 1/2. So 1/2 plus 2 over 2 equals 1 over 3. 3 over 2. 3 over 2. I'm gonna kick you guys out of my house.
I haven't done anything.
3 over 2, and then dividing is the same as multiplying by the reciprocal, so we're going to multiply this by 2 over 3, u to the 3 over 2 from 1 to 9, and since we changed our bounds to be in terms of u, we can literally just plug this in, so I'm going to save the, actually no, I'm going to multiply this out, so then we have 2 over 9 times, so 9 squared is 3, 3 cubed is 27, so this is 27, and then 1 would just be 1, so 27 minus 1, which would be 26, so then 26 times 2 this doesn't look right. Oh yeah, so 26 times 2 is going to be, wait, I might have done something wrong. Can you guys stop?
What? You're saying you guys. It's one person, right?
Like,
I'm over here. I'm over here again.
so it's gonna be something like this. Okay, stop. Seriously, come on.
I'm sorry.
I let you guys
I'm
into
trying
guess-
to listen. I'm trying to listen.
I let you guys into guesses in my house. Okay.
I apologize. While I'm trying to listen.
Seriously. Okay. More problems.
There's two more problems right here. Yo, don't worry. We only have like 2 hours.
Caleb, number 3 on your leaderboard.
Great. The problems are light. Do something
Ooh.
Who's Burger?
Yeah.
Who's Burger Gaming?
I have
I
no
have
idea.
no clue.
I don't know.
Like, I'm serious, I don't know.
It's your friend.
Okay, what kind of problems do you suggest then? Burger Gaming 101.
Why do you have to sound so hateful?
Burger King.
Dude, it's been over 8 hours of this. Okay.
That's not it. Geometric series.
Oh my gosh.
Geometric series.
Geometric
bro.
series. I haven't done a serious
Convergence.
question in a while.
Convergence tests is what
Oh my
they
gosh.
said.
Okay, how about this? I'll do a limit comparison test and then convergence. Yeah, okay. I'll do a limit comparison test question, okay?
Someone said, "Oh God, hit some
Okay.
quadruple chain rule."
Quadruple chain roll. Or else poker stick. Bro, you still haven't even touched your lemon. Or your pepper.
Dude, yeah, after the salt water.
Have you tried the treadmill challenge where you do math on the treadmill?
Dude. That's an extreme.
Next stream.
That has to be
doing
an
math until
extreme.
my legs give out, so it sets like a.
Or
timer.
no, every problem you get wrong, you have to up the intensity.
Oh yeah, up the slope and then you start upping the speed.
Yeah. That's
a
actually
great
tough.
calf
That's
workout,
actually tough.
That'd be good. We're just talking, because it's some downtime in between questions.
Oh, Anga hit some quadruple chain roll.
Wait, were we mudded? What happened?
I didn't know that was from the. I didn't know that
Oh,
was from
yeah.
that.
And we're mudded.
Okay, fine. Let's do this. Okay, so we have,
How much caffeine is this?
At least one.
I don't know how many are in 4. That's how many I've had.
4?
4?
Oh yeah, you can see the pile in the back.
Brother.
Hey, it's been 8 hours. He needs it.
We had a lollipop.
Of
Oh, it's only 80 milligrams.
That's great. That's
It's
fantastic.
Wasn't quite so big.
I was gonna ask that earlier, but I was like trying to keep it PG-13.
It's actually an issue.
It's an issue. All right, suffering from success.
you guys can go to my room if you want.
I thought you never asked.
I'm having the full learning experience
Okay.
right now.
So, okay, it's been a second since I've done some limit comparison tests, so this is gonna be a fun little thing. So, like, I know that this is gonna be our a to the n, and we need a b to the n, and b to the n is basically going to be. Oh no, it's n plus 1. It's what?
Coughing. Now that you feel good. Because the math is it's so sick. Okay. Hold on, bro.
You know, I don't think you can do it because you're taking so long.
You gotta prove Burger Gaming 101 wrong.
It's hard. Sorry, I haven't done questions like
No, you're
these
good, you're good.
in a
Take your
while. Shut up. Guys, just go to my room at this point.
he just put you in timeout. Like actually.
Go to my
Go
room.
to your room.
Go to my
your
room.
Fine, mama!
Oh my gosh. Okay. Nah. Okay, so this is basically the same as like what? You could do like the square root of n squared over n cubed plus 9, which would be like just n.
What is he doing?
Can you make sure he's not breaking something in there?
Yeah, I got you.
So, wait, actually,
That is good.
what is he doing?
Your train still's gone.
Wait, no, dude,
No,
I
I'm
think
kidding. I'm kidding.
Wait, is this the correct limit comparison test? I don't even know if I'm doing. Hold on, no, I'm not gonna do this one. I think I'm doing this wrong.
Ooh, they're saying put a time limit on you. Would you want that or not?
Put him on
The people are saying.
pump clock. What do you do? Stop.
Would you want like 5 minutes or
Do you want a timer? I got you if you want it.
No, because I'm trying to find. I'm trying to do like a specific type of problem that I know.
He's on the guitar. It's background music. It's fine.
Well, I'm gonna find a different problem. It's not.
This is no. He didn't know punishment.
I did not know. Yeah, I haven't done these in a while.
Wait. So is it every time you don't know a problem, you're doing punishment wheel? Is that what that was?
Dude, I'm done, man. I'm done with this. Who is it? Punishment, bro. Burger Gaming 101. Wait, what are all the series tests or conversions tests? That's what I forget. What are all the conversions tests? Convergence tests. Oh, it's the ratio test. Okay, my bad. Burger Gaming 101. I want to do the ratio test. Okay. Ratio test questions. There we go. My bad. I looked up the wrong convergence test and I forgot how to do some things, so. Don't even trip, bro. Okay, so this one is 3. Okay, so I believe it's like, yeah, so it should be the limit as n approaches infinity of a to the n plus 1 over a to the n. So then this should be the limit as n approaches infinity of a to the n plus 1, which equals 3, 1 minus 2 times n plus 1, which is 2n plus 2, which is 2n plus 2, which means that this is basically just 3 minus 2n over n plus 1 squared plus 1 times the inverse of this plus 1 over 3 1 minus 2n. Also, Burger Gaming 101, I do want to let you know that I will do a doing calculus till I cry stream, and for that I will prepare a little bit more because I haven't done actually any sort of calculus since AP season was over, so I'm a little out of practice. What?
Oh, yeah, I was watching.
Okay, make sure it doesn't break my guitar.
He's not. I'm gonna check.
Okay, so now I know that we can cancel some things with this, I believe. So, what actually would cancel with this? Or maybe I shouldn't have. Wait, I should just like leave this as this right now. And then. Oh, so this 3 to the power of 1 cancels. Who is it now?
You want me to check?
Yeah, sure. Wait, no, but there might not actually be anyone outside.
He's not like consistent
Okay, so then I have. He's not really a stats guy. Who? I don't know who you people are.
Caleb, you did take stats, right?
I did take stats.
Yeah.
Bro, Caleb's just my stage name.
Yeah, no, that's not your real name.
Yeah, it's
we just
not-
call you Caleb.
It's called.
That's
Everyone
why I
just,
call calculus with Caleb.
Yeah.
Because it was so convenient for the
Yeah.
title,
Yeah.
His real name was Libby Tingleton.
So now, I mean, I just know that, like, we have this, right? And then we have to, like... No, I forgot how fun these questions were. I'm gonna do another live stream sometime, like, maybe in a few weeks. Because I'm gonna be going away, and I want to, like, literally just do... Ooh, that's good. A live stream of just serious questions, yes. Yeah, okay. Guys, seriously. Okay. So I know that we have to, like, eliminate some stuff from this. So I know that, this is the same as, like, 3 to the negative 1 times 3 to the negative 2n. And this is the same as 3 to the first times 3 to the negative 2n. So I know those cancel. So, this cancels with this. So then I have for sure 3 to the negative 1. And then I have a 3 to the first, but this negative 1 will go down into the denominator, and then it becomes a square over here, yes. So, okay, cool. So that's progress, So I know this is going to be equal then to the limit, as n approaches infinity, of 1 over, actually, I don't know if I can eliminate anything else. Because I know this is going to be n squared. I don't know. Actually, hold on. Because if I just leave this as n squared plus 1 over 3 squared n plus 1 squared plus 1. Wait, shoot. So this would be plus 3 squared again. Be something like that, but something like that doesn't add up fully. I don't know. I'm trying to look at some. Oh wait, I guess I had it right. I guess this is right, and then you just factor out the 9. I'm just gonna move this up here. Of and I guess the way they do is like this is basically the same thing as 1, so then this would be equal to 1 over 9. Oh, because that will go to 0. And 1 over 9 is less than 1. You know, guys, I think I might end the stream. We went for 8.5 hours. So I don't know. I'm kind of tired. I don't know. This question was a little rough, but I think yeah, Burger 101, did that satisfy you a little bit? It was fun. You're broken down yet? Woxy, I've been doing this for 8.5 hours. 8.5 hours. Sorry, I have chat opened up right here. I know it should be 8.5 hours. I think I might be done. I don't know. Uh, Shalom, yes, I did, man. I recorded it. I'm going on the floor. I'm going on the floor. I don't. Yeah, I think I'm done. I can't. I don't. I don't know. Guys, honestly, yep. I think this is it, guys. We had a very good run. All right, I want you guys to know that I will be doing another one of these. Next time it's going to be doing calculus, specifically till I cry. I might be trying to do more BC questions. But we went for 8.5 hours. There were a few people. Mimi's Ocean, I wanted to shout you out. Cat's Tutoring. You guys have been here since the beginning. They're not here right now, but they were here for the majority of it. So I want to thank everyone who came, everyone who liked, everyone who subscribed. I think there are like 2 or 3 people who subscribed. I do plan to make actual high quality videos of explaining calculus topics. This is just something I wanted to do. I just want to do a lot of math. I know we kind of got distracted towards the end, but even though the stream was 8.5 hours, I'm gonna clock it in that I did a good 7 hours and 40 minutes of just straight math, and then there's like give or take about an hour of just like breaks, eating, and some messing around with my friends. So thank you to everyone. I might post the VOD. I don't know. It's just like it's a lot. So I will see all of you guys later.